Okay, okay. Awesome, awesome. How do I? Hello? Okay, cool. Morning, everyone. Thanks for coming to my session. And yeah, before I start, I'd like a quick show of hands. Has anyone heard of this thing called Prometheus? Like this thing, yeah, okay, cool. That will be relevant later. So yeah, the title of my session is Thinking Outside the Classroom, Building an Edge Device to Monitor Atmospheric Conditions. Unfortunately, my co-speaker was unable to make it, so I'll be giving this talk on behalf of both of us. All right, so who am I? My name is Jubril Etunji. I like to describe myself as a developer who likes to write, not just code, but also blogs. I'm interested in all things cloud native, and I write Terraform providers every so often. Cool. So this is how this talk is going to go. We'll start by describing what, the why, how, and the results we achieved. Cool. So first off is the what. That would be NASDA. Not to be confused with NASA, but back in Nigeria, we have the National Space Research and Development Agency, which is focused on space research in Nigeria. So about 2 years ago, they decided to start clubs, which is basically to foster interest in space research in universities. And my school was one of the few that was selected in Nigeria. Cool, so the why. This year, we noticed my school was expanding. We were having more buildings, and we decided to pause some of the space-related research and take a look at problems in our environment. So that was the first reason we started this project in the first place. Diesel consumption was up as there were more buildings. We had to run a generator to power the school. Degrading air quality, it got worse, and people with allergies, such as myself and other club members, could notice that the air quality was worse. And in order to say we have a problem, we have to visualize and quantify the problem. Cool, so the how. The first thing we needed to do was build a prototype. We kind of had the problem in mind, or the problem we're trying to solve, but now we needed to build a prototype to prove, for basically a proof of concept. So we gathered these materials, an ESP32 because we're going to be doing things with Wi-Fi, temperature sensors for temperature sensing, DHT11 for sensing humidity. I forget the names, but we had a carbon monoxide and dioxide sensor. MQTT, if you're not familiar, is a message bus which you can use to publish and subscribe to messages. In this case, this was going to be sensor data, and the edge is basically this kind of Raspberry Pi. Cool. Yeah, so at this point, you're thinking, oh, well, this is fine, but where is the cloud native? Well, this is a real image of me suggesting to the entire club that we use Prometheus. And, we have metrics, we have Prometheus, so we might as well bring in Grafana to visualize this stuff. Cool. So what we ended up with was an architecture that was something like this. We had the ESP32 and the sensors hooked up, and that was publishing all the data or the values collected to MQTT. And I hacked together a horrendous Prometheus exporter to get these metrics into a format that Grafana can visualize. Cool. So the results were something like this. This isn't exactly live data, but what we ended up with is we're able to detect CO2 in the last hour and by how much it's gone down. We're also able to visualize how much data we've collected over a period of time. We're also able to display safety values for the air quality. And the idea here is we're going to deploy this device to various locations in school. And as such, if we ever have efforts to cut down on our emissions, we'll be able to visualize the changes, hence where the edge part of this talk came in. So what did we learn? Well, hardware is hard. There were many problems because a wire could be missing. There's no compiler to tell you you don't have the right wire plugged in. Networking for IoT is weird. You have an ESP32. You need to figure out how to get that onto the internet, but at the same time, you don't want this to be like exposed to the main internet. And yeah, networking for IoT is weird. Bonus is, I think in the talk about 10 years of Kubernetes, the speaker said, Kubernetes is also about the community. And I think this is true. I'm here because the organizers thought this talk would be cool enough, and I am able to speak about these things. And as such, for the club now, people after me would be able to learn about Prometheus, even if it's for the first time, and learn about Cloud Native one way or another. So that's what we learned. If you're hiring, we should talk. And thanks for listening.
Check, check.
Okay, perfect. Thank you so much for this talk. That was very interesting. I have a question related to security. I'm curious to know if you have explored any TLS encryption or stuff like that in your project.
Yeah, so security was not exactly top of mind because we needed it to work first. And I know this is really bad to say, like we needed it to work first before we thought about security. But what we did do is ensure that the network is closed. So the network we're using was like separate from like the main school network. And the Raspberry Pi we had that deployed to, I made sure like it was locked down and only the ESP32 could talk to it. So that was the most security we did.
So you said the goal was to deploy them all around the school. How many did you get out there? Did you kind of accomplish that? Did you?
Actually, we had just one device, but the idea is like if it's good enough, we will be able to replicate this. Yeah, so we just had one in one major area.
That's a start. That's all. Yeah, that's how you start with one thing, right?
Yep.
Do you have any pictures of the device?
Yeah, I actually didn't take any pictures. I forgot to take a picture, but I did bring like the Raspberry Pi.
Any more? Okay, that's it. Then thank you.
All right, thank you very much.
I think. What's your name?
Next round of talks are starting in 1 minute. Talks start in 1 minute.
Why is it this way?
I'll give you 5 minutes.
Question. Okay.
You can choose to have 5 minutes of questions or 2
Yeah.
minutes of questions or no questions.
Okay.
That's up to you.
All right. I think I might, don't know, might be.
We're going to get started. So Priya's going to do the next talk. I'll let her introduce it. But everybody, a round of applause for Priya.
Hey. Hey everyone, can you hear me? Yeah, okay. So I'm Priya. I work for Microsoft Azure and specifically for Microsoft Azure Cloud Shell Service. You must have used the shell. I call it like the humble hobbit of all services. Today I'll be talking about something very foundational, which is the migration of distributed systems infrastructure. So you're migrating something in the cloud. I'm not going to be talking about on-prem to cloud. This is about cloud native and how migration is a constant. It's kind of a foundational thing there. And some methodology and insights from that. So, so this is more like an engineering management sort of a question as to why do we need timely migrations, right? So any infrastructure reaches its constraints over time. It could be that the infrastructure, somebody stopped security patching the infrastructure, right? Or somebody changed the way networking works, the networking stack works in the infrastructure. So it requires a timely migration to avoid getting into this vicious cycle of tech debt, where your team is like, it evokes a fear in anyone trying to touch the system, and then it feeds into this, it reinforces the belief that change is futile. Like, okay, I got to rewrite this thing, right? So neglecting or rather procrastinating migration makes your team work on maintaining an existing infrastructure, and sooner you know they're hamster wheeling to stand still, right? So why can it be intimidating? So revamping the back end of a widely used distributed service can be a bit daunting. It's a serious undertaking because your current service that's running right now, it's battle tested, it's developed some robust resiliency practices, it's gone through on-call, it's gone through site reliabilities, and then it's up and running. And trying to revamp that infra into some other infra can be a bit of a intimidating process unless you have like a measured risk methodology, right? Where you say, okay, here's a low risk methodology. I can start cautiously, and then I can proceed. So I'm going to talk about the methodology a bit, but then within cloud native, you kind of depend on other services. A service depends on other service. Let's say, some serverless service may depend on storage, for example. These are all services interplaying with each other. And when there are serverless services involved, we all know that debugging is a bit of a challenge. You don't get that much flexibility into debugging something unless that service gives you the monitors to monitor it. You have no idea what's going wrong unless there's an exact monitor for this. So how can you kind of guard yourself against these things, right, when you are using these services and in a migration context? So here's my methodology. I did migrations of infrastructures, and when I started, I was like, where do I start, right? So I thought, like, let me put a methodology as to, this looks like an expedition to me, because this is going to be a while, because I have to, it's a widely run service, right? So I look at it as an expedition. So you chart the course, and then you say, like, okay, here's where I start. I will set up an A/B experiment or a traffic redirection experiment first, and then I will identify a path, like how am I going to roll out this thing region by region, right? Because you have cloud in so many regions, and what's my rollout strategy? After figuring that out, the meat of my talk is going to be designing a compass. Basically, what are you going to measure? Because you started migrating your infrastructure, and what are you going to start looking for to make sure that things are going right? What's the first thing we do? We go and check if it's parity, right? There's some service running on your own clusters, and then you're migrating it into a serverless or managed service. You would ensure parity. That's the first thing you would ensure, but what else can we look out for, right? And then how do you reach your destination, which is you complete your migration with no downtime, right? So that's what I'll be talking about. So let's start with charting the course, right? This is like an older infrastructure A, okay, which is your cluster, and then you're going to migrate to this new infrastructure. I kept it very generic on purpose. If there's any specifics, we could chat about it, but this is mainly to help everyone kind of get a sense of their own infrastructure and put it into their context, right? So let's say this is like your own self-managed clusters, and then you're migrating to a serverless infrastructure. Basically, you used to have your own VMs, and now you started migrating to a infrastructure, which is when you request for a VM or container, it's going to give you, right? So that's the kind of thing that you're going, let's say. And you have a client there, and you can build your own service API B. So this is the one that's in production, right? Serving out of old infrastructure A. And you could build a service API B, and then your client can do an A/B experiment where it can send a portion of your traffic to B. And this is what typically people do. There's a whole lot of front end which does this kind of architecture. But what I like is basically putting the A/B experiment layer over here with many of your tools that are available for feature flagging. And CNCF's got some tools. So you can put the A/B experiment at the service API level so that a portion of your traffic goes to B, to the new infrastructure. This is helpful because in cloud native, it's not necessary that the whole infrastructure is getting upgraded. There are portions of your infrastructure, like say network stack, that's just upgraded. Something's reaching end of life. So it can help you be more granular. And then next, identify a path, right? Now, just figure out a plan for how are you going to roll out this A/B experiment in different regions. I just put a very, generic region, but you could have many factors on how you're going to roll out. But identify a rollout plan, and then let's get into this compass, right? So the first thing that was beneficial to me when I was doing stuff was like, how do I know if this thing is fully working in production? So I've tested my AB infrastructure in my pre-production, and I rolled it out to production. Now, this is very typical, right? You send all your traffic to your old infrastructure, and then portion of your traffic, you can tune how much it is. Maybe, let's say I started sending 5% of my traffic to the new infrastructure, and it failed, right? Something happened here and it failed. The first compass that you could design is you could fall back to A because you got to serve the customer. So you fall back to A, and then you emit a fallback metric. And this is a good compass to have, and it's kind of a basic foundational compass to have, like how many times is your service actually falling back because this thing failed, right? So that's one of the things. Infrastructure health. This is a kind of an interesting topic because let's say your service is requesting a resource, VM, storage, compute, whatever, from a managed service, which is your serverless, and then it's requesting this resource. Is this resource going to be fully healthy till the end of its usage, especially in the context of ephemeral resources, right? Not long-running ones. Like, let's say, even looking at the shell, right? It's an ephemeral resource. So is it going to be healthy till the end of its usage? Which means, is it going to have healthy network connections? And you typically know that in any managed service, you have monitors that will measure CPU, that will measure network connections, that will measure disk. You have all of those physical monitors, is what I call them. They tell you that this is in good shape. Whatever I return to you, that's in good shape. But what I would suggest is try to put some logical checks to understand if your resource is healthy. For example, I returned a VM, and it's supposed to derive its DNS settings from the customer's DNS and not your cloud's DNS. Is it going to do that? Is it doing that till when you returned it to the customer? Was that set up properly? So those logical parts constitute health, because what happens is, so here's another example, like, so you have a VM. Is your ingress, egress connections, are they okay? And what are the metrics that will tell that this VM is healthy? Not just from a physical point of view, from your use case point of view. When you're a service engineer or a cloud engineer, like how is it healthy, right? So put this metric in place, and then when there's problems, when you suddenly feel like something's going on that I don't understand, but your managed services monitors is telling that your CPU is healthy, your disk is healthy, so what's going on? This kind of a metric is going to help you understand those kinds of use cases when you migrate, right? Because you got to always watch if things are going right. So in such a case, when you zoom out, I'm going to give a real example. When you zoom out, you will understand who is healthy and who's not healthy, more than alerts, right? So this is an example where a resource, a VM, was supposed to be fully connected, like constantly having connectivity for about 6 hours from the time it was returned to the customer. So the customer requested a VM, you returned it as a cloud, and then for 6 hours it's supposed to be healthy. But then it wasn't. It's intermittently healthy, you know what I mean? So here, if you look at this is a graph that shows the network disconnects and a resource not being healthy. And when you zoom out and put these kind of scatter charts, that's very helpful to identify the picture, right? And typically, when you're having managed services, they are running it in big computes with multiple tenants and stuff like that. So if one of the resources takes too much of of the underlying compute resources. For example, in a node, one of the pod takes too much of bandwidth or is starving the other pods, you have a noisy neighbor issue, right? And it could be, this is fascinating because it could manifest in any way. So zooming out helps. And here's an example is once you go fix it, once you talk to the service and then you raise incidents or whatever and you fix it and you get them to fix it and you can see the difference, right? All of them are having a healthy lifetime. Like they all are healthy up to the 6 hours that you wanted them to be healthy, or 4 hours or whatever. So zooming out in a compass is super helpful. So a noisy neighbor by itself is very interesting. So if I want to just share, so one of Azure's, Azure public documentation has a noisy neighbor pattern, which is there. If you click on the link, it'll take you there where it'll explain what are the different scenarios. People do upgrades all the time. So if your managed service upgraded its OS or kernel, and that changed something like something at the network level, you could see disconnects. So these are things that you might want to think, okay, is my service actually seeing these issues, right? So yeah, and these things are very hard to debug, and it can really eat up your time. So it's good to have a compass. And it's nice to keep local health probes rather than go to the cloud and use its control plane to kind of ask for health of a VM, right? Have your own local health probe. This is a debatable topic from a design point of view. Some would say, I want everything to go via my control plane. That way I have good visibility, security. There's also, from an SRE point of view, you could look at the local health probes and see if it actually came up. You could set up your local metrics with your favorite monitoring tool. And when you have a service-to-service interaction, please keep in mind the service limits, and of course, rate limiting, exponential backoff is all implemented by most services, but any of your services bombarding another service with a lot of requests, as scale increases, needs a bit of a rethink. So it's best to kind of honor service limits, and as part of the service limits, factor in retries. So retry is a big topic where you can either kickstart a retry storm and totally eat up your service limits, or you could look at how many times you're retrying. Is the retry logic pretty solid in my service? There's also an Azure documentation on anti-pattern documentation, which talks about retry storms. It's public documentation, and I can put a link to that. And of course, there's many verbs, right? There's get a VM and put a VM, or so each of those verbs have service limits. So every single thing in part of your entire infrastructure has scale limits. So let's say you're requesting 200 VMs. They all need to have IPs, and there are scale limits to these things. IPs have scale limits. If you have a virtual network, that's public in Azure. You have public documentation that says, here's your limits for your IP addresses. So sometimes the way a managed service may handle is it may just be continuously retrying to get an IP address, or it may not have good indicators that I can't find an IP address. Let me just continuously retry, and you would have no idea about it. So try and have these scale limits in mind and ensure that each of these, small aspects of your infrastructure, I won't say small, it's something that's easy to overlook. And so just remember that every small thing has scale limits. And then let's say you put a graph of all of these things that I discussed. You can start tuning it, and you can look at the fallback metric. okay, I sent 5% of my traffic, and I saw like 10 of them fall back. So, or a significant percentage of them fall back. Go back, debug it, and then fix it with, put some right compasses to measure that going forward, and then make sure your fallback is continuously coming down, right? Increase the traffic percentage, measure your fallback. So how does your service fare with the new infrastructure? That's what this is telling you. And now it's just a bunch of knobs, and then you're tuning your migration. So when do you call your migration complete? So you can say the fallbacks are 0 over a period of time. All traffic is accounted for in that region. This is kind of interesting because I've listened to quite some people say, okay, this traffic is not important, or a specific percentage of the traffic is just test traffic. So make sure your entire production traffic is accounted. And of course, parity, that's the first thing people focus on. And then you can just rinse, repeat this whole process for the other regions. So using an A/B experiment armed with a dashboard that acts as a compass, being mindful of these things that I said, and configurable parameters that could be like tuned, you can just do a successful migration and call it complete, even for the most granular things that you're going to migrate. Yeah, so there are parts of this talk that are like specific to certain resources, and each person's cloud or whatever they're migrating could be very different. But I think the framework could generally be helpful. And with that, thanks for listening to this presentation. I'll be very curious to hear if you have any migration stories that you want to share. Please feel free to chat with me and reach out to me. And I'm open for questions, yeah.
Do we have any questions? Going once? Going twice? All right. Thank you so much.
Thank you.
Hi, everybody. We're now ready for our next talk. Carson's going to be giving this one. So let's start it off with a round of applause.
Make sure it's in the record. There it is. All right, I can tell now. It is on. All right, so thank you everybody for coming. If you are here for have half the service mesh with half the mess. Try to say that 10 times fast. In fact, I think going forward, I'm truly tempted to have the titles of all my talks be tongue twisters. Because if I get it right, maybe you're impressed. If I get it wrong, then I'm humanized. And so I don't know how I can lose doing that. My name is Carson Anderson. I work for Weave, not that Weave, and I'll get to that in a second. At Weave, I'm a principal engineer. That's the official title. But I prefer my made-up title of DevXO. DevX for the developer experience team that I'm on, and XO because I'm the executive officer. I consider myself the executive officer, the person in charge of making it so, the person in charge of getting it done for the developers at Weave. And that's where kind of all of this experience comes from and my main motivation for this and the things that I build for our developers. So let's get into it. Speaking of Weave, I just bring up a slide to say thank you, Weave, for letting me speak. And also, it's not the Weave, it's not the Cloud Native Weave. They're now defunct. We're a different company. We're an end user. None of the things I'm going to show you are a product pitch. I just want to talk about problems and solutions and share the things that we've done and kind of get your brain juices going on solving problems. Speaking of problems, let's talk about the problem I want to solve today and show you how to do that a couple different ways. So here's a very, very simple diagram of the problem. There's two problems in this diagram. I have a client. We're going to write the client today, and I want it to talk to this nebulous idea of service. And I want that client to have one problem of service discovery. Right? I don't want it to have to know even a DNS name, if I can avoid it, of where the service lives. I just want it to talk to service. I also want this second problem of customized routing. I want to be able to, on the fly, distribute load. If you're here for the previous talk, one of the things you have to do is start spreading load around, and I want to solve this problem. These are the two problems I want to solve today, and focus on just those problems. If you were going to solve this problem, and you're at this conference, you might immediately reach out for service mesh solutions. You'd go to the landscape page, you'd pick some of the big ones, because they're all going to solve both of those problems, and a heck of a lot more than just these two. So of course, why not just use one of the service mesh products, right? Like, there's these amazing products out there. Why wouldn't you use those to solve these problems and all the problems you might have in the future? The bottom line for me is it boils down to scale. Here's an overview of the CRDs that come with Linkerd, which is one of the top two. There's a lot of stuff in here. That's not to say they don't need these or these are wrong, but this is a lot to understand, right? These are all different types of things to create. Here's the amount of stuff you put in your cluster just to have the baseline Linkerd. Again, I only have two problems to solve. I may not want to have to understand all this. Again, probably not a problem for Linkerd, but it's a lot to understand for the two problems I'm solving. Here's Istio's CRDs, all the basic kinds of things Istio adds into your cluster, again, solving tons of problems, including my two. And here's the overhead. It runs off the screen of all the stuff that comes with Istio. Again, not dissing these products, but they're a lot. They're these big projects, these big apps. And I'm not paid to deploy applications. I'm paid to solve problems for developers. And I only have two, right? So there's a lot of stuff with Istio and Linkerd that I don't necessarily need. So, title of the talk, what do I mean by half the mesh, right? We know that those two products are full service meshes. So what do I mean by half a mesh? Well, if we do yet another service mesh diagram, there's really three kind of, in a service mesh. You've got your sidecars and your control plane. And in most service meshes, you have this wibbly-wobbly, networky stuff that I drew. That is kind of how you get all your network traffic magically through the sidecars. And that's your control plane, right? This is your traditional service mesh diagram. And that's a full mesh. So when I say half mesh, what we're going to do today, twice, is make our own little micro meshes that solve our problems by using just a sidecar and just a control plane. These are two completely different ways of solving the same problem. One's going to focus on HTTP. Sidecar is going to be for your HTTP people. The control plane is going to require gRPC, and I'll kind of show you how we do that. But again, we're going to build two micro meshes today. In summary, our full meshes, again, my problem was scale. My full meshes have all these extra resources. And our half mesh solutions today, our sidecar is going to have one. It's going to have one thing, and really mostly a config map. And that's the entire half mesh solution for the sidecar. And our control plane has 5 things. So a lot more approachable, a lot more understandable for me to solve the problem. I can look at one thing and know that's my whole configuration to solve the problem that I have. Again, I've already said a couple times, I like Linkerd. I like Istio. They're fantastic things. They are solving lots of other problems than the problems I have. But I want to kind of get people thinking that, remember, we're not paid to deploy applications or deploy products. We're paid to solve problems. And so we're going to do that twice today. Again, I'm speaking really quickly. Hopefully this thing can keep up. I have a lot of content, so hopefully you can keep with me. The plan today, We're going to very, very briefly show some test server and client code. I'm only going to show you that to show you how dumb it is. It's really the most basic client code and server code you can think of. I'm going to talk about this thing called XDS because we're going to use it in both our sidecar only and our control plane only half meshes. Again, the sidecar is going to focus on HTTP, and the control plane is going to be gRPC. So let's do our test server code. Here's the HTTP handler. You don't really have to understand Go at all. I don't want you to understand that this is it. The server is not smart. The server is the most basic HTTP server, listening on port 8080, spitting back the client its host name and the headers it got. Here's our gRPC handler. Again, if you don't understand gRPC, that's OK. Basically, understand that the server is also not smart. It is just a gRPC server that's going to return its host name. That's all we have. This stuff I'm showing you today would work with really any HTTP or gRPC client. I'm just showing you that the simplest ones will still work. Here's our test client code we're going to deploy. Again, nothing interesting here. In fact, this client is so dumb, it is hard-coded to talk to service.local and port 8080. It is unconfigurable. You can't even tell it where the service lives, because we're going to let the mesh do all that work. Every half second, the client's going to connect to the service at this fixed name and just print back what it got from the server. Same thing with gRPC. Hard-coded of the destination. The client's really dumb. It's going to talk to our gRPC server. We're going to let the mesh do the work and return the host name that it got. So that's our server and client code we're going to use for both of the demos done. I'm going to focus a little bit on XDS fundamentals because this is really important stuff, and we're going to use it in both of the demonstrations coming up. What is XDS? I used to think it was stood for Extensible Discovery Service. I couldn't quite tell what that X was, but it turns out it's all these things, RDS, CDS, EDS, LDS. I'll tell you what those are in a second. But you replace the first letter with the lowercase x as a variable, and you've got Discovery Service. Like that's what XDS stands for. This is something built and managed by the Envoy team. I'm going to lean a lot on a lot of things on the Envoy team today. Again, I like these other products, and we're going to use them today to kind of solve our problem. But basically, XDS is a kind of a standardized configuration language for service meshy things you might do. Right? And we're going to use that over and over. There are only 4 things about XDS you have to understand. There's more to it than this, but there are 4 things you have to understand today. There are LDS, listeners, which are ports that you open up and you listen and receive traffic. You send listeners to routes. Routes configure based on what kind of traffic is coming in, what clusters they're going to go to. Clusters, not to be confused with Kubernetes clusters, are just collections of endpoints of where you might, or places where you might receive traffic. Endpoints are the individual IP addresses or locations where you actually send it. So cluster is just an abstraction. So to summarize, you've got listeners that point to routes that point to clusters that have endpoints. That's the only 4 things you have to understand about XDS for the talk today. And for one of these, the first one, you only have to understand 2 of those. And that's it. So let's go ahead and get to half mesh 1, and let's actually build our sidecar only mesh using XDS files. So this is the diagram of me solving the problem today. Remember, I only had 2. And we're going to do this by having a sidecar that we run explicitly with our client. We're going to configure that sidecar with config files that we mount in from a Kubernetes config map. They're going to be live mounted so we can change them on the fly. And from there, the sidecar is going to talk to the client's going to talk to the sidecar and discover the service and go to our endpoints as we've configured it. Notice the network magic is gone. There's no wibbly-wobbly stuff. We're going to do a little bit of Kubernetes work to have the client point to the sidecar automatically. So here's where we take our server code I showed you, and we deploy it in Kubernetes. I show you this to show you that the server is not smart. Even the deployment is the most basic, boring Kubernetes deployment you've seen. Same thing with the beta. We have a main and a beta deploy, both having a separate set of pods in Kubernetes. Nothing interesting about these deploys. We're going to let the mesh be interesting. The one trick we have for our sidecar mesh to work is that when we create our Kubernetes services and point them at the deployment, we need to do this cluster IP none thing, where we basically say, when you hit this and resolve the DNS for this, give back all the individual IP addresses for the service instead of a load balancer. That way Envoy can do their load balancing for us. So this is the only interesting thing so far, really, about the half mesh is this one config change. Again, beta's deployed, same idea, nothing interesting there but that cluster IP. Here's our client deployment. We're finally getting to the actual part of solving the problem. Remember, I told you the network magic is gone. Basically, there's a section in our pod spec where we can tell Kubernetes, when the client tries to find service.local, which it's hard-coded to do, point it at itself, right? Because we're going to have a sidecar there, and it's going to listen on service localhost. But we do the service discovery kind of part here. We just point the client at the sidecar, and we'll configure the sidecar to match on that host name. Here's the other interesting part where we create and use an Envoy sidecar. So we're creating an Envoy container. We're mounting a config map as a volume, and Envoy is going to get all its configuration from the config files from that config map. and the client is just going to talk to localhost because of that redirect, right? So hopefully everyone's on board so far. This is the main setup for getting the client to talk to the sidecar. Now we just need to configure the sidecar. We do that with a Kubernetes config map. You're going to see a lot of walls of text today. I'm going to highlight the important parts, and I'll show you where I got all this from. It's not magic. It may seem like magic incantations, but I'll show you where it comes from. For a client, we're going to make a single file in the volume called envoy.yaml. It's going to point to a file called cds.yaml to find clusters, collections of endpoints. And we're going to point to a file called lds.yaml to find listeners, right? So those are the only two XDS things we do. We just tell Envoy, look at these files, and dynamically reload them when the directory changes. Deeper in the config map, we define cds.yaml. So lots of stuff here. Don't get overwhelmed. Basically, we're saying there's a cluster called service_main_cluster, and it points to this Kubernetes service DNS name, which, remember, is going to resolve to the individual IP addresses. So we do that for main. We do that for beta. And these are really the only non-boilerplate things in this file. It seems like a lot, but we're just making two clusters and pointing them at Kubernetes. Deeper in, we create our listeners. Again, tons of stuff here. The important part is here's where we listen on localhost. Remember, the client's coming in there. And we're going to listen on port 8080. Deeper down in the routes, we actually get to do our routing. So we say, hey, when the client tries to talk to service.local, we're going to point it to service main cluster. I'll do the kind of 50-50 split later. We'll solve the second problem. But let's just start with service discovery. Client wants to talk to service.local, we'll send you to all of the endpoints for service main cluster. Remember, the client's hard-coded, so this is where we get you could extend this to more than one service by just having different routes that match different host names, and you can build this half mesh, again, with just this one file. I know this seems like a lot, but let's take a second and look at the config. There are 167 lines of code in the client's YAML file, and most of that is the client deployment. So when I show it at you really quickly and you see all these walls of text, it seems like a lot, but let's show you a picture. This is it. I know you can't read it, but this is the whole half mesh solution. This is the entire thing you have to understand how this solution solves our problems. And if you want to change it, you change this. You don't have to go understand 20 other files or 20 different kinds of custom resources. It's completely self-contained. Also, this will work forever. This is all of the config. It's the entire control plane, if you will, contained in this one file that you have to understand. Where did that come from? Where did all that magic come from? Again, I highlighted the important parts. This all comes from the XDS specification. So if you wanted to go ahead and change the routes, you would go to the XDS API docs. You would go to something like find our route configuration. We'd go to our virtual host section, and you basically build a YAML file or a JSON file by following this very detailed documentation to fill in the gaps to solve the problems you're trying to solve. Again, you kind of have to learn this, but we're all Kubernetes developers. Like, we understand building big, kind of seemingly abstract config files to solve our problems. You understand this, you can do a lot with this pattern, and this is the entire thing you have to understand. So that being said, let's go ahead and take a second and do a demo. I'm going to go ahead and build. I've already built this, so kind of like a cooking show. Like, I've pre-baked my images. Don't worry, we don't have to watch my Go code compile. We just built our Go code, client and server, and the control plane. And I'm going to start the demo and then show you what it's doing while it starts in the background. So we are building a brand new Kubernetes cluster using K3D. There's nothing in there. In fact, we're turning off a bunch of things to make it fast. I'm going to import my pre-built image into that cluster because I don't want to deal with registries when I'm presenting, because that's a pain in the butt. I'm going to create the clients and server YAML files that you saw earlier. So we have our services and our deployments. We have our client. It's got that sidecar. It's got the network settings. And then we're just going to tail the logs. And we're going to watch our client, again, hard-coded, automatically find our server. Right now, it's just waiting for everything to come up. So we're getting our service discovery. We're going to immediately just go to service main. And then we'll go kind of change screens and go edit the config and reconfigure our control plane with just editing a config map. So in a few seconds, again, we're waiting for everything to come up. And you'll start seeing stuff pop up here. And then I'll go to another terminal, and we'll kind of play with it some more. Hopefully. Of course, you do it constantly. All right. Waiting for it to start. OK, there we go. It's just a little impatient. So I moved to another screen just so this is faster. You notice that we have two sets of clients. We have clients 1 and 2, two sets of pods. Both of them have the same config map mounted. They found the service, and they're load balancing amongst its endpoints. So that is done. Like our half service, we've solved our problem with one config map and a sidecar. Let's reconfigure our control plane. yeah, there's no fancy GUI here, but we can get all the things we can get from most of the service meshes by basically coming into our config map. We're going to delete this line. I'm going to change it from 100% of the time going to main to a 50-50. I know I said 95-5 in the slides, but 50-50 is better for demos. We're going to save this, not touch anything, and watch our clients reconfigure. Now, the clients do not instantly reconfigure. We've mounted a Kubernetes config map as a volume that will get live updated, but it takes a 60-second loop for the kubelets to kind of grab the new config map and remount. So on average, this part of the demo takes about 30 seconds for it to refresh. But I don't have to restart the clients. I don't have to create new pods. I don't have to change anything about the clients. I've edited the config map. The Envoy sidecar is configured to read that, detect the changes, reload, and start serving the new config instantly. So depending on how lucky I got, this is either going to take 30 seconds. There we go. So we can see one of the pods is done. The other one will come in a second. But this one right here, you can kind of see we have main and beta alternating now. We have reconfigured. We've solved our problem by just changing a config map. All our clients instantly have the new config just by changing one file in Kubernetes. So that's pretty cool. Hopefully you're kind of seeing how that's approachable. Like you can solve this, and you don't need a full mesh if you just have a problem. You can use some of the community tools to solve that problem in a self-contained, yeah, you have to understand one config file, but that's it. So tweak that config file, you get all of this stuff automatically. Well, not automatically. You can build this yourself. Again, I'm a platform engineer, so I'm really excited about tools that let me build more tools. But just change that config, and you can do all of this with this solution that I've given you. All right, question comes up. Can I just use one of these things? What you did is sort of just like a normal HTTP load balancer with more steps, right? And the answer is, yeah. Yeah, it's sort of like a normal HTTP load balancer with more steps. I just want to, again, encourage people to build solutions, not necessarily focus on deploying products. So why did I use Envoy? Well, it's built for this, first of all. It's got a lot of features. You saw that big list. That's all in Envoy. And sort of self-servingly, it's built on XDS. And we're going to use XDS again for the next half mesh that we're building. So you don't have to teach you XDS twice or some other configuration twice. But yeah, I think this is a really cool solution. You put that on the edge, and you could solve some of these problems without needing any other overhead. All right, about halfway through, we're going to focus on half mesh 2. So that was all HTTP land, and it worked with HTTP. You could make it with gRPC and some other stuff by changing that config file. But this second half mesh is focusing really on just a control plane and gRPC. So here's the diagram of what we're going to build today. We got rid of the sidecar, and instead, we're going to use thick clients. So our clients are going to be really smart. A lot of gRPC clients, and you'll see how many, have the logic built in to talk to a control plane. They know how to speak XDS and get their configuration and obey configuration that they read from an XDS server. So we're going to solve the same problems without the sidecar and just make smart clients instead. So here's what we're going to do. We're going to write our own control plane. Yes, we're going to write our own control plane in about 13 minutes. It's not as hard as you think. I promise most of the hard work, has been done by the Envoy team. And you just need to use a smart gRPC client. And you'd be shocked at how many of the gRPC clients are smart. So Go, JavaScript, Java, all of them have full feature support for everything in XDS. And all these things with asterisks support most of the features. So even PHP, you could use this control plane, point PHP code at the control plane, and get most of the features that we're going to talk about today. So it's way more approachable than you might think. You don't have to use Go as the client. I'm using Go as the control plane because it's built for that. You might want to do that. But as the clients and servers, it can be gRPC, whatever. So seriously, are we going to write our own control plane? I thought you need an entire team. You need a big CNCF project to write a service mesh control plane. And it turns out, no. No, you can leverage this Go control plane package by the Envoy team. Again, thank you, Envoy. And build your own pretty efficiently. And this isn't just theory, by the way. We do this at Weave. We do this for hundreds and hundreds and hundreds of microservices, constant scale up, scale down, configuration change, and it works beautifully to solve our problems. Again, trying to solve problems, not deploy products. So what we're going to do is get rid of that config map and put our abstraction on services. We're going to go say, hey, I'm just going to go to my Kubernetes service, annotate it, say that this service provides our mesh service, kind of weirdly named service, and on port 9000 with a weight of 1. We'll come back to why we have a weight in a second. But basically, we configure our mesh by annotating the service to say, when a client tries to talk to service, come here on port 9000. Here's what our control plane logic looks like. It's 3 things. We create an XDS cache using that package the Envoy team has given us. We're going to watch Kubernetes services and endpoints. We're waiting and getting live updates from Kubernetes cluster about any time a service is created, updated, or changed or deleted, and all of the individual IP addresses in the endpoints behind that service change, right? So our control plane is really leaning on Envoy and leaning on Kubernetes as the data source to configure XDS. And then we're going to generate our XDS resources, very much like the YAML file from before, but with a lot of Go structs. Don't get overwhelmed when you see big walls of text. I will point out the important stuff. First thing, very easy. We pull in this control plane package, and we create this cache snapshot. This is basically a snapshot of the state of the world of all of the XDS things that I know that exist. I don't have to care about what clients care about. I don't have to care about what clients already know about. That's all handled in the cache package. I just, whenever endpoints or services change, I generate the state of the world, shove it into the cache, and the cache does the rest for the clients automatically. Again, standing on the shoulders of giants, let other people do the work and just use it. What we need to do now that we've got our cache is watch Kubernetes services endpoints. Tons of stuff here, very basic Go stuff. We create a Kubernetes Go client. We create some handlers that say every time services or endpoints change, run this update cache function. If we go deeper in the code, we see where we set up the service watcher. Again, you don't need to understand most of this. Understand we're watching Kubernetes services and keeping an in-memory index of all of the services that exist in our cluster. So it's very fast to iterate through them all because they're all just hot and ready in memory. Same thing with endpoints, the individual IP addresses behind a service. We create a cache. We watch those for updates. We'll run that update function, and we will store those endpoints in memory for later use. So we've got hot and ready all the services and endpoints in our cluster. And again, this scales really well. Like Client Go is built to scale. Every time services or endpoints change, we basically call this update cache function. In that, we use those in-memory indexes of services and endpoints to build a cache snapshot, the state of the world. We shove that state of the world at the cache, and that's it. Our clients are all able to get the updates. They know when things are added, updated, deleted. Instantly, the cache does the work for us. We just need to generate state of the world. Deeper in that get snapshot function, so every time we update, we get the snapshot. Getting a snapshot involves really a couple things. Getting our resources, so building the XDS state, sort of like that YAML, but in Go form. We're going to print it out in YAML format, so it's easier to read. I'll show you that later. And then we create a new snapshot, again, so we can shove that at the snapshot package. This is where all the hard stuff comes in. This is where the walls of text come in. Stick with me. Get resources is going to have two parts. Every single time any service or endpoint changes, we call get resources. Get resources, step one, builds a big map of all the mesh services and all of the Kubernetes services behind it, right? So we iterate over all the services in memory. We find that YAML. If it's there, we're going to parse it, and we're going to get from all the endpoints individual IPs. So we know service one provides this. Here's all the IP addresses for it. Register that with our map. So we have a big list. At the end, we have this big map of all of the mesh services and who's going to provide them. Once we've got that map, we iterate through it. And for each mesh service that we've got, we find its listener, its route, its clusters, and endpoints. Multiple clusters because we might have multiple services say they provide the same backend. So again, the same four things from before, we're just going to go over them, get all of that from in-memory, and build that same data set as before. I'm going to go through each of those four things very briefly. Get listener, again, wall of text, don't worry. You go read the docs. They're very good docs. The Go structs actually make it really easy to not get this wrong because the compiler will tell you if you have things incorrect. It's even better than the YAML. But we basically make a listener, and we point that listener at a route for a given name, right? So we have something that says, I provide service. We say, make a listener for that and point you at the route for service. Don't worry about the rest. Remember when we made routes in the YAML format before? This is the Go version of that. Again, don't be too overwhelmed. We basically say, hey, whenever someone comes into a route for this service, I want you to send them to all of the clusters that say they provide it using their weights to decide how much to distribute to each cluster. So again, using some Go code to generate that same thing as before. Remember, client's hard-coded XDS service. In here is where we put in the actual, when we see its XDS and we go look for service, it's going to try to find it in this list of domains and then send it to the route if it matches. Remember our clusters from before? Well, here's the Go version of that. We basically go ahead and iterate through all of the individual clusters that say they provide a mesh service, and we add clusters to them in XDS. So again, we're just building up all this data of the state of the world. Moving on, we get endpoints. Getting individual endpoints is, again, going through individual providers and just slurping up all the individual IP addresses behind every cluster. We've already generated all this. This is just a bunch of Go structs that map to that YAML like we had before. That seems like a lot, lots of walls of text. When I step through them one at a time, it makes it seem worse than it is. Let's look at our slides. All right, less than 400 lines of code for the entire bulk of the control plane is in this file. Less than 400 lines of code. That's understandable. Yes, I had to build it myself, but I can grok 400 lines of code. And this is not that far off from what we use at Weave. So I'm going to go briefly here. Setting up our control plane, basic Kubernetes deployment, just running a control plane code. Our service, we're going to listen on port 18,000 for our clients, because the clients need to connect to the control plane. The clients, the only thing we do with the clients, run them in gRPC mode and give them this magic env variable. Even if your clients aren't in Go, this is the variable you give them, and you just need to tell them where the control plane lives, right? So we're going to point at that Kubernetes service, talk to the control plane here to find all your stuff. Let's run that demo. So again, actually, let me go back real quick. I got to kill the other cluster, or I won't have enough resources to run both the demos at the same time. OK, I'm going to start this. We'll scroll down, and I'll talk about the second demo. Second demo is a lot like the first. Make a brand new cluster, run our control plane, run our clients, and run our servers, just like before. Really dumb clients, really dumb servers. Less than 400 lines of control plane, not that much to solve our problem. And we're going to wait for the clients to come up the same way as before. So this will bootstrap, and we'll get into the, really I do the whole talk to get to this last part of the demo where you get to see, because we're watching Kubernetes services and endpoints, we get live updates when things happen instantly. So that delay you saw before, it's gone. We're going to see that change instantly because we're plugged right into our data source. This also would work without Kubernetes, by the way. If you have some other data source of all of the endpoints and providers and you want to build your own abstraction in a database, you could do this. You just need a list of what's the services I want to provide and where are the individual places I want to send clients when they talk to those services, right? It's all about just getting metadata. That XDS config doesn't care where the data comes from. You just need to build it. That's why I kind of built it in two parts of code. So again, step over here, tail the logs. So we have both our client 1 and 2. They're all going to service main. We're going to edit the Kubernetes service for beta. We're going to go to our annotations. And right now, the only thing providing service is the main instance. It had wait 1, remember. So when I save this as wait 1 as well, our clients instantly got that change. We have 2 services providing the same mesh service, equal weighted, so they get equal distribution of load, right? We instantly had that. If I were to scale up, let's add more replicas for main. It's a little hard to tell, but the clients instantly, every time the endpoints are changed, we get instant updates. Again, this is live from our Kubernetes data source because those watches are so fast that we can rebuild the entire state of the world every time anything changes. I could even go back and set this out, give that weight of 0, take it back out of load, and our clients instantly only go to main, right? How cool is that? Now I can mess with my mesh. Yeah, I don't have a fancy GUI, but this is the whole thing. I mesh with it just by editing Kubernetes resources. Again, I only have to understand that one bit of code that I wrote. Everything else is done basically by the Envoy team and the smart gRPC clients. Again, go to that documentation. It's the same stuff if you're going to do a config map or Go. The only difference is Go structs are type checked, right? But it's the exact same config because it comes from the same protobuf defs. And you can get all of these features with that less than 400 lines of code control plane by just changing the code that you generate. In fact, I was really inspired by the last talk. I want to go see if I can, when we do this kind of stuff, have our canary deploys fall back to our main deploys, because that's in here. You just have to figure out the config for it from the documentation. So we did it. I did it in less than 30 minutes. We took our full mesh sidecar control plane, and we built a sidecar-only one focused on HTTP, where we just used one config map and a sidecar. And we did our control plane, where we built our own control plane. Again, less than 400 lines of code. That is approachable, even if you just want to do it as an experiment. You can get this code and run it. So all that said, thank you so much. My name is Carson Anderson again. If you want to run this demo, you can run this. You just need Go. You can pull it down and find all the code and go at it maybe at a slower pace at this GitHub link here. So thank you.
Thank you. Questions?
Thank you. In the first part, you were changing the behavior on the fly by updating a config map. And it's been a while since I did stuff like that, but I thought that config maps don't automatically update when you mount them as files in the deployment. You have to actually roll the deployment somehow.
Nope, that's not true. They are live mounted by default. Config maps and secrets in Kubernetes. There's a trick to it. In the way Kubernetes does it, it actually recreates the entire directory and changes the symlink. So it can be a little tricky if you're watching a file. That file handle won't get changed. So if you're using like one of the libraries for iNotify, you have to watch the root directory. So people get a little confused because they're like, well, the file didn't change. Like, no, it's still there. The symlink for the directory changed, but it is live updated.
Okay.
It's a really cool feature of Kubernetes.
Right.
Yeah, back here.
Hey, but very cool. We actually built something very similar internally to Octeto that we should have open sourced, but I'm glad now there's something there. One of the challenges we've had with our users is for non-HTTP services, queues and all those things. Do you have any thoughts on that? Like what to do for those kind of...
No, that's great. Yeah, so for non-HTTP things, in theory, and at this point, maybe I'm just building a worse service mesh, but in theory, you can take that control plane and configure your own sidecars, right? Like, if you have your own abstraction you really love that works for gRPC, XDS, you can point Envoy at the XDS server that we built in the control plane part of this presentation. And so, like, we've had that come up, and that's been my thought is if we get real desperate for that and we can't use gRPC, then I would be tempted to see how hard would it really be to just use XDS to, again, maybe I should build someone else's service mesh or use someone else's product, but if I have an abstraction I love and I can write some XDS files and send them to Envoy and have Envoy do the routing, so that's my answer. Yeah.
More questions?
Right here.
How is this different from or similar to what Istio Ambient is doing?
It's pretty much the same thing, right? So Istio, I didn't hear the second one.
No, it was just...
OK, yeah, so the other service meshes, the only difference is the lightweight version, right? So Istio Linkerd, they do all of this and everything else, and they have fancy GUIs, but there's also a lot to understand, right? Like, if you wanted, those are full products with this giant suite of features, but if something goes wrong, do you even know where to look? Like, that's sort of my argument. With that, especially with that first half mesh, if it doesn't work, it's because your config map's wrong. That's the only thing that can be wrong, because that's the only thing you have in the system, right? So the advantage to me of something like this is that it's one file. It's also super lightweight, right? So that first example of just a sidecar and a config file, you could put that on an edge device in Kubernetes and work, and you could get the feature without the complexity. So I'm not, again, I love Istio, I love Linkerd. You just may not always need those things.
More questions? Going once, going twice. Oh,
Nope.
all right. Thank you.
All right, thanks.
We have a small break. It's I think there was a 20-minute gap. I think we went a couple of minutes over, so we got about 18 more minutes or so.
Awesome. I can't believe I kept it in time. Whew.
Testing 1, 2, 3, testing.
All right, we're going to get started. Yeah, I'll hand it over, and we'll start it with a round of applause. Hello? 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 Hello?
Keep talking.
Hello? 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 Okay, awesome. All right.
All right, so welcome to our talk. It's Papers, Please, scrutinizing AI model creation. So I'm hoping everybody in the room has heard of the game Papers, Please. So it's kind of a play on that. So it's like, we want to be scrutinizing how was the AI model created? Is it signed properly? Did it have the right documents? And is it allowed to move into, can we use it and so forth? Right? So quick introduction. I'm one of the co-founders of a supply chain security company called Kusari. I'm also an open source maintainer on the open source project Guac, which is a graph for understanding artifact composition. And we'll talk about that coming up. Another one is Fresca, and then in toto attestations, which actually the salsa attestations and other things are built on, and we'll talk about more. And then in toto Golang.
Hello, I am Mihai Marusac, the same way as Taylor Swift, it's Mihai. I am from Google Open Source Security Team, also known as Ghost. And I co-chair the OpenSSF AI working group for AI and ML and security, and also member of the Haskell security team. And for open source, I started with TensorFlow security. I started the team, and then I started maintaining TensorFlow, and also maintainer for Guac, model transparency for AI supply chain security, and Hindent is a Haskell indenter. And now let's go into the talk. So let me first put on an attacker hat. And suppose there are these users that I want to impact, to inject malware to them or to cause harm to them. And I want to do this via AI. So I'm going to build two models. One of them is going to be an evil model that will have malware, and the other one is a GPT 4chan. It's a LLM trained on 4chan. And I want these users to use these models. Of course, I cannot just send the models to the user directly. I have to upload the models to a model hub, and I have to give a description to the model in the model card. And now the users would likely download the models and use them. Well, this doesn't really work that well, because users are going to see that the first model is called evil model, and they're going to say, no, I'm not going to download that. And the second one, again, from the name, they're not going to download it. But that's something that I can easily fix. I can just change the name to the model, and now users will not be able to know what is the problem. So that's the main thing that we're trying to solve, is trying to tie the model to how it was built in a way that is tamper-proof and stored in attestations and so on. And this is not theoretical questions. Just a few weeks ago, a ByteDance intern got caught sabotaging another intern by sabotaging the model pipeline and ingesting malware and reducing the way a model gets trained just to get ahead of another one. So let's think how AI is being developed. Initially, you start with some data sets, and if you train from the internet, you just don't build the model directly from the data set. You perform some iterations on the data set to clean them up. You might have missing data that you fill in. You might run some rounds on scheduling the data, on massaging the data to fit certain forms and so on. Once you have the data set, the next step is to select a model framework like TensorFlow, PyTorch, and so on, decide on the model architecture, and combine everything together to train the model. And now that you have your model trained, you put somewhere in storage, and you are waiting for this model to be used. Well, actually, there are two steps. One part is for large models, you don't train everything in just one single step. You train one step, put it in storage, get another data set, train further, and so on to fine-tuning. So you have this iteration going back into the training process via pre-trained model. And at some point, you get this model and say, now I want to put the model into an application. You elevate it to a production model. You do a release, and then you embed it into the application. So this is kind of how you build AI models in general. This is like a 10,000 feet view of building AI. And of course, at every step in the process, there are supply chain risks. So you could have, during the data transformations, someone maliciously or by accident could ingest data poisoning. And now all the models that are going to be trained on that data are going to misbehave. Or from the model source, the source repository itself could be tampered with, and you're hoping to train one model, but because the source has been tampered with, you're actually training something else, a model that might have malware ingested into it. Or even let's go to storage. You put your model in storage, but then people that have write access to the storage might overwrite your model with something else, or might just modify the weights a little, fine-tune the model to mispredict it under some conditions. So we want to protect all of the supply chain. And the first step is each time we release an artifact, we sign it. And each time we use the artifact, we verify it. We can use Sigstore for this. There was a talk yesterday about Sigstore. This is very easy. But we can go one level further because signing only tells you that the bits of the artifact are expected to match this hash, and that's all. But it still doesn't tell you who built the model and what got into the model. So that's the second part that we want to do. And for that, we can go to the next step from traditional supply chain security. We can use SALSA. SALSA attestations can record information about all the inputs that come into the build process, information about the build process itself, and information about the output. And we can look at some SALSA statement.
Yeah, so the SALSA statement kind of starts off like, if you've seen traditional SALSA statements, they're usually describing software artifacts, right? So how was it built? Where did it come from? What artifacts, what other materials that kind of went into it. So you can apply the same kind of methodology for an AI model also. So you can see here for this PyTorch model, you have the specific hash, which describes the actual object itself. It's the subject of the SALSA attestation. From there, we see if we query the builder, you can see where exactly it was built from. And then we can see the materials. But materials currently is only listing the source repo, where exactly it came from. Because SALSA was originally designed to capture software dependencies, how the software actually is built, and not for an AI use case. We can actually, it's not fully complete, right? We're missing information about this. So that's where, we have the subject is being handled properly, we have the hash and so forth. But in order to complete the actual SALSA attestation, we need to include the data sets that kind of went into it. And then other iterations we made on the data sets, how was the model actually trained, and then finally what kind of framework all went into it. So we need a complete understanding of how exactly it was built, so you can put that into the SALSA attestation. Right, so this information is currently missing. Currently we're using GitHub Actions, but we want to in the future, have this ability available for other ML trainers and so forth, as well as for the developer, right? So if they're working at Jupyter or Collab, we want this in the hands of developers so that they can easily create these SALSA attestations as they're actually working. And it's not something that they have to do extra, right? It's as they're kind of working through their workflow, this information is getting collected, placed into a SALSA attestation so that it can be consumed. So we have three different things here, right? So we have the SALSA, which is focused on how was it actually built. Model cars, right? This focuses more on the ML, like the data sets, licenses, and so forth. So what we want to do is take all this information, combine it all together in a SALSA attestation, but from there we can actually create an AI bomb or whatever else kind of we want to, right? So that an AI bomb will contain the actual artifact, the dependency tree, and so forth. So we want to take all this information, but a starting point is we have to create a SALSA attestation that is complete.
So going back to the diagram, to the supply chain diagram that we have seen before, we can see that we have these two loops from dataset to dataset, and then from model, you train the model, you put it into the hub, and then you iterate again on it, and so on. And thinking a little bit deeper into this gives us the idea of dependencies. Each time you build a model, it has several dependencies. Some other models it has been trained on, some dataset it has been trained on, even the training framework, even the ML framework, TensorFlow, PyTorch, and so on. So thinking of dependencies, let's first think on how the traditional supply chain works with dependencies. So let's look, for example, at the dependency tree for TensorFlow. When you do pip install TensorFlow, all of these packages are going to be installed into your system. And when you look at the graph, we see that TensorFlow has a bunch of dependencies as the first layer, a bunch of direct dependencies. And then each one of them has a few of them. In general, for traditional supply chains, for the traditional software environment, the dependency tree is wide, so you have a lot of dependencies at the first few levels, but also narrow. You don't go beyond 5 to 6 levels. Of course, this is in the majority of the cases. There could be pathological cases where you have thousands of dependencies and so on. Now, if you look at ML, the process looks a little bit different. This time, the tree is shallower because each model has been trained from one data set and one pre-trained model. So you only have just a few dependencies. But also the tree is much deeper. You have many more levels into the tree. So here we have some example. At the bottom down there with yellow, is a model that is trained from one data set. That's the case that usually happens for very small models. In general, it's more like experimentation. You want to see if this model architecture is able to learn information from the data, but that model will not get into production because it's not trained on enough data. What usually gets into production is what's shown on the slide at the top. You start with one data set, you maybe perform some operations on that and you train a model, or once you have a model, you might fine-tune it with data from another data set, and you keep iterating on these steps, and then at some point, you take this model, the final model, and then you convert it to some format that the application can use. So for example, you can quantize the model if you want to deploy it in mobile applications. Or if you train a very big language model, like with 8 billion parameters, but you want to use only 2 billion for performance reasons, you can do model distillation to reduce the size of the model. And other operations like this. So that's how the supply chain, the dependency tree for ML looks like. You start with one model, and you have just a few dependencies and multiple iterations going back. And now, if we have salsa attestation for every step into this process, salsa attestations that are complete, so that record both the input and the output, we can now analyze the entire graph with both humans can read the attestations, but also we can use tooling. And that's what we're going to go into this for the remaining of the talk. So we have worked to extend the salsa. Instead of just providing the final output and the repository, we also worked to also record the data sets and the models that go into producing the model. And then we used some tooling that we're going to talk about that to analyze this entire graph.
All right, so just to recap here, right? So we talked about SigStore. So at the bottom here, at the right, you can see that SigStore. So that's where we're doing signatures. It's providing us with strong identities. The next level above that, which is in blue, is the software or the attestations. That's where Salsa lives, right? This is giving us the combined information about how it was actually built. And then the next piece is Guac, which is the graph for understanding artifact composition. And I'll go into it a little bit deeper in the next slide. But basically, right, you have all this Salsa attestation, all this metadata that's laying around. How do we take this information and make it usable for us? Like I want to automate policies around it. I want to gain some more insights. Can I use this information? Like, right, it's going to be separate documents. Can I take all this information, throw it all together, and then can I use it for policy? So that's where we're kind of getting to. So Guac, so there's an open source project that both Mihai and I are maintainers on. So it started off, we wanted to be able to ingest, software metadata in general. So we wanted to make this very flexible. So Guac is very pluggable. So right, it currently takes in, SBOMs, it takes, software bill of materials. It takes in scorecard information, OpenSSF. It takes in toto attestations, which is like Salsa and so forth, and vulnerability and all that kind of stuff. It takes all this information, puts it into a graph database, and then from there, you can use the API in order to query all the information together, right? So it's going to decompose all these artifacts and decompose all these documents, and then put them into a graph database that they're all interconnected. All the relationships are defined, and then you can use that information to make policy decisions or whatever else. And one of the things we'll get to is, like, for example, let's say that the data poisoning example happened, right? Let's say one of the data sets was compromised. Then how do you know where did you use that data set? Can you find out quickly instead of, it's a guessing game because you might not know exactly what data set kind of went into the model to get it trained. But if we're combining it together, having Salsa, SigStore, and Guac, you can query for that specific data set and find exactly which model is actually being used by it. So let's kind of jump into the demo here. So I quickly got, so Guac is up and running. So on the bottom, basically, it's just up running. So what I'll do here is I'm going to ingest. Like Mihai was saying, we went ahead and created Salsa attestations for all these models. So we are going. That's too small, so?
Yeah. Okay.
Good. Okay. All right. So what's going to happen is I am going to ingest all these Salsa attestations that we already generated, and we'll talk about some of the attestations, the materials and so forth a little bit later on. But basically, it's going in, it's decomposing all the information, like I said, and it's going to put all this information into a graph database that's behind the scenes that's running. At the same time, we are also verifying. So here you can see verify signature against transparency log. So we're using SigStore. So all the data sets, all the Salsa attestations are all signed. So as they're coming in, we know haven't been tampered with, and what information that we collected was accurate from the source, basically, right? So each of these documents were signed, and then as they were ingested into Guac, we're verifying that they were the documents. They're saying what they are, kind of thing, and haven't been tampered with. So the first example we're going to run is the PyTorch model that Mihai kind of talked about. So I'm going to run here real quick. So basically, I'm just querying at the top level subject artifact, and I want to see what exactly, what information is there, and what materials were kind of composed by it.
So this is the scenario where we have a model that has been trained from one single data set. We use the hash of the model, and we want to find out what are the files, what are the images from the data set that the model has been trained on. And this is what we see here in this table.
Yeah, so this table is here is the actual, this file, that's the salt statistician network. That's where it came from, and it's describing this SHA-256 hash, and you can see all the materials that are part of it. This includes, all the different data sets. It could be the framework or model, whatever else it is, right? Everything that's been trained on. And if we kind of search this, each one of these will have their own salt statistician associated with it. So you can see this material has its own salt statistician down here, which is part of this data set, salt statistician, and you can see the material that it was trained on. So it's going to be recursive, so you can go all the way down the down the tree, kind of see and understand exactly what kind of composed, what's composed within each layer, and then as you go down, you can understand, okay, what material is there, and this is how you understand where everything kind of came from, right? Anything else you want to add here? Awesome. Okay.
Okay, so now let's run the second demo where we are looking at the model in production, and we want to see the entire graph of dependencies from the first data set to any data set that got fine-tuned, any fine-tuned model, and so on until the end of the model.
And I forgot to show this off.
Oh,
and so we do have our visualizer that we have running here, and it zoomed out, which is not good. So we zoom in a little bit.
Yeah, so this was the PyTorch model. We can see this node, the pink circle here. This is the PyTorch model, and as dependencies, we see all of these salsa nodes here. These are the data sets, the images from the data set that have been used to train the model.
And you can see they're all linked to this salsa generator. That's where they were built from. So, and this is this particular hash, and they all are linked together with the salt statistician. So this is behind the scenes. You can see the graph database kind of taking all this information and correlating all this information together. And it's kind of hard to visualize here, right? Because there's a lot of information. So we're still trying to work on this. We're trying to make it so that it's much easier. It shows you the relevant information, and at the same time, it gives you the information. Doesn't crowd it all together. So this is still a work in progress. That's why it's a little bit like that. But yeah. All right. So this is the other model, right? The production one.
Yeah. So you can see that this is the CFAR 100 fine-tuned model.
Yeah.
And that's where it comes from. And the materials again contains every dependency that got into that model, and you can search from that dependency. You can see every dependency that got into that, and so on. But we can also display this into the visualizer. Same as before.
Yeah, and then you can see again, each one of these data sets may contain other materials, and so on and so forth, right? So it's all being recursive, and you can see it's pretty large in here. So again, I can take this visualizer, and we can view it here. I apologize that it keeps zooming out. There we go. All right. Yeah, so here's the actual shot we kind of started with, and then you can see all the different, again, you can see all the different the data sets and all the other kind of things that were associated with it.
Okay, so now let's do the other scenario. Now let's say that we discover that some data set has been poisoned, or maybe the images from that data set become illegal to use. So we are going to use Guac to detect which models we need to retrain, which models are impacted. And we are going, for example, to say that based on regulation, this set of images cannot be used anymore for training. So we are going to certify that set as bad. We mark that into Guac, and then we can query the Guac, the graph database, to determine what are the models that are impacted.
Right. So what I went ahead and did here is I marked that specific data set as bad, and then now I'm going to do a query on it. So once it returns, it's going to give me, so here is the certified bad that I created at the bottom. And from there, it returns me a visualizer. And again, like we can output this in a CLI in another format. So again, it's still a work in progress in terms of how do we display this information. So it's a lot easier for the users as well as anyone that's kind of looking at this to understand. So let me zoom back in again. Right, so here is my certified bad node here. You can see that I've certified this particular data set as bad. And then I want to see, okay, where is it being used? So here's a direct stall attestation that's attached to it. And then you can see that this is the particular model that has been trained on, right, on that data set. So that's the one that's kind of affected. And then you see there's another stall attestation here. And you can see because there could be recursive nature of the model training. There's a lot of different places where it can be used and so forth. So this gives you an understanding of like if the data set was poisoned, how do you quickly determine which models are affected, and then what do you need to go remediate, right? It's kind of the same example. If you heard of the log4j example continuously, right? So it's like, how do I know where log4j is in my environment? If I can map it out properly, then I can just query for it, and I can find yep, here are my different softwares that are affected in production or whatever else. The same kind of concept here. It's like, how do I know if this data set is affected, and then which models are, if I'm using it in production or whatever else, how do I know if they're affected?
So the idea here is you have your model put in storage, and now somebody decides, I wanted to take this model and put into some application. And as soon as the model gets taken from storage and you compile the application, if you integrate with Guac, Guac will fail the build and will tell you, you cannot use this model because transitively it has been trained on these images that are no longer supposed to be used. And the hash that we have passed for the image doesn't have to be the hash of the entire data set, could be the hash of a subset of the data set, as long as Guac knows about that hash. So in our case, it has been just a subset of the images, it's not all of them.
Yes, that was the important point of putting this into a graph database so that you can use the graph nature of everything to query the information as you need, and then apply policies on top of it, like Mihai said. Okay, so let me go back to this. Is there anything I don't? Right. Awesome. Yeah. So thanks for listening. This is we're using Salsa, Sigstore, Guac all together so that we can give a complete understanding of how the model was built and then create policies and so forth around it. And I did want to give a quick shout out. We're having a happy hour tomorrow, so if you're interested in talking more about this, be sure to join us. Mihai and I will both be there. So, thank you. Any questions?
Yeah, questions.
Hi, so how would this work if you have like a continuously growing data set? So like imagine you're doing like a web crawl, so you're continuously getting new data or something. How would you version that in order to like have the attestations about that?
So you can build Merkle trees on the data set. You'll have, this is the data set that has been before. I ingest more data from the internet and now I build a new data set. The first data set would come as the input for one salsa statement. And the full data set, that is the Merkle tree of the previous hash plus the hash of what I got now from the internet, will be the output. And that's how you can get the chain. Like this is the first part of the data set, then once I get more stuff from the internet, I'll have another hash, and once I get more stuff from the internet, I have another hash, and so on.
I see.
Yeah, so it's kind of mixing, like similar to Git. Each time you put a new commit, you still have a reference to the previous commit.
Okay, got it.
Tim? Any more questions? Yeah, back here.
Do I understand correctly that at the current state of things, there has to be a person who just goes in and says, oh, this model, this data set, this piece is bad, right? So there's no like current scanning, there has to be someone coming in and actually marking it. And I guess follow up to that is like, you talked about as long as the hash is in the database, so there's a possibility that some data sets in the model could not be in the database, right?
Okay, so for the first part, right now we just mark the data set ourselves to be dangerous, but Guac also supports the concept of vulnerability scans. Mm-hmm. So for traditional software, we are connecting to ASV and getting the vulnerability data from there, and then you can query based on vulnerabilities. There are some startups that are trying to look for vulnerabilities in ML metadata, in ML models, ML datasets, and so on. We can integrate with those two and then use the same approach. Now, for the second part about, let's say, image 1 and image 20 from the dataset are the ones that I shouldn't use, but my hashes are covering the entire set from image 1 to image 100. I can still find that hash, and that will be the hash that I mark as bad in Guac. And I'll have a larger chunk of the dataset that cannot be used anymore, but at least I'll still be able to know which are the models that definitely don't need to be used in production anymore.
Yeah, so I think in the future we can automate once like the AI vulnerability and all those kind of become more prevalent, similar to software vulnerabilities. We can just come in automatically, either create that node for you automatically based on online feeds and whatever else. So it doesn't have to be manual, but like at this point it is manual.
Questions still? Going once, going twice. All right, thank you very much.
Thank you.
Thank you.
Talk at 12:05.
Did you go over? At 12, right? Okay, so we're All right, everybody, talk's gonna start. Find your spots. All right, next talk is from Ishan from Microsoft. I think we should start this off with a round of applause to get him to get going.
Testing, testing. Okay. All right, hey guys, my name's Ishan. I have a background in AI and now I work as a software engineer at Microsoft. So I'm going to be talking to you guys about running inference, fine-tuning, and RAG on Kubernetes. So we've built something called Kaido, and that allows you to really efficiently run AI workloads on Kubernetes the easiest way possible. So I'm going to show you how that works. So we'll start out with some background, then we'll get into Kaido, the design of Kaido, the future roadmap, and then I'll leave time for Q&A. So just to give you some background, yeah, neural networks are not new. AI is not new. Like since the 1990s, we had simple n-gram models, and n-gram models are just ways that they could look at the past n words and then probabilistically determine the next word in the sequence. So when you type on your phone, it can give you a recommendation on the next word. Those are just simple n-gram models. Then we transitioned to the 2000s. We had neural networks. So those allow you to, the big thing that we were able to do was take words and represent them numerically as vectors. And that's that's word embeddings. That's still a huge cornerstone of LLMs today. And then, of course, we start to get more powerful models, so they're more context aware. And then finally, we have LLMs, which are powered by the attention mechanism. So they're powered by the transformer architecture, which was released in 2017. And I mean, not only are they super context aware, but they're also really accurate. And they're really able to understand the context of what you're trying to say, even without you needing to say it. So it's super, super impressive. But obviously, there's limitations, right? So these models are huge. GPT-4 has 1 trillion parameters in it. Various open source models will be in the billions of parameters. And as the model sizes get bigger, the number of tokens you need to train actually goes up exponentially. So it's super expensive to do inference, to do training. And I mean, for example, GPT-5 is rumored to have 10 times the amount of parameters. So it's like, with 10 times the amount of parameters, it's going to cost 10 times as much per inference call, roughly, right? So, this, in essence, in a practical sense, this is an infrastructure problem. And we need to solve this from an infrastructure perspective. And this is why we believe Kubernetes is the best solution. So why would you want to run LLMs directly on Kubernetes, right? That's the next question. Obviously, I want to address there are hosted solutions. Like there is Azure ML, there's AWS SageMaker. There are solutions that abstract away Kubernetes. And they provide you an endpoint or something that you use. So with regards to Kaido, with what we're presenting, why would you directly want to run LLMs on Kubernetes? Well, you can bring your own data. You can bring your own data, you have your own infrastructure. So in terms of data and security compliance, you get to control the sensitivity there with that. As you can also control the localization of your data, where your data is located, what permissions you have on it. You obviously also have the observability over your own infrastructure. So you get to actually see what you're doing. You get to set quotas for your infrastructure, and then you have the customizability. You could all the networking settings, the configurations. You're getting to bring your own infrastructure, and the community is completely ready for you to do this. I mean, Hugging Face has all the models, the benchmarks, the data sets, and there's a whole bunch of ML engines out. There's VLLM, Onyx, DeepSpeed. So the case for using Kubernetes is clear, but it's not easy, right? I mean, Kubernetes is hard, and AI is hard as well. So you need to be able to, obviously, when you're running AI workloads, you need to maintain large model weights. I mean, billions of parameters. You need to be able to host these models somewhere. You need to have the GPU infrastructure for the models. You need to, parameters. You need to tune the parameters for inference, for fine-tuning, for RAG. And then, of course, you need to be able to know about the specific NVIDIA drivers and configuration and libraries, and then you have to set up a server in the end. So this is where Kaido comes in. I mean, we want to take all those trivial things, those unsexy things that you have to do, and make sure that you don't have to worry about it, right? So Kaido stands for Kubernetes AI Toolchain Operator. So we obviously use Kubernetes. As I was describing earlier, we're not a like Azure ML or SageMaker. We're a we're not a platform. We're a CRD. We take the CRD approach. We're literally we're a controller, right? And then obviously we streamline your workflow, so we take care of all that stuff that I was describing earlier on that slide. You wouldn't want to have to do yourself. And this is really what's so cool. This is the example. This is our CRD, the workspace CRD. This is the magic of it. It's super, super simple. I mean, all you need to do is specify the SKU that you want to use and the preset here, which is the model that you want to use. So, I mean, it can't get more simpler than that. I mean, we pre-provision the GPU for you, and we install the NVIDIA drivers and all the configuration that you need. And then we have images. So these are preset images that have the model weights in them. They have the workload and runtime configurations. We take care of running the service and the deployment. Depending on the model, we'll use a stateful set as well, like for sharding. So we take care of all the setup there with the model architecture, making sure that it can run correctly. And then, of course, if you do want more flexibility, we do have the option for you to use a preferred node. So you could use your own node. And you could also set a custom template. So you could include your own Python template if you do want your own Python server code, if you do want that flexibility there. How do we provision nodes? So we use Carpenter Core APIs, so that's vendor agnostic, to provision our GPUs. And that allows you to specify. So why would you do that as opposed to auto-scaling? Auto-scaling, you have pods stuck in pending, and then that triggers scaling up nodes as opposed to specifying them up front. This allows us to do some pre-flight validations. We actually check if the model can run on the hardware that you specify. We check if it has enough GPU memory, so we're literally taking care of that. And yeah, we also give you the flexibility to use whatever SKU you want because we're pre-provisioning it. One thing is that we do store the model weights in the images themselves, and this is something that was done intentionally. In terms of so the model weights are never changed. We're only reading the model weights, whether it's for inference or RAG or fine tuning, and so we don't. For simplified version control, we store the model weights in the image itself, as opposed to putting it in blob storage or something like that, because if we did that, we'd have to create some version control mechanism to be able to then update our images. And we also do this for ease of distribution. By keeping the weights in the images themselves, we can allow MCR to replicate the data in different regions and be able to distribute the images easier. It's more cloud native friendly that way. So yeah, that's what we do there. And so then this is the example here. This is we host the images, right? So we host them on MCR. The images, but those are images that are only Apache 2 or MIT licensed model weights. So those are public. So yeah, it's all hosted for you. So that includes Falcon. We have Falcon, Mistral, all the Phi models, and perhaps a couple others that you can see. I'll share a link later. Okay, sadly, not all models are Apache 2.0 or MIT. So Llama, for example, is a private model. And if you do want to build your own image with your own model, you can. We give you a Docker file to do that. And you can simply build your own image, but you'd push it to your own container registry. And then we would just pull it from there. So ACR or whatever container registry you want to use. I'm not going to spend too much time, but this is just a diagram of how everything works. So the big thing to take away is step 1 there, which is you creating your CRD that I was showing earlier. That creates the workspace. CR, which goes ahead and creates the machine CR, which creates the actual GPU for you. And that GPU node will then pull down, if it's a public model, it'll pull it down from MCR, otherwise it'll pull it from your private registry. And there you go. Then you can run your AI workload. But the real big thing here is that it's like the easiest way, especially that I know of, like the easiest way for you to get started running an AI workload on Kubernetes is you just install our Helm chart and you just, because we're hosting the model weights and everything for you already. So it's the easiest way to get started. And we also support RAG and fine-tuning now. So it's not just inference. You can run RAG workloads, fine-tuning workloads. Are you guys familiar with RAG? I think, OK. I can give like a very quick primer. This is an example I've used before, but it's, but like one of the examples I like to use is like if you ask ChatGPT, what is my favorite meal? GPT has no idea what your favorite meal is, obviously, right? So if you also had a vector DB with all your DoorDash history in it, now you could provide like context for GPT. So now what happens is you prepend to the prompt, what is my favorite meal, the DoorDash history that you have. And now GPT knows, like it can answer what that is. So that's essentially what RAG is in a nutshell. It allows you to prepend context to the prompt that the model otherwise wouldn't know, right? So that's what RAG is, and it's super popular now. And the other method that people use for getting additional, the other method people use for trying to take base models and solve specific problems is fine-tuning. So we support LoRa and QLoRa as well. So what that does is you take a base model which already has generalized knowledge, and then you add adapters. They're called adapters to it. Adapters are just they represent 1 to 2% of the original base model's model weights, and you literally add them on, and it allows you to specialize for a specific task. So if you can have LoRa adapters for coding is a popular one. So now your LLM is specialized for coding once you add those adapters into your model. And we can talk more about that later. But I hope that gives like enough context there. So this is what I really want to talk about here. So this is what it ends up looking like. This is what our fine-tuning CRD looks like, and this is what ends up happening. Again, super simple, right? We have, so just like we had presets before, you specify a preset, you specify the method, either LoRa or QLoRa, and then you specify your input data source. So this is where we download the data from. So it's just like either a set of URLs or it's an image. And then we have the output image here. So we'll just push to whatever container registry. And this output would be the adapter. So what I was talking about earlier. And that adapter then gets added onto the model. So now you might also be wondering, where do you put like the fine-tuning parameters like epoch and learning rate and stuff like that? That goes in the config template. We already have a default config template for each model that we provide with like just basic settings. But if you want to customize it, you can, and you just make a config map and you just apply it. So yeah, you can get up and running with fine-tuning like literally like that. And then what ends up happening is we create a job. We download the data first, your fine-tuning data. We run the model, and then when the result is outputted, we have the Sidecar container that pushes your output to ACR. So, super straight, and we can come back to this and answer any questions. And then this is the next piece here. So once you've done that, now you have these adapters. You want to add them onto your model. This is all you have to do. You specify the adapters you want to add. And we have a field called strength. By default, it's 1. You don't have to add this, but nowadays people are adding multiple adapters and playing around with that. So we have the ability to do that, and you could specify strengths for each of them. It's commonly used in stable diffusion a lot, but also in LLMs, people will use that. Okay, and we can come back to those slides if there's any questions. Okay, this is the last part. I was going to talk about RAG. So we do support RAG. There's a couple different components of RAG. There's obviously the storage. So we have a vector DB. By default, we use FICE in memory. But we also support ChromaDB, and we're supporting Cosmos DB as well now. And so that's remote storage there. As far as the embedding model can either run locally on the hardware that you specify, or we can have it run remotely, either via URL, or these days actually Hugging Face even can give you an endpoint that you can use to run an embedding model. Embedding models are a lot easier because they're only in the hundreds of millions of parameters, not in the billions of parameters. So you can even run some of them on CPU as well. Then we have the inference. So inference is just going to be a URL. The vision here is that it could literally be a Kaido workspace, is just the URL. So you have a workspace, CR that you've created, and then you have the RAG engine CR, and they can interact with each other. So they're like building blocks. So as far as compute resources, you specify where your RAG server is going to run, and if you do specify a local embedding model, that'll also run there. And then we're using, I just thought I'd include this, we're using Llama Index. You can also use LangChain, but that's the orchestration library that we use for setting all this up. Yeah, so super simple. You specify the DB that you want, you specify the embedding model, so in this case it's a Hugging Face model ID, and then you specify the inference service. So in this case it's just a cluster IP of a workspace CR. And then we spin up the RAG server hits the embedding model, which is running in it, and the vector DB. So in this case, it's FICE DB, which is an in-memory vector DB. But we also support Cosmos, so Cosmos would run outside of this. This is how it should be. This is how simple it should be to do basic fine-tuning, basic RAG, basic inference. It should not have to be more complicated than this, and it is right now. So that's why this is so important, and that's why you guys should try this out. We are collaborating with upstream working groups, working group device management and working group serving. We provide our use cases, what we're working on. They give us feedback. This is the last slide I have here, then we'll do Q&A. So we released almost exactly a year ago, and we support dozens of models currently. I believe we support like 10 or 12, and we want to support dozens more. The next release will have the RAG engine in it, and we're also an onboarding to CNCF sandbox project. So we're also seeking new collaborators, maintainers. This is an awesome opportunity for anyone interested in AI infrastructure, Kubernetes and AI. And it's not crazy complicated either. It would be a good project if somebody just wants to get involved as well, or if somebody wants to do more advanced stuff, there's also opportunities there. So it'd be an awesome opportunity. That's our GitHub, and I will do questions now.
Okay, so my first question is, I have multiple. Is Kaido specific to cloud providers? Can I just bring my own infra and then let Kaido do?
Yeah, it's vendor agnostic, so you can use any cloud provider. We're using Carpenter Core APIs, so you can use AWS or Azure, and if you want to use GCP, you could specify a preferred node. So you can use any cloud provider. I believe so as well. Yeah. The question was, can you use any cloud provider? Is it cloud agnostic? The answer is yes, it is. So we use Carpenter Core APIs, so we can use AWS or Azure. For GCP, you'd have to specify a preferred node. So you would have to provision the node yourself, but once you do that, you just specify it in the spec, and we would take care of using it. Yeah.
How's it going? Thanks a million. AI novice here, but what I do know is that the preferred kind of toolkit for running AI workloads in Kubernetes at the moment is Kubeflow. I was just wondering, first of all, how does this kind of compare to Kubeflow? Would this be kind of like an equivalent kind of offering, or does it kind of fit better as a component of Kubeflow? Because I understand that Kubeflow is just a set of components.
Yeah.
Secondly, one of the things that you said a good few times is that this is very, very simple. And one thing that I do know about Kubeflow is that it's very, very hard to at least get set up in Kubernetes. So how does it fit in?
Yeah. So I'm not an expert on Kube, but I know there's Kubeflow, and I know people use, I think it's, Ray as well, right? Kubeflow, I have tried getting set up with Kubeflow. I did run into issues. They have their own, I think parts of the project are archived, but they have their training operator. So I know people use it for training a lot. I don't know if it supports inference, and I don't know how they're taking care of. We obviously put the model weights in the image itself. I think you would have to build your own images, I'm guessing, to then use Kubeflow, and then you'd have to make sure that they're compatible and you build it in the right way. So I do think it's from what I remember using it, it's fairly complex to get set up, and I wish I knew more about that, but yeah, that's.
So you're using Carpenter to do auto provisioning, but how are you doing auto scaling across so many different frameworks that when you want to do fine tuning and want to do RAG, I don't know how you would take a look at the load and determine that you need more nodes in your node pool.
Yeah, that's a great question. We currently don't support auto scaling for that reason. We are still working on that. We do have metrics that we've started to gather with GPU usage, and based on that, we will determine auto scaling, horizontal pod auto scaling, and then from there, we're also working. Some members of our team attend a lot of the DRA meetings because that solves a lot of the issues there with auto scaling as well as MIG. So we still haven't. That's still a complex issue, and that's obviously the next step is being able to auto. I think everybody's working on that right now. The whole Kubernetes community is. So yeah.
More questions?
Can I just, while deploying or using a model, can I just specify any Hugging Face ID and then you pull the model, or it has to be a container image to be able to use that model?
So yeah, like a Hugging Face model ID? Yeah, so if it's not one of the presets that we support, you can build your own image using a Hugging Face model ID. So we provide the steps for how you would do that. So yeah, if it's not one of our supported models, you can just download the model from Hugging Face and use it. You could just in our Docker file, and it'll build it for you.
And a lot of models, depending on how they're trained, they also have different backends, right? So how do you differentiate between what backend is supported and what's not? There is CPP, Llama CPP, and then there is.
Okay, yeah.
There are a bunch of them. I don't have a lot of experience, but from what.
Yeah, there's different quantized models. There's GGUF, GGML. Right now we use. I actually should have mentioned this. We use VLLM to run our models, so it does need to support the VLLM engine. However, we also have there's a setting. If you don't want to use VLLM, you can use Hugging Face Accelerate library as well as the runtime engine. So those are the two runtime engines we support: VLLM and Hugging Face Accelerate. If you don't use one of those two, so for example, if you're trying to run Llama CPP, we unfortunately don't support that. right now. But you can use Llama, the non-quantized version. And we do want to support more engines, Onyx, DeepSpeed, and serving frameworks as well. But yeah, that's all we support right now. You have a question?
Can you tell me a little bit more about pre-provisioning the nodes? What do you mean by pre-provisioning the nodes over there?
Yeah, pre-provisioning means that I feel like it's more complex than it needs to be. We just make the node for you in advance, as opposed to auto-scaling, which is you create the pod and there's no node, and it's stuck in pending, and that triggers creating a node. Does that make sense?
So like when I'm deploying my inferencing, you will provision a node and
yeah, we already know that you need a node, and we'll make it for you.
Because I'm deploying inferencing, right? I'm deploying the inferencing. That's why you know it.
You're specifying it up front that this resource I want created, I want my code to run on this.
Okay.
Yeah.
Yeah.
We can chat after.
Yeah, sure. Yeah. Just to add that, Kserv is the serving side of Kubeflow, and it also does VLM and Hugging Face Accelerator. So I think this is the same model.
Right.
Yeah. So right now, with respect to allocating a GPU, do you like allocate the entire GPU? How do you know, like, or can users specify? Can they even specify like a less than one kind of like one GPU using MIG or whatever?
We were trying. We're working on MIG right now, but right now we use the whole. It's like one pod per node, so we use the whole GPU. With DRA, we hope that will become a lot better because you'll have MIG instances. You can schedule different things. Things can get shuffled around, and that'll make for a much more powerful, heterogeneous environment. Yeah.
What is the recommended node size for run these models?
Yeah, so that's a good question. We have some benchmarks that we did about that. So some of the 7 billion model parameters, Falcon 7B, Mistral 7B, you can run in a 16 GB V100. However, once you get to, it grows linearly. Once you have larger context length, you're going to use more GPU memory. So if you test the upper bound, you can get an OOM. So now what we have, we actually included this in our VLM code. We test what's the max model length that you can use with that GPU that you provisioned, and we cap it at that. So we make sure that you don't OOM because we make sure that, you don't go out of memory there. So that's a really good question. That's something that we take care of. Yeah.
More questions? All right. Going once, going twice. Thank you very much. All right, it's lunchtime.
caption test, open caption test, open caption, open. Testing 1, 2, 2, 3. Testing 1, 2, 2, 3. Testing 1, 2, 3. Okay.
Good afternoon. We're about to get ready with our afternoon track here. We're going to be listening to Jeremy Louis. He's going to tell us why all platforms need AI Copilot components. Our talks here this afternoon are going to be 25, 30 minutes with another 5 minutes of Q&A. So make sure you have your questions ready. I'll come around with a microphone and make sure that you get your questions answered. Jeremy, take it away.
Great. So thank you all very much for coming today. I'm going to be talking about why software platforms need AI copilots. And there's really two things I want you to take away from this talk, or hope you take away from this talk. The first is that this is a very principled use of AI. We're not just jumping on that AI hype train. And the second is, what does it actually, how can we actually go about building these AI copilots? And so to get started, I'm going to give you a demo of an AI copilot I've built, which is foil.io, and helps you operate your software. So this is my Hello World service. It is deployed and running in production. That's how you can tell from the prod path. This service is incredibly simple. It just gives you hello world every time you access the page. We're using AI to generate this greeting. We're using AI because why wouldn't you use AI today to generate hello world? So you can see that every time I reload the page, I get a different greeting. So everything's nice and working well in production. But let's check staging. So we're getting that no healthy upstream error. So now what I'm going to do is I'm going to go ahead and debug and hopefully fix that issue. And as I do that, I'm going to show you how Foil, this AI copilot, can help you do that. So to get started, I go over to VS Code, and I create a document, which is a markdown document. And I'll call that fixstaging.md. And since I'm using an extension called RunMe, this Markdown document opens up as a VS Code notebook, so I can start writing Markdown cells to describe the problem in my thought process, as well as code cells that I can actually execute to accomplish different tasks. And since it's a Markdown document, this produces an artifact that I can share, for example, as my postmortem or to attach to a bug report. So to get started, I'm just going to start a Markdown cell, and I'm going to describe the problem I want to fix. So in this case, fix staging Rube service. Why am I getting no healthy upstream error? And so what you'll notice is that as soon as I start typing, I get this go cell. This is a light, that was the text that was lightly grayed out in a code cell. And this is the suggestion from Foil, the AI, about what commands I might want to run in order to accomplish my intent. So this experience should be very familiar to anybody who's used any of the existing Copilot tools out there, like GitHub Copilot. The only difference is instead of completing your current cell or from where your current cursor is, Foil is going to actually suggest new code cells. So in this case, Foil is giving me a helpful logging command to fetch the logs using gcloud. And there's a couple things that I want to point out about this suggestion that came from Foil. If we look at this query, we can see that there's some query clauses that indicate some knowledge of how the Rube service is running and how it's deployed. So the first clause is it's filtering down to the logs that come from Kubernetes containers. So it knows that I'm running on Kubernetes. And it also knows what the labels schema for my service is, because it knows how I've labeled my, my pods in order to identify both the application as well as the environment. And so this happens because every time you execute commands inside RunMe and Foil, Foil is constantly learning, and therefore it learns about your platform and infrastructure. This is critical because everybody's platform and infrastructure is different. And so if we want the AI to give us helpful suggestions, it needs to know how we're actually running and deploying infrastructure in our systems. So let's go ahead and run that command. And so this is one of the really nice things about RunMe is that we've created this single pane of glass for operating things. And this allows us to execute commands directly from the notebook. So we can see here that the logs are actually empty. And the logs are empty because we were filtering for errors. So there was no errors in our logs. And so what happened next is we got another go cell. And what this go cell is, this is Foil analyzing the output of the previous steps and telling us what we should do next. And so in this case, because we got no errors inside our logs, Foil is suggesting that we should look at the pods next. So let's look at the pods. And we can see that we've gotten an error. Just see 1 second. And so what we got next was we got another go cell, which I have accepted. And this go cell is Foil analyzing the error, the output, and telling us what to do next. So in this case, you can see that Foil is analyzing the error and telling us the pod has an invalid image name status. And this suggests that there might be an issue with the Docker image name specified in the deployment manifest. And that to resolve this issue, we should look at the image name in order to see if it's correct or not. And it's given a bunch of commands to us to actually go about looking at the actual pods. But in this case, I'm going to give Foil a little bit of a nudge, and I'm going to say, use kubecontrol to just get the image name from the pods. And I'm going to do that mainly just because it's going to be easier from demo purposes to see what the output is. So let's go ahead and execute that. So here's the image name that it's being used. And we can see that there's a couple problems here with the image. First, the separation between the image name and the tag is the @ symbol, which is not correct. It should be the colon. And there shouldn't be a period in the v1 command. And so we have to fix the image. And it looks like Foil has helpfully given us a command to fix the image. Let's go ahead and run that command. So it's updated the image. Now let's check the pods. Let's see if it's trying to get. So you can see that it gave us the wrong command. It gave us the logs command. So let's see if we can do the get pods. So now we can see that it looks like our pod has started and it's nice and healthy. So let's go back and check. So great. Our staging service is back up and running. Let's try our dev instance. So our dev instance is also down and unhealthy, and it's giving us the exact same error. So let's go ahead and debug that the same way. So we'll go over here. We'll create a document, fixdev.markdown. So not surprisingly, we're getting the exact same suggestion from Foil that since we have the same problem, we want to probably start off the same way, which is by checking the logs. So let's go ahead and execute that command. So this time we see that something different is going on because our log's showing an error. And so what's happening is we can see that there's an error inside the logs, and that error is indicating that there is a problem accessing the secret in Google Cloud Secret Manager. Because remember, we're using AI to generate the greeting. In order to do that, we need an OpenAI API key. That key is stored in Google Cloud Secret Manager, and therefore we need to make sure our pod has permissions. And so what Foil is telling us is that the next thing we need to do is to check the service account configuration to see what's going on. And we can see here that it's made another slight mistake in the analysis here. It's looking at the default service account, and we actually want to be using the Rube service account. So let's go ahead and run that. So we've gotten that command. And so here we have now an analysis of what's going on. And so it's telling us that the logs indicate that there's a permission issue with accessing the secret, the Rube dev OpenAI API key. So it's pulling that out of the logs. And it's telling us that we need the permission secret manager versions.access. And so it's telling us that to debug this, we need to check the IAM permissions on the service account to see why we don't have the correct permissions. And it's given us the IAM command. It looks like it made a mistake in the service account, so let's go ahead and fix that. So we ran that command, and it's given us that, and we're seeing that we don't have any bindings except for the workload identity user. So next, Foil is analyzing that, and it's telling us that we need to add the secret manager secret accessor role. And if we look, we can see that it's actually given us a Google Cloud command to add that IAM policy. That command is correct, but we don't actually want to use it because we're actually using Terraform to manage our IAM policies. So we'll give Foil a nudge. We'll say use Terraform. And so we can see here that it updated it. And so now we have a Terraform policy that it's adding to our Terraform file. It looks like it got the secret wrong. So we're going to go in and fix that. So now we're just telling it to apply the Terraform policy. So we're just waiting for it to apply. Looks like that is successfully applied. So now we will restart the pod so the changes take effect. So it looks like the pods have restarted. So now let's check them. So it's suggesting the commands to check the pods. It looks like it got the label wrong. So let's fix that. And I think this is one of the important things about the experience that we've tried to create with Foil is AIs do make mistakes. And so we've tried to create an experience where it's very easy to interact with the AI and correct it when it makes mistakes while still getting value. So we can see that our dev pod is up and running. So let's go back and check it. And great. The dev service is back and healthy. So hopefully that demo showed you that, like, hey, if we have these AI co-pilots, they can really help us walk through the problems that we're trying to solve and help us figure out what are the individual steps we need to run in order to accomplish our intent, and that the AI will automatically adapt based on the output and the actual situation that we're dealing with. So now let's talk a little bit more about the why and the how that underpins this. Let's start by why use AI. There's a lot of hype right now around AI. It's not unlike Kubernetes maybe 5 or 6 years ago. And it's easy to think like, hey, we should just sprinkle a little bit of AI fairy dust on whatever problem we have, and it's going to magically be solved for us. But I think in this particular case, we're using AI in a very principled way. We have a problem that is well suited for today's technologies like LLMs. And so I hope you walk away from this talk with an answer to this question that really shows that this is a principled use. So I'm a software engineer. My job is relatively simple. I start by writing software. I then ship this into production. And then we make money. And today, in large part because of AI, writing software has never been easier, right? We have all of these co-pilots and AI assistants that make it super easy to write code in languages that you may not even know, and very easy to help you learn them. And so in our case, for that Hello World service, any of the assistants can write that code very easily. But when it comes to shipping this software and operating it in production, it's still a little bit of a nightmare. We're still solving this not so much with AI, but by giving our application developers a whole bunch of tools, as kind of illustrated by the CNCF landscape. And we're kind of saying, have fun. Like, figure out how to use all these tools to solve all of the problems you have with them when the operating and that software in production. And we can see that if we look at what does it take to actually get this Hello World service into production. So I wrote some Go code. And once I had that Go code, I had to build a Docker container and push it to an artifact registry, which I did using Co. Since I wanted to deploy this on Kubernetes, I had to create a Kubernetes deployment resource and also a Kubernetes cluster if I didn't already have one. Since I needed an OpenAI API key, I had to put this into Google Cloud Secret Manager. I then had to create appropriate IAM policies and workload binding in order to give the deployment pod access to this secret. And then to actually expose this to the world, I had to create all these networking resources. I don't think we can solve this complexity by building more tools, because we've been building tools for the past 20 years to try to simplify operating and deploying our software. And it's kind of how we wound up in the situation we are right now, where we look at the CNCF landscape and we're just overwhelmed trying to make sense of all of that and figure out how to accomplish our tasks. So I think in order to make shipping and operating software easier, we need to make it easier to use our existing tools and to make them more accessible to application developers so they can focus more on the application and business problem they're trying to solve and not this burden of learning all of these tools. I think the way that we make tools easier to use is with playbooks. If you have a playbook that tells you exactly what you need to do, then you can just sort of copy and paste the commands and sort of blindly follow that playbook. So for Hello World, you can imagine I have a playbook that tells me, step 1, run co-build. Step 2, run kubecontrol apply for these resources. And step 3, run Terraform apply to create all of the cloud resources that we need, like the IAM policies. the problem is we can't keep up in terms of writing these playbooks. And the problem is, because of all of these tools and complexity these days in cloud and Kubernetes, we have combinatorial complexity, where depending on what you're trying to do or what kind of tools you're doing, there's all this different branching that could be going on. And hopefully you got a sense of this from the demo, because we had 2 different cases where we had the same exact error, no healthy upstream. We started off our debugging process the exact same way in both cases by getting the logs. But then based on whether there was an error in the logs or not, we started going down different branches. And this process of branching would continue at every step of the process. So we no longer really have linear information flows, which makes it really difficult from a documentation writer to figure out how do we organize and structure this information. And it's also really difficult from the reader to try to figure out how do I follow this choose your own adventure process to figure out how to actually accomplish my task. So this is a problem that I think generative AI is perfect for solving, because I think we can use generative AI to write our playbooks. And it's not just that we can use generative AI to write our playbooks, we can do so dynamically and sort of generate our playbooks just in time so that our playbook is personalized and adapted to the specific issue that we're seeing. So it's analyzing based on the output of the commands we've just run what we need to do next. And the insight really here is that this is basically a sequence prediction problem, which today's LLMs are perfect for solving. So if we have some intent, like debug no healthy upstream, we can feed that to an LLM and ask the LLM, what's the command I should run next to debug this? And the LLM can spit out the command we should execute. We can then execute that command and collect that output. And we can then feed that back to the LLM to say, all right, given this output, what should we do next? And so by iteratively repeating this process, we can build an AI that walks us through the process of accomplishing our intent. So all we need to do this is data. If we have these traces, these reasoning traces of intent, command, output, these sequences, we could just train an AI, an LLM, to solve our problems. So what we've done is we've created an IDE for operations using RunMe and VS Code that creates a better experience for operating your applications, because we give you a single pane of glass that combines executing commands and looking at the output, and also produces artifacts that you can share. And as a side effect of using this IDE to solve your problems, we can collect all of the data we need in order to train the LLM. So your markdown cells capture your intent. Your command cells capture the commands you needed to actually execute to achieve that intent. And we can then capture the outputs of those commands as well. So we can capture that data and use that to train the LLM. A key bit here is we really want high quality data. And the key to getting high quality data is collecting human feedback. And in Foil we do this because when we suggest a command, as is evidenced by the Go cell, the human accepts the command, and then the human can edit the command. And so we can log that signal, and based on that logging, we can identify what were the intents where the LLM made a wrong prediction, what was the correct prediction that we should have predicted, and we can then use that to retrain the AI. And if we do this, we create this data flywheel where the more you use Foil and RunMe, the more data we produce. The more data we produce, the more we can retrain and produce a better AI for assisting you. As the AI gets better, you derive more value from it, and you're going to be more inclined to use it, thereby producing more data. It's very early days for Foil and RunMe but I find that when I use it, it saves me a fair bit of time. So I estimate it saves me about 20 to 40 minutes per day. And this is based on the number of times it makes a suggestion that I end up accepting. So at the bottom of the slide, you can see a graph of how many suggestions it makes each day that I accept. And right now, it's about 20 to 40. So I could really use your help. I'd love for you to try it out. The folks at Stateful have created this amazing sandbox, which is at this URL, stateful.com/foil, or the QR code will take you directly to it. You can basically open it up in a web browser, and you can try out RunMe and Foil without having to install anything locally. But I also love it if you tried out and Foil yourself, if you wanted to try it out on your own machines. It's very easy to install. You have to install the VS Code extension for RunMe, and then you download and run the Go binary for Foil. So everything runs locally, so you don't have to worry about sending any data to anybody else. And after you've tried it out, I'd love it if you provided feedback. You can find us on GitHub at jlouis/foil. I'm on Blue Sky, jeremy.louis.us. That's also my email. And then really, I'd love to talk to people here at KubeCon. I'll be hanging out at the Stateful booth, which will be S51. Just a couple quick shout outs. I really want to acknowledge the Mozilla Builder Accelerator, which has been graciously funding my work with a grant. And then Stateful and RunMe, which is the open source VS Code extension that provides the front end. They've been really great partners. And with that, I will pause and say if you have any questions.
That was super interesting. Thank you for the talk. One of our challenges that we've seen in kind of using AI for platform is that many times the commands are out of date, especially once you're trying to troubleshoot harder things. What's your take on that? Like, is that something that you've kind of feed the model to have newer data, or is it more just waiting for it to catch up? So I think when you use this approach, right, it changes what it means for us to be as platform engineers. So if I think about platform engineers, the two terms that constantly come up was paved path and guardrails, right? So you can imagine we have a better way of we have an old way of doing something, and now we have the better way of doing something. And now we really want the AI to come up to speed so that it starts spreading that knowledge around. And so what I think that means for us as platform engineers, it really means how do we curate the AI so that it quickly learns the new way of doing things and spreads it. And so I think the way that we achieve that is by retraining the AI, but also using data curation. So we can, if we have examples of like running the command or achieving the intent using the old way, then as platform engineers, we want to start curating that data when there's a new way, rewriting those examples to use the correct new way, and then using that data to retrain the AI. So that's how I think we solve that problem.
This was a really interesting talk. Thank you for that. I would love to get some context on like how Foil works behind the scenes. Like you could see in the commands, it knew that you were running gcloud and it knew the labels of your pods and all. So are you basically like reading the code in the directory and then maybe sending it to OpenAI API and then getting a response? Like how are the responses actually generated? Yeah, the AI is actually very simple. We basically use context-dependent few-shot prompting, right? So that's a little bit of a mouthful. It sounds fancy, but it's very simple, right? We basically have a RAG database of past examples of intent action pairs, right? So what was the intent? Debug no healthy upstream. And then what was the actual command that you ran, such as the gcloud command? And then what happens is when you execute a command, we look up relevant examples as a way of informing the AI, and then we feed that as a prompt to OpenAI or whatever model provider you choose. You can go check out the prompt in the repo. It's fairly simple. We basically say, continue writing this document, right? So suggest markdown cells or code cells to add to it. And here's a couple of examples of similar documents or fragments of documents that you might be helpful. So that's it. It's pretty simple.
We've got time for one more question. Anybody else? Great.
I'm just wondering how this meshes with like opinionated systems that kind of sit in front of, platforms or infrastructure. So guardrails type systems.
Yeah, so I think if you have existing tools, it should play well with those, right? So we've tried to create an experience that works really well with CLIs and all the APIs that you can interact with via CLIs. So if you built like some higher level CLI rather than like kube control or to like produce configuration according to some guardrail or paved path for spinning up applications, Foil would learn that. So when you say like, give me an app template, it would use your custom CLI or et cetera to do that. So I think it would play very well.
Great, super interesting talk. AI is such a big theme. So thank you so much. Let's give him a round of applause.
Thank you all.
In 5 minutes, we'll be starting back up again with a talk about K8s and Postgres.
Thanks.
So good. Come in. I can see you standing there. Come in the door. Oh, I scared you away. All right, we're gonna get started in just a minute. We've got Leonardo and Gabriele. They're here with us this afternoon. They're going to be talking about maximizing your microservice databases with Kubernetes, Postgres, and Cloud Native PGs. So pay attention. We'll have a couple of minutes for Q&A at the end. I'll leave it to you, gentlemen.
One, two, 1, 2. Yeah, now it works. So if you're planning to run Postgres databases now, it's important to decide where to run the database, but also the reasons behind that decision. So why? So nowadays there are so many options. Most of them are outside Kubernetes. So for example, public DBAs or traditional VM setups. But one option that is becoming very, very popular is to run Postgres inside Kubernetes. This approach brings an enormous benefit. We call it cloud neutrality. There's going to be a blog of mine on the CNCF blog next week about this topic. And cloud neutrality for PostgreSQL allows you to run it everywhere, removing vendor lock-in and allowing you to port the data anywhere. So welcome. My name is Gabriele, and today with Leonardo we'll talk about running Postgres inside Kubernetes with Cloud Native PG. And also we will talk about an extreme use case, running Postgres as a microservice database directly integrated with your application. So I'm Gabriele. I've been using Postgres for over 25 years. I'm a Postgres contributor. I'm also Data on Kubernetes ambassador. And I'm a big DevOps and Lean fan, and they are the reasons why I came to Kubernetes. I'm an open source contributor, and I have contributed to Barman. I'm the founder of Barman. It's a popular open source backup and recovery tool for Postgres, and also Cloud Native PG, of which I'm a maintainer with Leonardo. And I work for EDB as Vice President, Chief Architect.
Hi, I'm Leonardo. I work in EDB as Gabriele. I'm a principal software developer. I'm a Kubernetes CSI member and contributor too, so it's really great. And I'm a maintainer of Cloud Native PG, and I work for Cloud Native PG in EDB too. And I've been using Postgres for many years. Yeah, that's it, you know.
So just a reminder that tomorrow, as a Data on Kubernetes ambassador, I invite you to come to the Data on Kubernetes Day. And also, if you're interested about the Data on Kubernetes community, if you scan this QR code, you can learn more about this community and you know, our initiative to run stateful workloads in Kubernetes. Thanks, Leonardo. This is also a talk that a panel I will be part of on Wednesday. And you're more than welcome to participate about the future of DBAS in Kubernetes. So first part, I guess everyone knows Postgres. Is anyone in here that doesn't know Postgres? Okay. So I just put some reasons why people use Postgres today. It's the most popular database in the world. And so I'll just move forward, okay? So I want to go through the 5 eras of Postgres deployments. Okay, we started on bare metal, then we progressed on VMs, then infrastructure as a service, so VMs on AWS and so on, and then the DBAS options came. So this is a very popular option to run Postgres on, for example, RDS or Azure Cloud and so on. What I'm going to focus about is this new era, which I call cloud neutral, that is based on Kubernetes, both as a self-managed Kubernetes or a KaaS, Kubernetes as a service. That's why cloud neutral is an important concept because we can use the same resources and port what we create on everywhere, on private, public, hybrid, and multi. So Cloud Native PG, in a slide, it's a production-ready operator. I want to stress about the license and the vendor neutrality and the open governance of the project. That's why it will always free. It will always be free. It was originally created by ADB, which is also one of the major contributors for Postgres. Our mission is to run Postgres everywhere. And we applied for the sandbox a second time 2 months ago. So hopefully this time we will get accepted. You can install it everywhere, but you can see in 2 years we've reached about 4,600 stars on GitHub and 60 million downloads for the operator. Of course, the reason is that it's used in CI/CD pipelines, which is one of the main reasons why we had the operator. Briefly, this slide is here only for this QR code. If you want to know why we don't use stateful sets and we use directly PVCs, this is the reason. It's explained in that page. So I'll move forward. So Cloud Native PG in a minute. Cloud Native PG is described by this CRD, okay? There's a cluster resource. We follow convention over configuration. In this case, I request 3 instances for the Clapton cluster. We set affinity. We also set synchronous replication, which is a concept in Postgres because we don't use storage level replication. We use stream replication in Postgres. And 2 volumes, one for the storage and one for the write-ahead log, which is the transaction log. So what happens is this. Once we create the cluster resource, and suppose we have a Kubernetes cluster with 3 availability zones and multiple nodes with the Postgres labels, we start with the PVCs. Then we start the Postgres primary on top. This is one of the reasons why we control directly PVCs. Then the read-write service is created to point to the primary. Then we create the first standby and the second. And one is synchronous and one potentially synchronous. And then the read-only service. So what happens if there's a failure? So suppose the first worker goes down. The controller basically removes the pointer to the former primary, promotes the new primary, and automatically redirects the endpoint of the service there. Then, when the other worker node comes back again, the operator transforms that into a standby. So let's go quickly over the main use cases. This is normally the way you run Postgres today. Okay, you write your own application, you have your CI/CD pipeline, you deploy the application in a Kubernetes namespace, but you're afraid of running Postgres in Kubernetes, and you access a database in the cloud, for example. The second one is whether you decide to use Kubernetes to run Postgres, but you are afraid to run it inside the same namespace of the application, and you provide, for example, an internal dbus service. What we want to bring today is actually the reason why we created the operator, is to run the database together with your application. So when you create a feature for your app, use the database, use Kubernetes to test the feature you deploy and enhance the velocity of your application and make it more robust. The idea is to rely on you can leave, you can go ahead. Postgres has this feature called transactional DDL. So you can begin a transaction, create tables, or destroy them, and then roll back, and nothing happened. So if you have a 10-step migration, you can begin the transaction, do all the steps, and if one fails, you can roll back. Here I put the main DevOps capabilities, which are in orange here, that you can actually implement with Cloud Native PG. So let's start from the left. You are the developer. You write your own the code for your application locally. You run tests locally. How? With kind. You can use Cloud Native PG with kind to test your application. It works. You issue a pull request of your application with the feature you developed. You have automated pipelines. So these are DevOps capabilities. Version control. You have Git, test automation, and shift left on security, because maybe you also scan for the code or for the container images that you build. And then you use the same container images to run end-to-end tests. So you build container images in your pipeline, and you use the same environment. Okay, no variability. That way you can apply continuous integration and also test database change management with migrations through transactional DDL I was mentioning. When everything goes well, you merge your main, continuous delivery. So it's your posture to make sure that your software is always running the best version of it. And trunk-based development. You can find them out. Okay, you can search for these capabilities. They are very well known. And then depending on the release policy, you publish on a public registry or your local registry, and you deploy. You can have automated deployment and ensure that database change management is part of that. And then the end user. Remember, lean. Lean is about creating a highway between you, your product, and the end user. So now I think it's your turn, Leo. Okay. This is important. You have two feedback loops, one local and one with the end-to-end test. Okay?
And now we are talking a bit about how this stuff works practically. Okay, so again, this is a simplified version of what Gabriele was explaining before. It's the same cluster definition, the name changes, name PG, and here you see there are two different storage areas, one for your data, that's name storage, and one is name wall storage, that's for the transaction log. In this example, I use the same storage class. It's just an example. Since the access patterns that the storage get impacted for the two different storage are totally different, you can choose to have two different storage classes with different performances. It's fine. And let's try to, in the meantime, we are talking about this. If my friend T-Max is still here, we apply this magic PG cluster. Yeah. Okay. I'm using Cloud Native PG just to demonstrate what is going to happen, but these concepts are generic. This is just the operator I know best, and I'm a maintainer of Cloud Native PG, so that's it. Meanwhile, this is working. The first point of the database is being useful for the application. Why being useful for the application? Because this is how you help users. That's the main point. Our value added as programmers is to help people. This is why you need a database in the end, but a database per se has no meaning without an application. So database should be helpful. This is why our operator is creating a lot of resources that are really needed for just the application to connect to the database. In this example, you see this secret, PG APP. This is useful for the application to connect to the Postgres database. And then you see this RW service. This is, again, this is useful for the application to connect for read-write traffic, okay? So it will not target replicas, that service there. Let's have a look at them. Meanwhile, our friend is downloading the images, it's fine.
Of course, I forgot to mention, there's one primary only with Postgres. Okay?
Yeah.
It's primary standby architecture. but it can scale.
Yeah.
Okay.
So let's have a look at that. As you can see, it's nothing fancy. It's just your username, your password, and a set of useful URI for your application to use. Nothing fancy. But the most important bit here is that if you look inside your Postgres, I'm using the CMPG kubectl plugin to do that. It's just an exec call, nothing fancy. You see there is just one database, it's named app, it's just the default, you can name it as you like. But this is your application. Look, one Postgres cluster per application. This is the underlying concept of the microservice database. And not only this, but you have oh, maybe that's too much. Oh, this is better. A user to connect. This is the one corresponding to the secret we were looking at before.
And also, it's not super user.
No.
Okay.
Shadow.
By default, we disable super user access
Sorry.
to the database. Every change needs to go through the YAML. I actually did a patch for Postgres 17 for this.
Yeah.
Okay, to remove access.
Yeah.
To disable the alter system.
No super user, just your password, but because a reasonable question would be, okay, why guys you just don't use MTLS or integrate with Spiffy to do that? It's reasonable and you can actually do it, but this is for simplicity because there are still a set of Postgres client libraries that unfortunately are not able to log in to authenticate via MTLS. So this way you can use them. And if you want to create a certificate for your app user to use, it's just one kubectl CMPG invocation that you should do. That's it, no more. And again, we need to be useful. A database alone is not really useful because it's empty. You need a schema. And I love this quote. It's actually 1975, so I wasn't even born, but it's really powerful. And it's more, show me your tables, and I won't usually need your force chart. It will be obvious. What does it mean? It means that your schema is basically what you are perceiving about the problem you are trying to solve. So this is really important. It's, you know, a schema-less databases are really comfortable to use, really ergonomic, but I still think, just my personal opinion, that the mental discipline you have when you design a schema is useful per se, even if you choose to use a schema-less database. But you know, your understanding of the problem changes over time, and the problem changes itself. So you are going to change your schema, this is life. Nothing gets still. If something is still, it's not useful. We need to be useful. And what happens? It happens that you need to change your schema. How do you change your schema? With migration. That's the technical name for changes in the schema. But on the practical side, what kind of migrations trick can we use? Or there are two different approaches. The first one is the declarative. The second one is the change-based. The declarative is somewhat new. There is a really good product, it's named Atlas, that lets you use the declarative approach. Declarative means just everyone is used with Kubernetes here. So it's just, look, this is the schema I want to have. Your magic migration box will detect the SQL DDL to apply to your database to get the schema inside. It sounds magic. And then you have the change-based migration. This is what we are used to. Everyone is used to writing change-based migration, whether in SQL or in different languages. And that means you have a migration engine that connects to your database, get the current version, and then you have a set of scripts that are migrating the previous version to the new one. And the migration engine will apply the scripts that are needed. And then it stores the new version inside the database. More practically, the declarative migrations day one. Oh, look, I need to store a set of people. Great, let's create a table. Really simple one, and I put just the address here. It's fine, just to begin, it's totally fine, okay? And this is easy to apply for a declarative engines. Just throw inside, create the table, and you are done. Beautiful. Day two, and then you realize, oh my, there are many addresses for a person. I need to create a separate table. And I create one. It's great. My database is relational. It's just a foreign key away. Beautiful. Now I have a table. And now my magic migration box needs to migrate this stuff here with these fields that could be full of data inside this. Is it really smart enough, my engine? OK, Atlas is really good. But still, that's what is going to happen. Primary headaches. And by the way, this article is really nice to read. And why it's called primary? It's called primary in physiology because it doesn't have explanation in other phenomena. It's you have a headache because you have a headache. That's it. It could be a lot of different points why you have a headache, but you don't really know. And that's the problem you usually have with these engines, to let them understand what you are trying to achieve. By the way, still, you get an headache. Change-based migration are more painful. The day one is just the same. And just create a table, it's fine. Day two, still, now it gets more convoluted. I need to create a table. Then I need to insert in the new table every address that was stored in the previous version of the table. But look, I need to tell my SQL engine, I need to lock these rows, otherwise they are going to change. Okay? And then I can just drop the column.
This is all Postgres, SQL, standard SQL.
Yeah, okay. This is standard SQL, actually.
Very powerful.
Yeah, it's really powerful,
They
this stuff here.
Concurrent. Okay.
But again, the point is, whether engine you need to use, take care about how this stuff is implemented, because these have different performance aspects that you can use for Postgres, MySQL, whatever you like.
And these are, for example, 2 transactional DDL instructions.
The main point is begin and commit. But to do that, to do this stuff here, so you need to understand, as I was saying before, what's happening inside your DBMS. And there are people that are just vertical on that. They are called DBAs. They're these guys with long beards, pretty with people, but they are useful for this kind of stuff. And sometimes you don't have a DBA to work with. Is there a middle way? Yeah, there is one. You can use your declarative migration magic box to scaffold a SQL script for you, and then you review your script. Because we are still humans with our brain, and we need to get this value added inside the engine. That's the main point. So you can combine both approaches. It's good. It works beautifully. So now we have reached a point where we have a migration strategy. We need to understand the safety of what we are trying to do. So, what should a migration engine do? The change script should be applied entirely. You don't want to get in the middle, because otherwise you are in the middle of the bridge, and you don't know where you are. The change script needs to lead to a consistent state. I mean, the constraints must be respected before and after. And it should not conflict with other queries. Look, this is not A, B, C, D. It's magic. Once committed, should not ever be forgotten. This is the axiom 1. ACID, this is the main point. You need a transaction. You need transactional DDL in your engine. Postgres has one. So it's a really good DBMS. But should you look for another one, please ensure it does transactional DDLs. Otherwise, you are going to have
30 years.
Point.
So it wasn't implemented in a couple of years.
Yeah. You have seen migration are just SQL code. You need to test them like every other code base. What you're going? Oh, this QR code just leads you to a repo where there is this workflow fully implemented. It's nothing important, just an example of what you can achieve with this concept. But by the way, it's just set up a tiny cluster, look 2 lines. This is the syntax of GitHub. You can use the syntax you like best. Install CloudNativePG. It's just a kubectl apply. Easy. Then you wait for it to be deployed. And then you can do whatever you like with install your application and test it. You can test your migrations that way. This is really powerful. And now can you execute them? So if you have your magical migration box, it works per se, it's an operator, it's fine. Otherwise, if you don't have it, you can use an init container if you like. But the point is, in Kubernetes, we have several replicas of the application that are working all at the same time. And only one of them at a time should execute the migrations. Your migration engine should take care of that. Postgres has a primitive, it's called advisory lock, that is doing exactly that. So should you look for another DBMS, please ensure you have a primitive to use like that. Please ensure that your migration engine is using it. Otherwise, you're going to be in trouble. And then depending on the deployment rollout strategy you use, you need to be prepared for all versions of your application to cope with the new version of the schema. Otherwise, you're going to recreate all the pods and have a bit of downtime.
So, with that, and then we just conclude, and then maybe have maybe time for one question, or depending on Courtney. Okay. So if you want, there's this blog article I wrote a few months ago that recaps what we talked about today, and the key takeaways. Postgres is the most popular database. Okay, it's useful in most use cases. It will not excel maybe in some specific ones, but it will take you far in most cases. You can break vendor lock-in. So you can have a fully open source stack with Kubernetes, Postgres, and CMPG that is also vendor neutral. You can achieve cloud neutrality, so you can have your Postgres run everywhere. And my advice is to start with the DBaaS approach if you want to run it for your company, or even externally, like many companies are doing, like IBM Cloud, okay, a Cloud Pack. And then follow what Leonardo said, the microservice approach to build the quality directly into your product, achieve operational efficiency thanks to also GitOps pipelines, then velocity, and then ultimately drive innovation.
We've got time for 1 or 2 questions. Yeah?
Of course, you can visit us at our booth at EDB if you want to talk more, or talk with me and Leonardo outside.
Hey there, thank you for that.
Hi.
Very interesting. A question, maybe I'm asking too big of a question, but what does backup look like? Is there any integrate like locking tables, right, and exporting to S3?
So backup Postgres, I did a talk last year in Chicago with Michelle Au from Google. My suggestion is to go there. It covers a lot, but long story short, Postgres has an advanced backup, continuous backup. Okay, so you can do point-in-time recovery, and it works out of the box. Okay, and we support it. Leonardo is also working on Kubernetes storage for volume group snapshots. So we also support volume snapshots. Last year in Chicago, I showed how to restore 4.5 terabytes in 2 minutes, okay, in AWS. Okay, so this is just a start. Yeah, it's all done transparently. And believe me, I'm one of the pioneers in Postgres for backup and recovery. And the implementation we've done in with volume snapshots is amazing. Yeah. No fear. You know, backups. We have many users tell us that if there are problems with the operator, at least they don't lose data. Because of our PVC, we start from the PVC essentially, okay?
We are working on promoting volume group snapshot to V1 Beta 1 these days, so it will be amazing. Because they will be consistent. By the way, our volume snapshot implementation is still based on the physical backup infrastructure of Postgres. It's just not a snapshot and then you are out of luck. It's with transaction logs and everything.
All right, we've got time for one more very quick one.
Okay, thanks for using kubectl plugins. We'll have a session about that later today. So the question that I had is, how do you handle eviction requests that are coming from drain command and stuff like that? And do you have a way of pushing back on that? Actually, I'm curious to go back to the slide where you skipped quickly over why don't you use stateful sets? Yeah, probably the answer is related.
So for example, we support pod disruption budgets. Okay, we have one for the replicas and one for the primary. Okay, so we allow one disruption per replica for the replicas at a time so that we can perform rolling updates. So essentially, when you drain a node, if there's a primary, we issue a switchover. So the primary goes to another node, okay? And then we basically shut down the node, restarts as a replica. Yeah, 2 different PDBs.
What if you receive 2 different eviction requests?
Shit, my wife, sorry.
Oh, mama. That was risky.
That depends. I mean, the pod disruption budget might not allow you to maybe the second one. And it depends actually on how many clusters you have on each node, where the primary is. So the idea is normally you should drain one node, Kubernetes node at a time, okay? But there's a lot of things to learn. There's also tools like Carpenter, I understand, I'm not familiar with, but that are trying to manage that stuff, but yeah.
The operator ensures that your primary always runs in a schedulable node. Otherwise, it switches over. So that's perhaps the main.
Okay, great. If you want to continue to ask them questions, I think they'll still be here. And also, definitely attend Data on Kubernetes Day. They're always
tomorrow morning. Tomorrow morning.
Let's give them a round of applause.
Thank you. Thank you.
We'll be back in a couple of minutes talking about troubleshooting an open telemetry operator. All right.
Oh my God. Hang on.
No talking under my breath. Oh, okay.
All right, we're going to get started. We're a couple of minutes late, but that's okay. They're well worth the wait. We've got Adriana and Reese here. They're going to be talking about when things go sideways, how to troubleshoot the OpenTelemetry operator. So, ladies, I'll leave it to you.
Thank you, Courtney. Hi, everyone. Welcome to our session, When Things Go Sideways, Troubleshooting the Operator. And first, I'd love to introduce my co-presenter, Adriana. Yes, I got that right.
Oh. Hello. Oh, this is going sideways. Haha. Come on, seriously? Okay, here we go. Let's see if this, okay. Yay, it's working, okay. Hi, my name is Adriana Vilela. I'm a CNCF ambassador, HashiCorp ambassador, blogger, and podcaster. I do have a day job. I am a principal developer advocate at Dynatrace. I literally joined a week ago. I specialize in the OpenTelemetry and platform engineering spaces, and I'm one of the maintainers of the Otel end user SIG alongside my awesome co-speaker Reese. And by night, I like to climb rocks, so much so I sprained my ankle recently, fell off a bouldering problem, and can't boulder in Salt Lake City this week, which makes me super sad. But you know what makes me happy? Capybaras.
Hello, my name is Reese. I'm a senior developer relations engineer at New Relic. And like Adriana just mentioned, we work together in the OpenTelemetry end user SIG, where we're focused primarily on working directly with end users and kind of closing that feedback loop between end users and contributors to help improve the project and drive adoption and implementation. So if you have an interesting story you'd like to share, we would love to hear it. We do interviews, and we work with the other SIGs to do surveys and such. I love horror movies, landscaping, started training jiu-jitsu, and I love it. You can usually find me eating, or if you want to find me on socials, you can do so. It's just Reese's Bites, Onyx, and Blue Sky. And so with that, how we've organized our session for you today is we're going to start with an overview of the OpenTelemetry operator. Then we're going to talk about how to install it, how to deploy the collector using the operator, and how to use the operator to inject auto instrumentation into your Kubernetes pods. And along with those, in those three sections, we're also going to cover commonly encountered issues, as well as some troubleshooting tips on how to resolve them. And finally, we will wrap up with some key takeaways, and we'll also share reference materials and the repositories so that you can try things on your own. OK, so what is the OpenTelemetry operator, and what does it do? So if you already have an application running in Kubernetes and you're exploring using OpenTelemetry to get insights into the health and performance of your cluster and application, you might be interested in the OpenTelemetry operator. It's primarily responsible for two things. The first is managing the deployment of your collector and making sure it's configured correctly in your cluster. It also manages configurations across a fleet of collectors via OpAmp, which is a network protocol for remotely managing large fleets of data collection agents. Now, the second thing it's primarily responsible for is injecting and configuring auto instrumentation into your pods. And Adriana is actually going to go over that more in depth shortly. So let's learn what we need to install the operator and how to do so, and then we'll look at some commonly encountered issues and some troubleshooting tips. OK, so first, this might seem obvious, but before you install the operator, you must have a Kubernetes cluster that you can install into that's running on at least version 1.23. You can spin up a cluster on your machine using a tool like Kind or Medicube, or of course, a cloud service provider hosted cluster. Next, if this is less obvious, you must have Start Manager already installed on that cluster. This piece manages your Kubernetes certificates and makes sure that they're valid and up to date. To install both the Start Manager and the operator, you can use kubectl or Helm. And we've also included commands that you can reference for both options in the slide deck, So for kubectl, it's pretty simple. There's essentially just these two commands that you use. For Helm, first thing to note is that version 3.9 at least is required. And this step will take a few minutes. Once that's done, you can install the operator. Note that in either case, you have to wait for the Start Manager to finish installing before you install the operator. Otherwise, the operator installation will fail. Oh, yep, 1, 2. OK, so once you have Start Manager and operator installed and set up a new cluster, you can deploy the collector. Who here is familiar with the OpenTelemetry collector? Oh, how about half? OK, that's pretty cool. So we'll just do a brief refresher on what this is. It's a really cool and versatile component of OpenTelemetry. It ingests data from a variety of sources. It transforms that data based on how you've configured it. And then finally exports that data onto one or more backends that accept data in the OTLP format, which is OpenTelemetry protocol. It's also supported by additional functionality called connectors and extensions, which are optional. OK, so the operator has a custom resource that is used for managing the deployment of the collector called OpenTelemetry Collector. So a few things we want to point out with this sample OpenTelemetry Collector resource. One is that there is a version. This one we're looking at is v1 beta 1, and that will matter for reasons we will go over shortly. And you can see that the kind is OpenTelemetry Collector. And then depending on how you are instantiating it, there are many configuration options for this custom resource. But the basic configuration requires two things. One is the mode, which can be one of 4 deployment, sidecar, daemon set, or stateful set. And then the other thing you will need is the config attribute, which may look familiar to those of you who know about the collector, because it is the OpenTelemetry collector's YAML configuration. One more thing you want to call out is if you have specified sidecar mode, there's some specific things you're going to want to take note of, which we'll go over as we cover it, So for this case, you will want to add an annotation to your deployment YAML, which we have highlighted here for your reference. Oh. OK, so what happens when you deploy the OpenTelemetry Collector CR and things go sideways or don't go anywhere at all? First, check whether your resources were deployed correctly. When an OpenTelemetry Collector resource is deployed, the following objects are created in Kubernetes: the OpenTelemetry Collector, collector pod, and if you have specified non-sidecar mode, look for deployment stateful set or daemon set resources with the following name structure. And for sidecar mode, you should see a collector sidecar container being created in an application pod named OTC container. Next, you'll want to make sure that a config map was created when, and the thing to note here is for sidecar mode, the collector config is included as an environment variable in the OTC container. And finally, if you have enabled the target allocator, which is a whole separate topic, that will also be included here. So just be aware. But there's lots of interesting stuff on the target allocator that we're not going to cover here, but it's cool. OK, so when you deploy the OpenTelemetry Collector resource, make sure those objects are created. So first, check that the OpenTelemetry collector resource itself was deployed. And then next, check your config maps. When you deploy the collector using the OpenTelemetry collector resource, it creates a config map that contains the configuration of the collector. So confirm that the config map was created in the same namespace and that the configurations themselves are correct. Why do all these words have so many syllables? We also recommend checking your collector pods, and depending on the collector mode that you have specified, you can use the appropriate one here for non-sidecar or sidecar mode. Also check the collector CR version that you are using. So earlier I called out that we were looking at a sample collector CR that was version v1 beta 1. There is one more version, and that is v1 alpha 1. So the first thing to note is that the config sections between the two API versions are different. The config value for v1 beta 1 is the actual configuration of the collector, meaning that the key value pairs are part of the CR configuration. But for the v1 alpha version, it's actually one long text string. But keep in mind that the text string still needs to follow YAML formatting. Another thing to note is that if you're using v1 beta 1, you can't leave the collector config values empty. You must specify either empty curly brackets, braces for scalar values, or empty square brackets for arrays, which is not necessary if you're using v1 alpha 1. You also want to check the OpenTelemetry collector base image that you're using. By default, the collector CR uses the core distribution of the collector, which is a bare bones distribution of the collector and comes with just a base set of the components. If you want access to more components than the ones offered by core, you can use the collector's Kubernetes distribution instead, which was made specifically to be used in a Kubernetes cluster to monitor Kubernetes and services running in it. Alternatively, you can also build your own collector distribution. And we've highlighted here where you can set the base image version. OK, I have a couple more things to note. So if you're using a backend vendor to ingest your telemetry, you'll likely need to configure some kind of access token or license key. So make sure that you're using the right one for the account and the backend vendor that you are sending this data to. And also be mindful that you will probably want to prevent that information from appearing as plain text. So you'll want to store it as a secret, either using Kubernetes secret or a secrets provider. And then finally, if you're not seeing data in your observability backend still, make sure that the exported endpoint for your backend is configured correctly. And with that, I'm going to pass it off to Adriana.
Thank you, Reese. OK, so we've learned about the collector component, management component of the operator. Now we're going to learn about zero code instrumentation component of the collector. Now, before we talk about that, let's level set a bit and define what we mean by instrumentation. So instrumentation is the process of adding code to software to generate telemetry signals. Awesome. And if you're familiar with OpenTelemetry, there are two types of instrumentation. We have zero code instrumentation, also known as auto instrumentation, which means that the instrumentation is done for you. You do not have to touch the code. So basically, you have bytecode or shims will intercept the code at runtime or compile time and insert those traces, metrics, or logs for you on your behalf. No code touchy required. There are several languages that are supported for auto instrumentation in OpenTelemetry, including Java, .NET, Python. For more information, scan the QR code at the bottom of the screen on auto instrumentation. Super handy stuff there. Now, on the other hand, we also have manual instrumentation, which, as you would imagine, requires that you, the developer, insert those traces, metrics, and logs into your own code. Awesome. So as I said, the operator does that nice auto instrumentation for you, and it does that by injecting auto instrumentation into your application pods, courtesy of a lovely new resource available called the instrumentation resource. Now, let's run through what that means, all this blob of text here. So, first of all, take note of the fact that our API version is opentelemetry.io/v1alpha1. Unlike the collector, which has 2 versions of that API, there is only 1 version of the instrumentation API, and our instrumentation, our kind is named instrumentation. The other thing of note is we have this section called env, and this is where you define your OpenTelemetry environment variables. And for your convenience, I have included this QR code where you can find all of the applicable OpenTelemetry environment variables. Now, in addition, we have a lovely section here called exporter, and this is where you specify where you're sending your telemetry data to, usually some sort of Otel collector residing in your Kubernetes cluster or maybe outside. And by the way, if you want to know what each of these fields does, you can scan this QR code. It's got the API reference. So next we have propagators, and this is where you specify 1 or more propagators. This is for context propagation, right? So you have you have that correlation between your traces, metrics, and logs. Then we have a sampler definition. You add this part. This is optional only if you want to do any sampling for your data. And then finally, we have this Python env section. And you're probably looking at this thinking, OK, but there's an env section up top, and now there's this Python env section. So here, this is where you define Python-specific environment variables that you want to include as part of your auto instrumentation. Now, fun fact, if you wanted to also auto instrument some Java code, you could add another section here to this instrumentation resource where it would say Java, and then you would have the env section for that. Other fun fact, you can define more than 1 instrumentation resource. So you can define them in the same namespace or different namespaces. If you want, you can have 1 giant instrumentation resource for defining the configuration for all of the languages that you want to auto-instrument, or if you prefer, you can have 1 instrumentation resource per language. Okay, so now the instrumentation resource is basically the configuration for our auto-instrumentation, but we have to do another bit here, which is in our deployment, we have to add this lovely annotation. Now, this annotation basically says to the operator, hey, I want to auto-instrument my application, and I want to use these configurations for that. So if we look at our annotation, it is under the template metadata section of your deployment. In addition, it says, so our annotation is called instrumentation.opentelemetry.io/inject_python. Now, obviously, if we were doing auto-instrumentation for Java, it would be called inject Java. And notice also that we have a value here for the annotation that says true. And this basically says that we are injecting, we're looking for an instrumentation resource in the same namespace as our deployment. Now, you might be wondering, are there other values besides true? Well, absolutely. So we have true, which, as I said, you're looking for an instrumentation resource in the same namespace as your deployment. You can also have false in case you want to have that auto instrumentation but be able to turn it off if you don't need it. Now, in the case where we have multiple instrumentation resources defined in the same namespace, then you have to go a little bit different and specify the instrumentation name, because what happens is if you have more than 1 instrumentation resource in the same namespace and you have that lovely annotation that says true, the operator goes, OK, but which one of these instrumentation resources is my configuration? And then we can go fancier still. Our instrumentation resource might reside in another namespace, in which case you would have to say the name of the namespace of that instrumentation resource and its name as part of your annotation configuration. So you would say that in lieu of that true value. That's awesome. Maybe you're going through this and you're like, makes perfect sense, amazing. And then you go and do it and you're like, dude, where's my instrumentation? Ha! And believe me, I've gone through that, so I'm going to share some of the things that I've learned along the way in trying to auto-instrument my code a la operator. So first of all, make sure that your instrumentation resource is deployed. And we can do this by running this lovely command, kubectl describe otelinst-n. And basically, the instrumentation resource in Kubernetes is named otelinst. So if you do the describe of that resource, hopefully your resource will show up. If it doesn't, then that resource hasn't been deployed. In addition, it'll display all the nitty-gritty details about that resource, so you can go through and see if it looks right to you or not. The other thing is we need to check the deployment order of our auto instrumentation. So as I mentioned, to auto instrument in the operator, we have to deploy that instrumentation resource, but we also have to do that lovely annotation to our deployment resource. The order in which you deploy these matters. Instrumentation resource has to be deployed first, followed by your deployment, because what happens behind the scenes? When you deploy your deployment, that little annotation tells the operator, hey, I'm going to look for an instrumentation resource with all my configs. It finds it, and then guess what happens? It creates an init container to inject that auto instrumentation into your application code. If that instrumentation resource isn't there by the time you deploy your deployment, ship has sailed, instrumentation no worky for you. So how can you check to make sure that that init container has been created? It took me a while to find this command, but this is it. This will basically, for a given pod in a given namespace, it'll list all of the init containers that have been deployed for that pod. So you should see one that is an auto instrumentation init container for the language that you intend to auto instrument. Okay, next, check those auto instrumentation annotations. As we know, in deployments, there are two places where we can define annotations. One in our main metadata spot, metadata section. That is wrong, it will not work. And the other in our template metadata. That is correct, it will work. In addition to that, you need to make sure that we are specifying, first of all, the correct language. If you are specifying inject Python and your application code is Java, guess what? It's not going to work. In addition, as I mentioned earlier, if you set this value to true and you have more than one instrumentation resource in that namespace, the operator is going to be confused. It's going to error out. You're going to get a nice crash loop back off error, and you're going to be super pissed. So make sure if you have more than one instrumentation resource, you have to specify its name in here instead of true. And then another thing to do is check those endpoint configurations. So in your instrumentation YAML, we are checking our endpoint configuration. If you're pointing to another, an Otel collector that's running in your Kubernetes cluster and it's running as a pod, you have to specify the service name. And if that collector service is running in a different namespace from your instrumentation resource, you have to do a fully qualified service name. So that's the namespace, in my case, opentelemetry.svc.cluster.local. Plus, you have to specify that port number, 4317 for gRPC, 4318 for HTTP. But guess what? For Python, it will not work for 4317 because it does not support gRPC for instrumentation. Found that out the hard way too. Now, if you're deploying your collector as a sidecar, this is what your exporter is going to look like. It's localhost 4317 or 4318. Again, Python, only 4318. And finally, if all else fails, turn to the Otel operator logs. This command here will tail your operator logs, and if you're super fancy and can use sed, then look for the word error. Anything that looks fishy in those logs. That's your last resort. Okay, so if you take anything away from this talk, take pictures of the next two slides. I will summarize these lovely troubleshooting tips for you once again. Number one, install that cert manager first before you install the operator fully. Number two, make sure your resources have deployed, your instrumentation resource, your Otel collector resource. If deploying Otel collector, make sure those corresponding pods have deployed, right? Your collector pods and corresponding config maps, your target allocator pod and corresponding config maps if you enabled target allocator. Make sure you've checked that API version, especially for your collector, because there are two versions that you can choose from. Check your deployment order for your instrumentation. Auto instrumentation, deploy instrumentation first, and then your deployment. Next, make sure that those annotations go in the right spot. It's your template metadata that goes for your auto instrumentation annotations and your sidecar. Check those endpoint configurations, make sure that they are pointing to the correct collectors, correct service names, and check those operator logs for error messages if all else fails. All right, some handy resources For your reference, we have a blog post version of this talk if in case you want to refer back to this. There is a repo where you can check this stuff out. It was actually created for another talk, but it basically has like all the stuff set up for Otel collector and auto instrumentation. So definitely recommend you check it out. Also check out the Otel operator Slack channel. The Otel operator folks are super friendly. They've always been really great about answering mine and Reese's questions, so don't hesitate to reach out. And finally, doing some shameless self-promotions. I have a podcast. The logo was designed by my 16-year-old daughter, and I've had awesome guests on there, including Kelsey Hightower, and Hazel and Marino sitting at the front there have also been guests, and also Reese, so this is why you should check it out. Also, the Otel end user SIG has a docs usability survey. If you use the docs, love them or hate them, we want to hear from you. Tell us what you think about the docs. It helps us improve the docs. Survey is going to be open until the 15th, i.e. Friday this week. And finally, thank you for joining us, and thank you to Reese's cat, Taco, for being our excellent slide model. I laughed my ass off as I was going through these slides because I love the pictures. So thank you so much. Thank you.
Don't have time for questions, but if somebody would like to ask you some questions, ladies, where can they find you?
We'll be around.
We'll be around here. Great.
Yes. We're going to be at Observability Day tomorrow and at the Otel Observatory booth during KubeCon. So
fantastic. Thank you so much.
Thank you.
Thank you.
Okay. Thank you.
Oh my God.
Okay, and we're back. We're going to get started with Scott Nichols. He's going to be talking to us about the wrong way to reconcile. So I'll let you take it away, Scott.
I should have called it something positive, I guess, but this is what came to my mind. Who am I? I'm Scott Nichols. I've been in and around the industry for a bit, Riot Games and Google, and I've been working, so I cut my cloud native teeth on Service Catalog and then Knative, learned a bunch in Knative, and I've now seen a lot of reconcilers out in the industry, and so this talk is really about helping explain the things that level set good operators, reconcilers, controllers in the industry. Like, this is what you need to do. And then we're going to go over some foot guns that I've found all the way. It's not comprehensive. This is not a how to get started talk. This is more like how to judge what you see if you're evaluating something, or how to judge your own project a bit. If you don't want to sit through the talk, I made a slide that you can read, and then you can walk away. Here's what I'm advocating for. Every single CRD, no matter what it does, needs a status.conditions. And inside that struct, it has to have these fields. But the most important thing is that it has a status type, observe generation, and the condition type needs to be ready or succeeded, one of those two. You can have a bunch of other things, but the top level one needs to be either ready or succeeded. Okay? Sorry, the ready is something that continues forever. Succeeded is something that finishes. Right. I think this is a cute little definition of what reconcile means. Right? If you ask Webster, it's to settle a disagreement, right? And how does this apply to declarative APIs? Well, declarative APIs in Kubernetes open the door to this disagreement. You have the spec says one thing, the world says another thing. We have examples of declarative APIs all over. My favorite one is the thermostat, where you say, dear thermostat, I would like the temperature to be 70 or 68 degrees. And then the thermometers, or the thermostat's job is to measure the environment, understand all of the operational parameters for your particular HVAC system, and adjust the environment to match what it's been asked to do, right? I declare I would like my room to be 68 degrees, and depending on what it actually measures, it adjusts. If you've read Joe Beta's book, his example is table for two, please. You walk into a restaurant, you say table for two, and you don't describe what is on the table or where the table is, or you get an available table that meets your capacity. We've heard a lot that Kubernetes is a platform to develop platforms, and this is true. And if we look at the CNC landscape, this is not the whole thing, this is just things inside the CNCF. A bunch of these things make custom resource definitions, and they provide them for you to use their SaaS-like provider, or provision things, or do whatever interesting thing that they're trying to solve. But I've seen some skeletons, or whatever the phrase is. So let's just take a quick tour of a resource. This happens to be a core Kubernetes resource, the replica set. So, right, we have the spec. It's the thing you asked for. We have the status, which is the opportunity for the controller to tell you what it did. You have the generation. Does anyone know when the generation gets bumped? I don't know hands. So if you update anything in the spec, generation will get updated. What if you update the label? Nope, doesn't do it. The resource version, if you dig all the way down to the very bottom of how Kubernetes is implemented, resource version is really just a monotonically incrementing number associated to a journal in etcd, right? So if you change that label, spec doesn't change, but resource version does. So if you're watching an operator, or you're watching a resource and its resource version is changing all the time, or its generation is changing all the time, that gives you a hint on where in its resource you need to look to see what is flip-flopping. And usually there's fights, or there's a circular dependency, or something depends on something else. And I have a couple foot guns that I want to talk about to describe how to find those things, and we'll get there. Another thing that I really want to talk about is, most of you probably use Kube Builder, and I bet you've never built a reconciler the hard way. And inside, for better or worse, the Kube Builder client, or a controller runtimes client, wraps up the typed clients, the cache, the listers, the informers, all into this one kind of uniformed API. But internally, what's actually happening is there's a typed client that can talk to the API server. There's listers that they have a similar API than the client does, but it interacts with the cache directly, and it gives you cached objects. And the cache gets populated by setting up watches, populates the cache, and informers let you know when the cache gets changed, right? The work queue is usually interacted with by injections into the client cache itself. So it's, So the work queue has anyone read the work queue code? It's fascinating. It's a very good queue. And it has some advantages and some disadvantages. It is a queue, just like you would expect a normal computer science queue to work. It is strongly typed, so the string that ends up in there is key. It's usually a namespace/name for namespace resources. And your job as a reconciler operator is you have to take that string and turn it into some kind of query for the resource. Because the queue is strongly typed, the key is tied to one kind that you're trying to reconcile, right? And so there's some interesting problems where if you're trying to watch a child resource, something in the child resource has to point back to the type, the kind that you actually want to reconcile it. Usually this is like the owner reference, right? There's a metadata about the type, and so you can look for your owner reference in the owners list, and you take that key and you inject it into the work queue. The most fascinating thing about the work queue, though, is that as a worker, you can spin as many threads up as you want, but as the worker pulls a string out of that queue and you modify it, say you update the status, because you're probably going to do that, well, if we go back to this thing, so you store the status, it goes into the API server, that causes a watch event to happen. The lister says, oh, I've got to change it, injects it, the client puts it in the cache gets triggered, and it tells the thing that puts keys into the work queue, there's this new event, and your foo/bar thing now is added to the bottom of the work queue. It's very cool, but it does this clever thing where it'll hold open the current key, it'll add it to the bottom and hold that kind of as a pending thing, and then when you commit, say you're done, you've popped it off of the top of the queue, the pending one will get re-added back. And so it has this lossless, I can act things but add things at the same time while it's pending. It's very fancy. This interaction, though, it's one of the reasons why I always advocate for if you're writing your reconciler and you're writing your loop and you get to the point where you make a modification to the resource, you should probably exit then, right? Like sometimes you shouldn't change spec, but if you're gonna change spec, change it and then just bail and then pick it up again the next time, because you're gonna be added to the work queue again. You just do it then. Some self-inflicted footguns that I've given myself is, it's when you, not necessarily with Kube Builder or controller runtime, but if you interact with clients directly, you need to make extra sure that you're using the same client and the same caches, because there are all sorts of synchronization problems that one client will get an update, but the other client doesn't get that update, and so then depending on which client you're interacting with, you see an event, and then you check the state of it, and it doesn't make any sense because it's the old thing, and then that one gets updated, and it's a mess. And so be very, very diligent that you're using the same caches from the same clients across all of your all of your reconcilers inside of the controller. I should side note, what is the difference between a reconciler, an operator, and a controller? Well, a reconciler, this is my loose definition, I think it's mostly agreed, but a reconciler is like an implementation, a particular thing for a particular kind, right? It's operating on Scott's object. Controller is the thing that helps you set up all of the other clients, and it holds the reconciler. You can have more than one reconciler per controller. A controller I think of is more like it's the thing that is running, it's the entry point to the pod that's running your set of reconcilers. And an operator is a very clever marketing term that CoreOS made to make it more consumable. So another thing that I see all the time is that resource models, so if I make a CRD, it's a cool database, and it has a bunch of other pieces that it makes because I delegate my responsibilities of making or orchestrating the architecture of the thing that I'm building. It sort of fans out, and as you're building up that resource graph, like as you're developing the model, it needs to be useful from the bottom up. I mean, take Kubernetes, for example, right? The bottom thing tends to be the pod, and the pods, I wouldn't recommend it, but you could roll your own thing that uses pods, and it's useful. You could also roll your own thing that uses replica sets, and that piece is still useful, and it leverages pods, and on and on and on, all the way up that graph, right? And often what I see is that because it takes a lot of work to duplicate a bunch of data down, think about like the pod template spec is a bunch of data, and then the pod gets all that same data. But the graph, the model wouldn't work if pods reference the template in the object that they were created from, because this thing could change, and before the pod has a chance to either reject that or whatever, it shouldn't reference, right? Just do the hard work of copying that down. It also breaks that directional DAG sense, where now the pod, I can't make a pod without having the template of a parent object there too, right? And there's other examples where there's references to other things, and it makes it really difficult to reuse that bottom layer. So at the very bottom of your resource graph, it's very not opinionated. And as you go up that graph, it becomes more and more opinionated and maybe less verbose, right? But the bottom, verbose and opinionated. Or sorry, not opinionated. Just to level check, right? Annotations and labels, very useful. I think of annotations as kind of like strategy selectors for the reconcilers that you're using. Think like, I have a thing, but I want to use the next generation business logic in this implementation, and I want to test it out. One way to do that, to kind of A/B test the data inside your CRD, is you can add an annotation that says, I want to do the next thing. I want to try that out. I want to A/B test some logic that I have. And so in your controller code, you can look for that annotation and make an internal decision. It doesn't change the API, and you don't have to deal with backporting and all that stuff. And more or less, annotations could be ignored by the implementation of that controller, right? Labels are mostly used for filtering and identifying things. So, yeah. Okay. So, I already TLDR'd this, but the general shape of a required status is status.conditions and a little array of stuff. The old style was an status.observe generation, but this changed to have observe generation inside of the condition in the conditions list, because when we decided to do, what is it called? Managed fields, right? Managed fields is this feature where I can have my spec and I can have a controller or an owner of that can mutate the spec or reconcile different pieces of the status. Well, if two controllers want to be able, or two reconcilers want to report back what they did, the status will be sliced up into you own this and you own this, but the conditions still need to report the other controller have done this work, and I did the work and I observed this generation, and so it reports back into conditions. It makes it a little more complicated because you have to, as the owning controller of the condition of either ready or succeeded, has to then go and raster back through the list and check for up-to-date generations from the other controllers. So it's complicated. I wouldn't really recommend doing that, and you better have a really good reason to split the reconciliation like that. It's probably better to make other resources and have single controllers. I drew this diagram for a different talk, but I think it's interesting for people to see kind of the flows on what the API server does for its lifecycle and webhook checks. Right? So the red things are built-in things that the API server does, and the blue things are things that you interact with the cluster with. It's your webhooks, it's that kind of stuff, right? It's all your hooks. So just be aware, this is what's happening when you're writing your webhooks. And just because you're defaulting and validation webhook pass doesn't mean that it actually stores, and they could get called again. So make sure that you're not actually mutating the state of the world inside of your webhooks directly. Okay. Conditions. Somebody was asking me, how do I think about conditions? And in my head, conditions are kind of this flat DAG where you have this top, I call it the top level condition. It's ready or succeeded. And then every other subcondition is kind of a wrapper around sections of logic that you've baked into your operator or your controller or your reconciler. And it's like this thing happened and it was either successful or not, right? And your code is compiled of several of these. Don't do too many because it gets a little noisy. Don't do too few because it's not enough information for me to debug why the thing is not working, right? Because I'm telling you, you have to use ready or succeeded, I'm not telling you what any of these need to be. These are actually highly implementation specific for the reconciler that you've created or you're using. Should things depend on it directly? It's like depending on the implementation of the thing, the internal bits, the hidden bits of the other dependency that you're trying to observe. So my opinion is probably not unless you're deeply coupled to that other thing. So I just wanted to illustrate the point, right? So this is from Knative Serving. If you want to, I don't want to explain everything. Find me in the hallway and I can show you Knative reconcilers, but it's not the same as, can you read this? Let me zoom in. So that configurations ready condition, right? So we'll zoom in. It does this block of code, and then it determines, should I mark it complete or should I mark it no? Right? We have this pattern in Knative where things are mark methods, where you can mark it true or false or unknown, and then we also have propagate, where we don't know exactly what it's gonna turn it into, but we're gonna delegate that responsibility for the code that owns how to translate config.status, which is a child resource, into the condition for configurations ready. I should say one other thing. Conditions can be true, unknown, or false. True means that whatever that condition represents, it's good, everything's fine. Unknown means I'm working on it. Maybe I actually have a slide. And false means, I do have a slide. It's coming next, so ignore me. Okay, so routes ready, right? Same thing, right? So we zoom in, and there's like we do some logic. This whole chunk of code does some logic. And in this case, serving is really just creating 2 child resources. So we're just comparing the state of this, in this case, the route, what's going on. And it's either not ready or I want to propagate it up into have information. The whole point of these subconditions, remember, though, is to tell the human what the heck is happening. So that message needs to be as useful as possible for the human, and if you want to depend on the implementation, then you start to know about what the code of the reason is inside of the condition. Right. So, like I said, true means everything's fine. Unknown means it's not what you asked for, but I'm working on it. I'm not stuck. And false means I need an adult. Like something fundamentally needs to change in the cluster before this thing's going to flip-flop. It either means that I'm missing some nodes, or I have some invalid schema or something that got in, but it is stuck until intervention. And you could have some automation, or it's probably like some poor on-call person has to fix something. Do me a favor. So in doing preparation for this, I did a bunch of research, and it turns out that 79% of all issues in Kubernetes are because of typos. Yeah. And I have a whole list of other facts. You should scan this code. Scan the code. Yep. So don't trust status if observed generation doesn't match generation. If you look in the little details, I have generation 4, observed generation 1. So my status is a lie. It's not what I intended. Who knows what it's doing? I don't know. I can't trust it, right? So one of the things that I see all the time is that controllers will go and redo reactions because of that lister, watcher, cache update thing. You get kicked back into your reconciliation loop and you're going, and you kind of blindly go and react to its status because you've propagated some change. But you're really reacting to probably the controller itself pushing status or a change to status into the child resource or whatever, right? And until you see generation match observed generation, which is why it's so important, you can't automate anything reliably without like sleep 15s, waiting for the next thing, right? So sorry to troll. I'll touch on events. Right? So one of the useful patterns for explaining to the humans why your thing is doing wacky things is emitting events, right? I think that events should be emitted on meaningful changes, big meaningful changes. Success path, not so much. You actually bump into getting API quota back off. You're going to emit too many things to the API server, and you're going to get delayed, and you won't be able to actually log the important things when you bump into an error, and some other things. Logs, this is for the context of writing controllers, right? Keep the happy path as quiet as possible, because we don't really care that everything's working because it's working, right? We want to know when it doesn't work, and when it doesn't work, add some context about what was it actually doing so that we can go and investigate an instance of a CR inside the cluster and see if it has events, or if it has conditions, or if it has children, or if it exists at all. Metrics that matter. Well, I'm sorry, I got to speed up. Work queue depth, right? How busy is my reconciler? Duration of reconciliation. How lag is it going to get? Is it ever going to catch up? And know the number of workers that's pulling work out of that queue. So the foot guns is my favorite part. Again, ignoring observed generation, biggest foot gun I've seen. You do work without understanding that the world is being reported accurately. One that we bumped into in Knative a bunch is adding very helpful mutation webhooks that simplify the input. So a user types in 60 minutes, and the webhook will turn it into 1 hour. Same value, right? But then the controller, maybe a controller spits it out, and then we see that it's a change, and then we fight. We fight forever, and then we get observed generation over 9,000. It's probably more like 40,000, but referencing spec fields. So my opinion is that if you think that anything is ever going to be an input to something else downstream, always propagate it into the status. Just trust the status, right? Referencing things in a spec of something else, I think is an anti-pattern, actually. It also gives the controller a chance to resolve that, right? That's when you convert that 60 minutes into 1 hour. If that's your preferred way, something downstream is going to consume that. It's in the status. I talked about 2 caches, right? Just use 1 cache. It'll simplify your life. Actually, we bumped into a different one. You don't get this with controller runtime, but the typed clients and the dynamic client also have their own independent caches. And so when you're doing duck typing, and if you search for duck typing, there's a bunch of talks. Though the events for changes come in at different times, and we would see a change, and then we'd look in the typed cache, and it wouldn't be there, and then the reconciler would get confused, and then have to wait for the next update. Very confusing. Try to always kind of use the same client that you're interacting through. So what's missing? Well, I had to write a bunch of weird code inside of Knative to help make that DAG controller condition thing. So subcondition manager is missing kind of in the wild. Controller runtime doesn't have this thing. And there's a whole list. So I have a few minutes. I would like to enable questions if anyone has a question. But yeah, duck typing support is big. If you don't know what duck typing is, it's search for polymorphic reconcilers. It's a talk we did a couple years ago. You can do some things, but not all the things that we can do in Knative. KubeBuilder is getting better. Somebody introduced something like reconcile kind, but the whole point of reconcile kind is that the first phase of a reconciliation is you get that string of a key that represents an object somewhere, and you have to load it up and make sure that you duplicate it so that you don't mutate the cache, because the cache gives you the real copy, which is another foot gun that's fun. So you have to deep copy it, and then you can mutate it, and then you hopefully throw it away or do some update or something. So reconcile kind turns the string into a real object clone on your behalf, and then that's the entry point to the reconciliation. Yeah, that's all I have. Thank you for listening.
Great, we definitely have time for a few questions.
Scott, thank you very much for this. This is one of the presentations that I would like to have the link of the recording for whenever I'm writing a controller to watch at, because most of the time, probably I didn't got all the details, but when I'm writing a controller, I will say, okay, that's the reason why Scott was saying that. That's super interesting. So again, like coming from the Knative background, I know that in Knative we are not using controller runtime. So what are the main things that pushed you not to use that and just create your own kind of like caches and different mechanisms there?
So the big Knative's controller come from what Kube had as an example controller framework, and it basically was a reconcile method with the string, and then how to set the controllers up and type clients and all this stuff. And KubeBuilder comes in and says, well, it's actually really difficult to set those listers and watchers up correctly. It's really difficult to use typed clients. So we're going to wrap some of that stuff. And then there's this Fluent Builder thing to help set up the controller and initiate those caches. And it makes sure that you can't mix and match caches and things like that. The other biggest thing is around the life cycle of the resource, right? So KubeBuilder by default has the string, and you have to turn it into an object. But if you use their client, it's not the cache version, it's a copy for you. Knative has this pre and post amble piece that we added, which is confirming that you haven't mutated the spec. We just ignore that stuff. We clear out or initialize some of the conditions that we use because we have a pattern about the manager. And then at the end, we decided that you can reconcile your kind and then return the mutated object, and the thing that called you will take a look at the condition or the status and determine if it's time to do an update on status, which means you focus on your business logic, and then the Knative side will help you submit that to the Kube API. Controller runtime, you have to do all this on your own. And I've done a couple other talks. I think it was TGIK 145. I did a talk, and I tried to use controller runtime, and I got burned by that because I forgot that I have to do that like a farmer. And so it took me 5 minutes to remember. And
Any other questions? No? All right, great. Thank you so much. Really, really great talk.
I assume, ooh.
In about 15 minutes with our next talk. So you've got a short break to grab something to drink and head back. All right. Welcome back. We're going to get started with Abhinav. He's going to be talking about GitOps first deployment, Argo CD, and beyond. We've got 25-minute talk and hopefully a bit of time for some Q&A. Take it away.
Hello. Hello. Hi, everyone. Hi, come on. Hello. Perfect. I can see. So it's about GitOps first deployment, right? Argo CD and beyond. But who am I? So I'm just a Kubernetes head with a traveling soul. So full-time I'm a traveler, and to pay my rents, I work at Defron as a solution architect. I'm also a CNCF ambassador. I'm also a AWS community builder, CNCF New Delhi chapter organizer, founder and author at DevOps Diary, which is pretty much dead these days because it's been a year I have pushed anything on this publication. But yeah, it's another publication. What is GitOps? So I assume everyone here must be aware of GitOps, right? Everyone must be doing GitOps and Argo CD. Anyone would like to pick this up, or it's the fusion of elephant's head and penguin's body? What is GitOps? Come on. Okay. So it's just the fusion of elephant's head and a penguin's body. Basically, it's more than that. So it's a practice. It's a practice of deploying applications onto Kubernetes using Git as a single source of truth, wherein you separate your different repositories, and there are different core principles which GitOps stands for. The very first one stands for version control. Basically, Git having single source of truth, right? Where you push all your Kubernetes configurations at one place, where you define the configurations in a declarative fashion so that you have a consistent configuration which can be deployed across multiple different environments. Basically, the declarative configurations. The third point is drift management. Again, GitOps is known for the reconciliation, right? Having a robust drift management solution wherein you can check the different configurations, and if there are any drift between the actual and the desired state, it will reconcile automatically. The next is continuous delivery. Again, it facilitates the automated deployments, having faster deliveries and faster go-to-markets for the applications or the software, basically. The next, GitOps tool. Again, so there are ample of tools in GitOps, right, which are being used. But two of the most popular tools are Argo CD and Flux CD. And for any engineer, it's a dilemma, right? Which one to choose, which one to go with. So let's go with the Argo CD, the one that is one of the most popular one, and we have been talking about Argo CD for long now. So what exactly is Argo CD? So Argo CD is all about not using kubectl apply in your clusters, right? It's about having a declarative GitOps-based configurations. So as per the Argo CD documentation, it's a GitOps-based continuous delivery tool for Kubernetes. The main objective of Argo CD is one of the objective of Argo CD is reconciliation engine, right? So it synchronizes with the configurations that are being pushed to the Git repository with the actual state of the workloads which are running on your Kubernetes cluster. A small overview of the components of Argo CD, or let's say a small overview of the architecture of Argo CD. The very first is API server, which manages the REST APIs and the user interface through which you interact with your applications. That can be the GUI or it can be the Argo CD CLI as well. The second is repository server, which handles all the interactions with the Git repository basically. So if there are any new commits, it will fetch it and cache it within your application manifest for deployments, right? The next one is application controller, the third one, which actually constantly keeps an eye on that particular Git repository where you push all your Kubernetes configurations, checks if that particular configuration that you have pushed in the GitOps repository is the same as the one that you are actually running on a Kubernetes cluster, or if there is any drift. If there are any drifts, it will automatically reconcile it to the desired state, right? These are the main three components of Argo CD, or let's call it overview of the Argo CD architecture. But let me make a statement here. So Argo CD is a Git syncing tool. How many of you agree with this? Please raise your hands. Argo CD is a Git syncing tool. I can see just a couple of hands. So it's not a Git syncing tool. What do you think about it? Anyone? It makes sense, right? Thank you. Anyone else? Okay, so Argo CD is not. Argo CD is more than a continuous deployment tool, right? It's not exactly a continuous deployment tool when we say the entire full-fledged continuous deployment. Argo CD is more of a Git syncing tool from its principles, right? Is Argo CD is equivalent to full-stack continuous deployment tool? So ideally, what do you think about it? Anyone here like to speak up on any of the topics here? Is Argo CD equivalent to full-stack continuous deployment tool, or it's a part of the entire ecosystem? What do you say? Anyone? So what is your ideal checklist of a continuous deployment tool? For example, for me, a ideal checklist for a continuous deployment tool would be, let's say, in my continuous deployment tool, I would want to have rollback, right? The flexible ways of rollback, basically one of the checklists that I would want for my continuous deployment tool. Or let's say I would like to have a flexible way of deployments, right? A control way of deploying my application onto the Kubernetes clusters, where I can control the way I want to do it. Or maybe I want to have a flexible workflow, right? I want to run the workflow as per my use cases. So again, policies and governments can be one of my ideal checklists for a continuous deployment tool, right? Wherein I want to block certain things going in the production environment, or I can create certain pipelines with certain configurations, right? So the ideal checklist of a continuous deployment tool would vary from different organization to organization, depending upon the requirements, right? So there is no as such hard and fast rule or one particular checklist which is true for everything. But the continuous deployment tool does need these kind of capabilities, right? A lot more than that as well. So when we move to the cloud native ecosystem, right, it's not that good, right? Basically, if you see here, right, Argo CD is one piece of the puzzle. It's not the entire puzzle, right? It's not the entire continuous deployment tool. It's one part of the entire ecosystem. Now, Argo CD and beyond. So when I say, okay, so please scan this QR code. So this, and you can enter your email ID and name basically. So if you want to sign up for the Defron's newsletter, wherein we publish all different this kind of blogs and resources related to cloud native ecosystem. Coming back to the topic, so Argo CD, when combined with different other things, other capabilities, right, it makes the entire continuous deployment ecosystem. For example, flexible rollback capabilities. When I say flexible rollback, it doesn't mean just rolling back the entire previous commit, right? Maybe I just want to roll back my previous container image, for example, or I just want to roll back my previous configurations. Or if I go a step ahead, I want to set up automated SLO-based rollbacks, for example. If certain checks has been passed, then automatically it should roll back to the previous version. That can be one of the requirements, right? Again, support for advanced deployment strategies. For example, for my production environment, I want to go with the blue-green deployments, right? Or maybe canary deployments, for instance. Again, there are tools which can be integrated. For example, Argo rollout, but there is an overhead of integrating that tool, right? Policy enforcement and governance. For instance, I would like to block all the container images which have certain vulnerabilities in my production environment, right? So that can be again one of the checklists for my continuous deployment environment, or that can be one of the piece of the puzzle that needs that will complete the entire continuous deployment ecosystem. Fine-grained controlled deployments across multiple different environments. For example, let's say if I want to deploy my application onto 3 different clusters, right? Let's say staging cluster, dev cluster, and my production cluster. But for one particular release, I don't want to release it to the staging environment, and I directly want to release to the other 2 environments, right? I should be having a control way where I can deploy all those, configure those deployment patterns. Or let's say the Black Friday sale, right? The Black Friday sale is going on, and I want to block all my deployments to the production environment. How do I do that, right? Having a control way of those deployments, having a, for example, blackout window, right? For instance. Having such deployment patterns will help me achieve these goals. Auto remediations is again one of the examples to automate the certain tasks, right? For example, one of the classic example of auto remediation can be, let's say HPA max out, right? The maximum replica count that you have given in HPA is reached. Now what do you do about that? So in automated remediations, you can write those runbooks which will automatically increase the max replica count of the HPA, and again, it will fix your issue, right? Microservices dependency gaps. It is again one of the important aspects when we talk about the entire continuous deployment ecosystem. Why? For instance, there are 3 microservices, right? Microservice A, B, and C. And all these 3 are interdependent on each other, right? So whenever you deploy those different microservices onto a particular Kubernetes cluster, let's say if anything fails down, right? Ideally, you will have, instead of rolling back individually all those microservices, you can bundle them and create a release out of it, right? And instantly you can roll back the entire release, which will roll back all the 3 different microservices. Having a way to define all those different microservices which are interdependent on each other, which you can directly see in the dashboard, basically in any of the system, deployment system, and thereafter bundling those releases and rolling back those releases. Having the workflow flexibility, basically, again, it's one of the aspects of the entire continuous deployment ecosystem, wherein, for instance, I want to run certain pre-deployment and post-deployment stages for my workflow, right, for my continuous deployment environment. Now let's take a scenario wherein in my post-deployment, it says certain things might fail, right, but that doesn't mean that my deployment is not successful. If I give a small example, in case of Argo CD, right, there are pre-hooks and post-hooks, right, which you can use for those kind of jobs, right? But if any of those pre or the post hooks fails down, the Argo CD application status will continue to be in the in-progress state, and it will continue to reconcile. Reconcile with the GitOps repository to detect the drift, and the status of the application would be in progress. But technically, your application has been deployed, right? If the post hooks are being failed. So having a flexibility to run those kind of complex workflows, wherein I had the flexibility to run just the pre-deployment stage, or just the post-deployment stage, or the entire workflow wherein the first pre-deployment stages are being passed, wherein I might have DB migrations, for example, Django DB migrations. After the migrations are being done, the application is deployed to the target Kubernetes cluster. Once the application is actually deployed on the target Kubernetes cluster, in my post-deployment stage, maybe I want to close my Jira ticket, for example, or send a notification to a specific email, or update a GitHub PR request. All those activities can be done, right? So having a control around all those different workflows, again, makes the entire ecosystem. And these are just some of the points. There can be some other points as well, which completes the entire continuous deployment ecosystem. Powerful, independently, invincible together. And this is true for everything in Cloud Native ecosystem, right? So in Cloud Native ecosystem, we have a lot of different tools. For example, Argo CD itself, right? Argo CD. Every tool in itself is very much powerful, but again, when combined together, it makes the entire platform. To defeat the Thanos, the entire Avenger team needs to be assembled, right? So that's how it works here as well. Now, introducing Defron. So navigating the world of GitOps with Defron. Defron is an open source Kubernetes native software delivery platform, which is built upon on the top of these cloud native tools that we have been talking about. So with Defron, you should be able to achieve the entire Kubernetes native CI/CD pipelines, creating your entire CI workflows, the deployment workflows, however you want to create, and in whichever fashion you want to create. It eases out the entire day-to operations, for example, checking out the logs, troubleshooting, debugging, anything that you want to do on the top of Kubernetes. You would be able to create policies and guardrails around the entire platform, the entire ecosystem, wherein, for example, maybe in your entire CI/CD pipeline, right? Let's say for your production pipeline, ideally you want to create a policy wherein the CI pipeline should go through a SonarQube check, for example, right? If certain criteria is passed, then only it should go ahead. Or let's say for your production environment, you would want to have approval workflows, right? Having an approval-based deployment, or even multi-stage approval deployments, for example, even for your configurations. The user access management part of the entire Kubernetes ecosystem, observability, troubleshooting. So Defron is a one-stop solution for all things Kubernetes, basically. Now it's show time, so let me quickly share my screen and share a couple of screens here. Okay. So this is how the dashboard looks like. It's a sample, it's a sandbox environment where you can log in with your GitHub credentials. Let me quickly log on. So this is a preview.defron.ai is a sample sandbox environment where you can log in with your GitHub credentials. Defron does have native integration with all different SSO providers that you want to use, and the fine-grained access control for your applications deployed onto the Kubernetes. So I'm not going to give the entire walkthrough of the platform, but let's just talk about some of the points here. Okay, the internet, I guess. once. Maybe I need to switch my network. No, that's fine. Perfect. So these are the applications which are already being deployed in this particular environment and across multiple different environments that you can see here. The multi-cloud, multi-cluster applications basically. Let me quickly go to a specific application. Let's say the demo application. That's why people say we should record your videos before giving the live demos. Perfect. I have learned my lesson now. Workflow, yeah. So you can see here, right, for any of the application, you should be able to create any kind of workflows here, the entire CI/CD workflows. And when I talk about the entire deployment ecosystem, let's say, for example, this is my production environment, right? In my production environment, when I create a production deployment for my environment production, I should be able to define how exactly I want this deployment to be. For example, I want to have an approval-based deployment, right? I can simply enable the approval toggle for that. I can define who should be able to approve this particular images to be deployed in the production environment, or even I can define a specific number of approvals that I need from the respective approvers. And the user who should be able to approve those particular images can be controlled through RBAC itself. Now, pre-deployment and post-deployment ecosystem. So basically, there are multiple different plugins which are already available within the dashboard that you can see here that can be natively integrated within the different pipelines. For example, let's say if I want to integrate, let's say I want to run any migration, for example, right? I might have this Golang migrate, a plugin which I can use to run the migrations before the deployment happens. Or let's say if I want to go ahead and close a Jira ticket, for instance, right? I can see my Jira plugins which are already available here, or maybe the GitHub plugins which are already available here, which I can integrate directly within those environments. And even if I want to create a plugin of my own, that's way too straightforward. Simply write your custom scripts here, and you should be able to save that particular as a plugin, giving some of the environment variables. The entire documentation is already available at the docs.defron.ai, which you can use for that, for creating the entire CD pipeline. Now again, for the configurations, right? If you see here, there is something called product configurations, wherein you should be able to enable the approvals for even for your configurations as well. Let's say I have enabled my approvals for my production environment. For my production environment, whatever configuration that I have given, right, I should be able to control those configurations. If there are any changes made to this configuration, it first needs an approver. And once the approver has approved those configurations, then only it will be deployed to the respective environment. Now again, let's say if I want to deploy my application onto respective production environment, for example, right? And before deploying deploying my application to the production environment, ideally I would want to see what are the configuration changes which I have made. For example, I can see the entire config diff. So since there are no configuration diff here itself within the last deployment and the last save config, I won't be able to see any diff here. But if there are any configuration changes, you can directly review it before you actually deploy on the respective environment. Or even if I want to roll back, right? For example, let's say I want to roll back for this particular release. I have different configurations. I have different ways different combinations I should be able to roll back to my previous release. And there also I can see the entire diff, which are the things which has been changed. Let's say, for example, here there's an ingress name has been changed here. Yep, there is an ingress name has been changed here in the previous release, so it will take it to my previous version basically. Same thing if I want to roll back just to a specific config with the last deployed config along with the images, or even if I want to directly roll back to the last save config or the last deployed config, I should be able to roll back with these different options. Or if I want to set up the SLO based rollbacks, again in my workflow, I should be able to get those plugins which I can integrate within the pipeline itself. Let's say post-deployment stage, right? The SLO-based plugins, the SLO-based rollbacks. I should be able to define those criteria for which, if those particular criteria are not met, then I should be able to roll back it to my previous releases. Now, once my application is being deployed, I should be able to see all my applications which are deployed across multiple different environments, the real-time status of those applications, the deployment status, the application metrics, along with all the resources for this particular microservice here itself in a resource group view, wherein you should be able to see different resources which are already being created. For example, let's say the staging environment, right? In my staging environment, again, the application status is missing here. But if the deployment is successful, then you should be able to see the entire application status as well. So these are the real-time status which are being fetched from Argo CD itself, the GitOps-based deployments. So internally, Defron leverages Argo CD for the entire GitOps principles. So whatever benefits that you get with Argo CD, right? What are the operations that you do with Argo CD? All those things can be carried out with Defron. On the top of that, it builds up the entire deployment ecosystem basically. Now, coming back to the presentations, since we don't have much time, yeah. Cool. So, so these are some of the getting started guide for Defron. You can scan the QR code and you will directly land to the GitHub page. It does have, it is an open source platform which you can see in the GitHub and you can install on your Kubernetes clusters. And thereafter you should be able to start your Kubernetes native deployments. Should I move to the next slide? Perfect. So, any questions? Yeah.
When you were selecting the deployment, I think that was a Helm values file that you were showing of like selecting what to deploy. Would that GUI operation go back to Git and put those values back to Git?
Yeah, it will. Exactly, it will. So that's the GitOps is all about. Yeah. Any other questions?
Any other questions?
We also have this Cargo software coming up, which like how do you compare Cargo with this Defron software?
Yeah, so Cargo does the entire image promotion thing, right? It's more towards the image promotion thing. With Defron, you get a lot of other things around the ecosystem as well. For example, the plugin ecosystem which we have seen, right? The deployment windows wherein you can define certain parameters. For example, let's say the Black Friday sale, right? For this particular period of time, you want to block the deployments for a specific environment, that you should be able to create it. Now, if I talk about the deployment flexibility, right? Deployment filters are there, which are the CL-based deployments, CL-based filters, which you should be able to create within Defron itself. There are deployment log configurations, which you should be able to create with Defron, right? So there are a lot of other things which builds up the entire platform here. So in the demo, it's not that, so I don't have that much time for to showcase all those things, but there are a lot of different things which differentiate Defron with Cargo. Maybe we can talk about this afterwards, or you can meet us at booth R13 at KubeCon and we can have a deeper discussion on this. Thank you.
Any other questions? Great. Let's give them a round of applause.
Thank you.
We'll be back with another talk in about 10 minutes. Okay, welcome to our final session before the lightning rounds. We've got Joaquin. He's going to be talking about how you can publish your Kubernetes tool as a GUI on Headlamp. So take it away, Joaquin.
Oh. Is it mute? It's better now. Okay. All right. Thanks everybody for showing up. And my name is Joaquin. I work for Microsoft. We do this project called Headlamp, and this is like the second part of, second part of a talk that I started giving in the last Rejekts in Paris. But before I go to the actual part of publishing, I need to ask who doesn't know what Headlamp is or only learned recently what it is, by show of hands. All right. So very quickly, Headlamp is a modern and generic UI for Kubernetes. What modern means is that it looks good and it's done with all the right technologies, for a controversial statement. And also it's generic in the sense that it's not made for using only with AKS or Minikube or anything like that. So it's, it should work with whatever you got for Kubernetes. If it doesn't, we want to know about it. We want to add it. Sometimes you have projects that only work on desktop, or they have like a text UI or even a graphical UI like Headlamp. And others only work if you deploy them as a service. Headlamp supports both. So basically we want to be where you use stuff, not to try to adapt too much to us. And that means also that you can install it with whatever people are using out there. So we have quite a lot of options there. And the most important thing that is related to the talk is that it's extensible through plugins. So it has a plugin system. With the plugins, you can change many things in there. And I'm claiming that it's an ideal platform for creating custom Kubernetes UIs. We're also 100% open source, so there's no version like, maybe Microsoft has this special version, then we get the trimmed down, stripped down stuff. That's not like that. You get what we are developing. That's the only thing we got. And it's a CNCF project, as you can spot right there in the middle of it. So I was saying that this is the second part of a talk that I started giving in the last Rejekts Paris, so I just have to do a little recap of that. In there I was saying that we have this really incredible ecosystem of tools. We have lots of stuff, as you saw here. And with great tools comes great fragmentation. So in terms of UI and user experience as well, you can see that it's you have this fragmented space where I think it affects, or at least I claim it does, the learning curve. So if you have many different tools, you have to learn each one of them, or how the UI works for each one of them. There is sometimes context switching, so maybe a tool only runs on the web, another one is a command line interface. Sometimes you have to change. All of this impacts really what you're doing. And there is inconsistency, right? If a UI is, it's a text UI, of course it works different than a graphical UI. Even within graphical UIs, you have many different ways of working. Like, for example, if you cannot delete a pod, what happens then? Do you get an error, or do you don't see the option to delete the pod, right? So on top of, coming from that, what I'm trying to sell you here is that Headlamp is a great UI for CNCF tools. And why is that? Is because it's customizable. So like I was saying, you can add new routes, you can add app menus, even if you're using the desktop version. You can change the sidebar, you can change even the logo or branding. We have all that. It has libraries to perform the most common Kubernetes operations. So if you want to list pods, we got a function for that. If you want to do, like scale up, we also have that. And since it's web and desktop, sometimes you don't want to have the same thing in both of them. That's what you commonly want, but sometimes it's like maybe you don't want something to run on the web because it's going to be a shared environment. So we have also ways to restrict that. And we also allow running certain command line tools from that for better integration. And we have stuff like unified plugin settings and all that. So I thought we could look at some examples that exist right now. This is the Prometheus integration. So this is a plugin that we ship with Headlamp. So Headlamp by itself, it doesn't really have anything like, okay, you know, we're going to use Prometheus for graphics, right? But we do ship with some plugins that offer that. This gives users the ability, or vendors, I guess, to say, okay, I want Headlamp, but I don't want the Prometheus plugin there. So in any case, going back to the UI, so as you see, you got in the screen, you can see there is a chart that's powered by Prometheus that shows you the pod, the CPU in this case, and but that's very built into the UI, right? If I didn't tell you, okay, this is the Prometheus plugin. If you don't have that plugin, there's nothing in there that says, okay, you know, this is the functionality that comes from this plugin. It's just we try to integrate things seamlessly. An example that is kind of opposite of that in terms of a seamless integration is the Compose plugin. So we have a plugin for the Compose tool, which translates your Docker Compose manifest to Kubernetes ones. So we did this very simple UI, but this is like its own section, as you see there. The only reason why we don't see the Compose logo is because I was too lazy at the time. But otherwise, it's its own thing. So in here, you know that you're using Compose, right? So it's really up to whoever is doing the plugin to, you know, just show whatever you prefer. And this is another example that is kind of different from the other two, because in this case, what you see there, it's the open cost plugin. The open cost plugin gives you the cost of running your workflows, of course, and it integrates it as a column in several tables. So that table is the exact same table that we show without a plugin. All the plugin does is to insert a column on that table, in that table, right? Yeah, and then we have stuff like, you know, this is yet another case where we have a section called apps, but that's actually Helm charts and Artifact Hub to point to them. So it allows you to install them. We have, those that I showed you before were done by us in the team, but now we have also plugins coming from, for CNCF tools coming from other external contributors. This one is called is for Kubescape, and it's contributed by this I think independent developer called Mateis. He also published another one called Trivy, and we have one that we released last week called about the Flux project. Then we have some work in progress stuff like the Minikube plugin. This is I just put it here even though it's not yet released because it's an example of running a tool that is you know, is the same tool that you run when you run Minikube, but it's running from the plugin. And yeah, so you know, this is not a talk about how to build your plugin. It's about how to publish your plugin. But I cannot really talk about publishing the plugin without talking about building the plugin. So very quickly, and in the spirit of that draw, we have a tool called Headlamp plugin, an NPM tool. So you install that tool, then call Headlamp plugin create. It creates it bootstraps, you know, a plugin for you, and you can go from there. So yeah, you have the docs in there. I won't go into detail. We also have a little VS Code extension that simplifies a couple of things, like getting Headlamp. Our intention is to make it more powerful in the future. Yeah, so once you build your plugin, once you develop your plugin, you have the functionality that you want. Then you have to build it, of course, and you have to release it. So for building it, it's very simple. It's the regular stuff you find in any NPM project usually. So npm run build. Then we have a special command called npm package for npm, and that just creates the tarball with the things that the plugin needs. Normally that's just main.js and package.json. Sorry, so that's the example you see there with the Flux Speeder. All right, so discovering your plugin. Before we go again to the publishing guide, we have to talk, why do people publish plugins, right? Why do they want to publish plugins? And they want to do that because they want other people to use it, right? And now I can tell you that Headlamp in itself, right, it doesn't have any ability to discover plugins. It doesn't list plugins from anywhere or anything like that. This is done by design, more intentionally, because we want Headlamp to be, of course, as clean as possible, but also because, as I said, you can deploy it as a web application. And in that case, it's very unlikely that you want your users to go there, list plugins. Where would they install it? Is it like going to run locally? Do they install it to a server and then it's available for everybody or anything like that? So that means that in terms of plugin discoverability in Headlamp, only the desktop version has that. And it has that because we ship with a plugin called the plugin catalog. So the way that you discover plugins is by using a plugin called the plugin catalog. But like I was explaining before, this is very seamlessly integrated. Every time you install and open Headlamp, you're going to see plugin catalog there. Yeah, so essentially this means that it's a guide about publishing plugins, sorry, but for Headlamp for desktop, not for everybody or for every single use case. Okay, and now we get to it. So how do we publish a plugin? The pre-step is you have to have your plugin released. So you build a plugin, you have to release the plugin. Why is this here as part of the guide? Because right now we only support downloading plugins from 3 places. That's GitHub, GitLab, and Bitbucket. The reason for this is related to security and related to how also Artifact Hub allows you to create repositories. And we'll go there about Artifact Hub. Yeah, so I'm sure everybody's familiar with GitHub, but just to give you an example of what this involves, it's very simple. You create a release, you draft up some nodes, you push the tarball that you did with the npm run package command to that release page. Then you push the tag, or you could have pushed the tag before. It's up to you. This is how I do it. And then you associate the tag with the release, and you press publish. So now it's available on the internet. And you can download it from there, assuming your project is public, of course. All right, so in the screen we have a screenshot of what the release looks like on on GitHub. This is the Flux one, and just has the tarball. You can just copy or download the URL. Download the package from that. Okay, so now your plugin is available online. But we want to bring it to users that are using Headlamp with the plugin catalog thing. And the first thing to do is to create a repo on Artifact Hub. So this means that the plugin catalog actually uses Artifact Hub as a centralized source for all the plugins. Who doesn't know how Artifact Hub works here by show of hands? Everybody knows. Just a second. Yeah, so we chose Artifact Hub because it's not really a place where you push your code. It's just pointing to the code or packages. We have our own package type in Artifact Hub called Headlamp plugin. It allows us to do stuff like having verified packages, CNCF packages, official packages, all that stuff. All right, so how you do it, if you're familiar with it, you just go to your control panel, click Add, then it's all graphical. You just choose the plugin type. It's going to be Headlamp plugin there. You choose the name for your repo and the URL. Of course, at this point, Artifact Hub doesn't know if you own the repo. So for Artifact Hub to know that, you have to place a file called Artifact Hub repo at the root of that repo. And this is in your favorite format, YAML. You have the name and the email there. So that's all it's needed. The next time that Artifact Hub starts the scanning, I guess, it will find that your repo has a file, so it's official. Now it recognizes it. It starts looking for packages inside it. So the next thing is to create a package. Now this is similar to, this is the way that Artifact Hub works for all the package types, by the way. There's nothing new here. And the package types, they have a common base. So they have, you have to give it a name, you have to give it a logo, you have to give it a creation date, a bunch of stuff like this. And then usually they have annotations, annotations that are related to the package type that they are. So in our case, the annotations that we have so far are these four: is the archive URL, the archive checksum, the version compatibility, and distro compat. The first two are easy to understand what they do. That's actually the the URL of the tarball that you push to the release page that I mentioned before. Then the checksum, of course. The version compat is, of course, which version of Headlamp is this compatible with, right? So we have some control there. And then the distro compat, this is a way for us to tell Headlamp, you know what, this plugin only works on desktop, not on the web. Or this one doesn't work on Docker desktop, right? I think we're not actually, checking all of these, but this is like it's a future thing. So you might as well just add these there. Yeah, and this is the full example, for example, for Flux. As you see, it's got all that I mentioned, and it's very easy to understand. Even the logo is just a URL that we push to the main repo. And this is what you get afterwards. So the next time that Artifact Hub scans your repo for packages, it finds it. By the way, you can have your own your repo with just one package, and you place the Artifact Hub package right there, or you can have folders with different packages. Sorry. Yeah, and if you see like the name in there and the description, the repository, which is not very visible there, and the author, this is all stuff that is coming from Artifact Hub. Okay, so there's another part. So this is the guide for publishing plugins, right? It's I think it's super simple, assuming that, of course, you want your plugin published in a public way, and that you're fine with having it on Artifact Hub. Now, some things to consider is that by default, we are not showing all the plugins in the plugin catalog. We chose this for for security reasons. So we thought, okay, so anybody can just go there, push a plugin, saying, hey, I'm Prometheus, and then you install that code, right? So in order to give it a little bit more control, we are only showing plugins that are official on Artifact Hub. The process for doing that, for being marked as official, as far if I remember correctly, is you have to open a ticket with Artifact Hub and say, hey, I'm the owner of this project. I'm actually the person behind this, or the company behind this project. So that means you cannot just, if you don't own a certain project, you cannot claim it to be official from you. And the other way, because we worked on plugins like OpenCost and stuff, the other way is to be in our allow list. This allow list, basically right now it's us, but we're gonna have a process to open it to other people that, that we have, that just basically come to us and say, hey, I'm a real person, not gonna push anything bad, I promise, all that stuff. Yeah, and also for, like I said before, for security reasons, we also only allow downloads from GitHub, GitLab, and Bitbucket. A bit about the technical side of this. So I said that Headlamp does not really list plugins, but the actual plugin download mechanism is in the Headlamp desktop side. This is because otherwise plugins could actually fake a lot of stuff and say, hey, I'm actually official, because I have this official check mark. Yeah. Or they could say, yeah, this URL is, this plugin will download from GitHub for sure, but then you use another URL, right? So this way we actually show to the user, this plugin wants to download something from this place. And you can actually see, and there's no way that the plugins can fake that. Yeah. So what if you want to show your friend your plugin that you just developed and you're not yet marked as official or allow listed in our repo? We have settings for this plugin. You just go to the settings, say, I don't want to see official, I don't want to see verified. Then you see everything, but then it's up to you, and you know, use it at your own risk. Yeah, and if you want to start looking into doing something for your project, we have, of course, the GitHub repo. We have the Headlamp channel in our, sorry, too much cold last night. And on the Kubernetes Slack, you can follow us. And we have a newly drafted contribution guide. So check that out. And also a newly published, like I published this just before the talk. There's now basically what I was talking about in this talk. Yeah, and if you are going to KubeCon, we have a Contribute Fest session for Headlamp on Friday. So it's at 2 p.m. I think. Yeah, and the idea is to just, you know, have a little chat about the project, or you know, make it like a workshop kind of thing, and just bootstrap some plugin, start developing that. This was quite fun in the last KubeCon in Paris. So yeah, we're gonna be there. It's gonna be me and Renee. They're sitting right there. And yeah, that's all I got for you.
We've got a couple of minutes if anybody has any questions. Yeah?
How do you compare this with other tools such as Lens, which I personally use effectively? So will it be like as you know, bigger like Lens, or this is going to be like bare bones, bare minimal?
Sorry, what is the question about Lens?
Question is, how do you compare this with Lens? Lens
Yeah.
is also another tool which we can run, right? So
yeah,
how do you compare?
So I haven't used Lens lately. I've tried it before. Lens, as far as I know, and again, I don't know if that's the way it still is, but it's desktop only. I was saying that we are desktop, but also web. So in there's a lot of flexibility. I guess it's not for everybody, you know, to use it, especially if you're just an end user in that case. But I think the ability to say, you know, I want Headlamp, and I want this couple of plugins, and I just deploy all of these to my clients. This is something that we allow, and I don't think Lens supports that. Now, last time I checked, I couldn't really understand if Lens is 100% open source or not. I think I've read some things about their, you know, going to a mixed model or something, but yeah, I don't know. Otherwise, of course, it's both are Kubernetes UI, so both, I guess, manage Kubernetes. It's at some point, I guess, it depends on each other's preferences, and yeah.
Yeah, I can follow up a little bit more on that. So I'm one of the founders of the project and the project manager. But you know, when we started this project, we were actually looking, like the Lens website said it was open source, and we looked for the source. It wasn't there. This was like back in 2018. So basically, we were, because we wanted to have a starting point, and we wanted to work with somebody else. And so we started this. A few months later, it was open source, and recently it's been unopen sourced. And so I would say the open source aspect of it is not very stable at this point, which, you know, for us is very, very important. If you're going to have a community tool, you have to have some kind of guarantees. We got this into the CNCF because we think that's a good home for such tools. I don't think you'll find Lens there. And as far as features and functionality, we have been, for the last few years, we've been looking over at all the other tools, and we think we have pretty much at least feature parity. But with the plugin system and the plugins that we've added, we think we are now fairly, past that functionality. So just to be clear, I think, we were definitely looking at them. We were frustrated with the open source aspect of Lens, for example, but there are other good tools like, what is it, K9S and stuff is really cool for the command line, but we're web-based. So yeah, we feel very comfortable with the functionality where we're at and, being a community tool, so.
Great. Any other questions?
So am I thinking about this the right way or the wrong way, that if Backstage is for developers, this is the ops side of the house?
This is the Kubernetes, I guess, focused. But so there are similarities with Backstage and Headlamp in that both allow these plugins that are made very similarly and all that. However, like you said, Backstage is a portal for developers, so you find about your services there and all of that. It also supports Kubernetes, but there is no special UI for Kubernetes. We are focused on Kubernetes, right? So you don't go there to create a developer portal. I guess you can create a plugin that kind of gives some functionality that would overlap with what Backstage does. As in Backstage, you can also do functionality that would overlap with what Headlamp has as its base. But we basically focus on providing everything that you expect to find in a Kubernetes UI. So you're going to find the workloads, the configuration. You're going to find ways to scale things up if you want to do that manually. So that sort of thing, right? Since you're asking that, we published today a way for integrating Headlamp inside Backstage. So now, because I said in Backstage you don't have really like a dedicated Kubernetes UI. For that you have some stuff around. So now with this way that we integrated it, you can install a couple of plugins in Backstage. And then when you go, for example, to one of the services that is a Kubernetes service, you're going to find a button that they already support called Open in Kubernetes Dashboard, but it doesn't have really to do with the original Kubernetes dashboard, right? It's configurable, so our plugin sets that up. So when you click it, you go into a dedicated view of Headlamp, just slightly different, right? So it looks a little bit better when it's embedded in. So it's really embedded in the UI, and then from Headlamp, if you're looking at, for example, a pod, and you want to see that pod then in Backstage or the service in Backstage, we also have like a backlink, so you can click it and you go into the Backstage area of that. Yeah. So it's like a cross-linking thing. So I think with this solution, we're really curious to see how people that are currently using Backstage and want to have like a powerful UI for Kubernetes and vice versa will respond to this.
There's a follow-up to that actually. Sorry, but the plugins, can they be write? So can you have an input box that then applies to Git somehow? So if you wanted to make a config change to a config map or something.
Yeah, we have a way to run CLI tools. We usually are very conservative in terms of what we open to the plugins in terms of functionality. So we have that. I think we have it enabled only for Minikube and a couple of other commands. And you have to run a special flag, right? But nothing really impedes that you just say, okay, I want to run any command. And then your plugin can say, hey, run this command for me. The command is git with whatever these values come from whatever the user wrote here, and I picked it up, right? So I think we have a very solid and flexible solution.
Last one.
Chris is going to complete my...
Yeah, I just want to make a point to that. That's a perfect example of, using Headlamp as a tool to kind of unify the CNCF tool set, right? A lot of people were looking at, it was kind of confusing between Backstage and Headlamp, what should I use? They're complementary. And if you set them up and the tool and the projects work together to get that right, it's actually a really good experience. And so that's kind of the point of the talk we gave at Paris and the talk we started out, what we started off with here. And we're going to be working on that. We hope everybody else does too. So.
Great. Thank you so much. Let's give them a round of applause.
Thank you.
Really great stuff. We'll be starting off with our lightning talks in just a few minutes, so stick around.
Probably works better if I turn it on, I guess. Hello, everybody. I'm Duffy Cooley. I'll be your host for the lightning talks coming up. Our first lightning talk is going to be by Laurie LaRusso, talking about 6 Degrees of Kevin Bacon, OSS edition. Give Laurie a second to get set up. This is always my favorite part because people sign up for this just to do this at the end of the day. This is not a thing that we schedule. There's no review committee. It's first come, first serve, and we always get such an awesome dynamic set of talks for all of this stuff. So really looking forward to it. Raise your hand if this is your very first Rejekts conference. Wow, that was way more hands than I was expecting. How many people in that same set were here yesterday? Right on. So this is maybe your first day at your first Rejekts conference. I have to tell you, this is my favorite conference because you get to hang out with all of the amazing people who are here and actually spend some time connecting with them. Usually at KubeCon, we're all so busy running around doing all kinds of stuff that we really don't have time to connect, and that's why Rejekts, in my opinion, is an absolute requirement. Really puts me in the right headspace for the next 3 days. So. Yeah. Andrew, that guy with the orange hat, Andy Randall.
Andy Randall?
Yes, he's probably right here. See that guy with the orange hat? Woo! You ready? Are you ready?
Yeah.
All right. Let's kick it off with Laurie.
All right. Hey, everybody. Thanks for hanging in to the very end for us lightning talks. So today we're going to talk about the 6 Degrees of Kevin Bacon Open Source Community Edition. So first, I was pretty surprised this talk got accepted because I was like, does anybody even know who Kevin Bacon is now? So who is Kevin Bacon? He is an American actor and singer. His first film credit was in 1978. He has 110 acting credits and counting. You might know him from Beverly Hills Cop 4, A Few Good Men, Tremors, one of my favorites, X-Men First Class. But for me, the quintessential Kevin Bacon is a man that just wanted to dance. And so this is Footloose, movie from the 80s. I'm aging myself, that's fine. But you couldn't dance in this town, and by golly, he made it happen. Look at those happy faces and those 80s clothes. Yikes. Okay, so what is the 6 Degrees of Kevin Bacon? So it's an assumption that anyone involved in the Hollywood film industry can be linked through the film roles of Kevin Bacon within 6 steps. So because he's been in so many roles and he's put the work in, you can just get to him. And today, I postulate that the same can be true for you in the world of open source, but you have to put the work in. So again, if Kevin Bacon can be in 110 films and counting, what can you do this week, starting here at Cloud Native Rejekts and moving on to KubeCon and beyond, to become Kevin Bacon and get your 6 degrees? So first, I want to say you got to network, right? But network on your own terms. There's no right or wrong way to network. You got to know yourself and what you're comfortable with. Are you comfortable just walking up to somebody and starting a conversation? Would you rather be in GitHub, doing an issue or just, commenting on something? Do you love to go sit at a table with a bunch of strangers you don't know and just strike up a conversation? What about email? If a speaker leaves their email, are you willing to just email them? Is that your comfort zone? Then we've got our socials, we've got our LinkedIn, our Blue Sky, the one that shall not be named anymore. And then, of course, organizations like the CNCF give you multiple opportunities to network at your own pace, right? So you can join the Slack channel. You could just see what's out there, check out all the different hashtags, all the different groups. You can be on mailing lists where you just literally receive the emails to see what's going on with the community. One of the things that I think is highly undervalued is the calendar. So every project has a calendar meeting, so you can go to like a SIG meeting, you can go to a project meeting, you can watch the recordings of those meetings, but check out the calendar and see, like, does this work with your schedule? And if not, again, there's the YouTube channel. And then while you're watching the YouTube channel, maybe you find somebody you want to ask a deeper question to because you weren't there live. So network on your own terms. And it's all about the vibe, right? So, honesty and transparency wins the day. Like, I know I'm not everybody's cup of tea, but that's okay. I'm going to be honest with you. I'm going to tell you how it is. But when you go to a talk and you want to strike up a conversation and you want to send that email, you've got that LinkedIn request where you have to leave a message because I have it closed down, instead of saying, like, I loved your talk, let's be honest, all speakers are like, thank you very much. Pick a point of the talk that you really liked and express your value. So, I loved your talk, specifically the part where you called out the value of using one open source project over another. I use X and I'm super hesitant about trying another project, but what you said really hit me in the fields. And now I'm going to think about trying something else, right? So that honesty, that transparency, and that digging in a little deeper than just saying, I loved your talk, is going to be able to start that conversation that you maybe wouldn't have started before. And the whole thing is, like, we want to be in that bubble. And while it might not look great on this big screen, we want to have that private conversation. And if at first you don't succeed and they say, you only get one chance to make a first impression, no, try and try again, okay? So, like, how many times have you been Homer Simpson and you've, like, walked up to a group of people and you tried to interject and you couldn't, and then you just back away and you're scared? Don't worry about it. Try again. Again, go back to the networking on your own terms. Now, I'm speeding up because I got my 1 minute mark, but, and there's tons of non-technical opportunities while you're here. So I want to thank Troy Connor for reminding me of this Maya Angelou quote. Said, I've learned that people will forget what you said, people will forget what you did, but people will never forget how you made them feel. So how many of you have dogs, right? Go to the Pet-a-Pup and start talking about your dog. Share a picture, and you never know what that conversation can lead you to. Network on your own terms. If you are comfortable petting a puppy because you are so stressed out with all the other things going on, that is an awesome opportunity to meet new people. And lastly, just be the Kevin Bacon, right? So you can't just expect to get out a bunch of things if you're not willing to put in the work yourselves. So introduce yourself to people. Bring people into your network. This is your job just as much as, like, for you to get stuff out is to bring people in. Talk to the maintainers. Talk to the people working on the projects that you're working with. And if I can give you any advice, talk to this guy right here, this little curmudgeon. Talk to George this week. He's the project guy. He's going to help you. He, in my mind, is Kevin Bacon. And so, yeah, thanks so much for listening to my talk.
Thank you, Laurie, and I completely agree. I mean, here at this event, if you're not taking advantage of the hallway track, if you're not meeting each other, building your network, this is what it's all about. Andrew is up next. I would like Matthew Benoit to come on over here and get mic'd up.
Okay.
This is your next guy here. All right, Andy, anytime you're ready.
Okay. All right. So, first of all, who's heard of Flatcar? Okay, most of the crowd. Who's actually used it? Okay, quite a few folks as well. So I'm going to give you a very quick update of where we're at with the project. So for those who aren't familiar with it, Flatcar is a Linux distro optimized for containers, which means it has a minimal set of packages, it's immutable, has a cloud native style declarative provisioning model, and it comes with automated updates. We've been putting a lot of emphasis on building the community over the last couple of years, and as you can see from the chart, well, it's a little bit hard to see on the black background, we're seeing a lot of growth, a lot of traction, and in fact, we've got well over 50,000 contributions from over 200 companies into the project. This is really, really transitioned from something that started as very much something within a little startup called Kinvolk in Berlin, and after we got acquired by Microsoft, has grown into a true kind of community movement. And that was recognized, and we're very, very excited with the fact that Flatcar is now an incubating project within CNCF, and we just announced that a couple of weeks ago. And what this means for the community is, it's under a vendor-neutral home, so everyone can participate without worrying about, which vendors have influence. And it also shows that it went through a due diligence process, which was pretty tough. Duffy actually was one of the people that led the due diligence process and really looked into adoption and governance and all those kind of things. And the outcome of that is at incubation level, that means it's considered by the CNCF to be stable and successfully used in production. Now, from our perspective as the project, it also means that we get access to CNCF resources and can start to think about where do we take the project next and where does it go in the future. So as we think about that, some of the big themes that we're looking at are security, how we evolve the architecture to be more composable, how we focus on the Kubernetes community, because Kubernetes is the #1 application for Flatcar, and how do we think about what comes beyond Kubernetes or beyond containers and the next kind of generation of workloads that we're expecting to see. First of all, on security, I want to say that development team behind Flatcar has done an absolutely incredible job. Just in 2024 to date, over 2,300 CVEs are patched. So, those are all vulnerabilities that folks are getting automatically updated and automatically applied, and we're within the embargo community, within the Linux security community, so we're generally getting those out very, very fast, and particularly when there are high severity ones, we get out releases very quickly. But this isn't going to be the end of the story from a security perspective. We've done a lot with supply chain, we're evolving that. We're going to work on runtime, we're going to evolve how we do updates, all to drive that. On extensibility, composability, we're adopted a capability called system extensions, which is basically like containers, allows us to overlay files. We've already applied that to alternate runtimes, improving support for how we enable OEM variants, and allowing folks to customize their images. One of the ways that we're applying this most actively is in how we do cluster API. So moving away from using image builder to build a tightly coupled image, combining the kube control plane with the OS, to using a separate sysext, which you load on at boot time, which allows you to use stock distro images and kind of have it loosely coupled and allow you to update independently. On evolving workloads, we've added support for ARM, including Cobalt within Azure, maybe RISC-V in the future, GPU support integrated, more production environments, lots of clouds that we've added support for, and WebAssembly. We have sysext system extensions available for various WebAssembly runtimes. So that's it. We're community-driven, foundation-governed, enhancing security, extensibility, and evolving as the technology evolves. Thank you.
Next up, we have Matthew talking about you can score it shift down or and versus shift left. You ready, Matthew?
Yes.
Chevet, please come over here so we can get you mic'd up.
Cool. Can I start? Wonderful.
Take it away.
Thank you for having me. I would like to talk about Score, brand new CNCF sandbox project, just graduated like 4 months ago. I don't know if you're familiar with Score, but the goal of Score is to provide an abstraction to Kubernetes for your developers, right? And the goal is to show you live demo about the capabilities and what you could do with that. So here, let's say I'm a developer, right? I have a Node.js application talking to a database. So I will do some very good stuff here. I will debug in my inner loop, in my local environment. Maybe I will have a Docker file. Maybe I will have some help to have a secure Docker file. But at the end of the day, I want to containerize my application and ship that at some point, right? So that's, again, my developer inner loop. Here comes Score. The basic Score file you could have to describe how you want to deploy somewhere your workload is this file, 6 lines of file, right? And I don't know the technical detail of where it will go. But what I know is, for example, I could use one of the implementation of the Score project, Score Compose, and I could generate from this Score file a Compose file. If you're familiar with Docker Compose, that's a good way for test locally a container, right? So for example, I could generate from this Score Compose implementation a Compose file. Very simple, right? Based on this Score file, I have this simple Compose file here. And I could, if you're familiar, use Docker Compose up, and that's it. I have my container running locally. And here it's pretty basic stuff. You will say, yeah, Mathieu, basic stuff, why having an extra layer and Score? I was too fast on this guy, but now I could use another implementation, Score Kubernetes. On this exact same Score file, what I could do now is generate a Kubernetes manifest, right? So here it's a very basic deployment file. Nothing crazy, right? I could write it as a dev, but the goal is not to do that, right? So here I will complexify, if I could say, my scenario. Now what I want is, for this application, I want to expose this workload via a DNS. Where is it? In AWS, in Google, I don't know. And what I want is also talking to a Postgres database, right? Where it will go in production, I don't know, right? I'm not an expert, I'm not a cloud engineer, I'm not doing Terraform and stuff like this. So here comes a very more complex Score file. You could see same Score file, but now I have more environment variable. I know the port of my workload. I know also how to inject the connection string. Someone will generate for me at some point, and I will inject that in my environment variable. And here comes the description of the dependencies I want. I want a Postgres database, please, and I want a DNS, because at some point I would like to expose my maybe public or internal DNS workload. So that's the kind of description I will have. And here, now I could use again Score Compose. And guess what? I will be able to generate a more complex Compose file. Do you want to ask your developer to write this almost 100 lines of code to describe a Docker Compose test environment with a Postgres, et cetera, et cetera? Maybe not, right? So here, we are generating from the Score file all the complexity of Docker Compose file. And guess what? I could run Docker Compose up, right? And here, I will have, when it will be ready, here, if I look at Docker PS, I will see my Nginx exposing the DNS, exposing my workload. I will see my Postgres database and my workload, right? And I could test it. I could list the resources generated by Score Compose, and I could test my application. Yeah, it's working locally. Fine, let's move on. Now in the CI/CD pipeline, maybe at some point it will have a Kubernetes cluster. So here I want to generate from this exact same Score file all the complexity in Kubernetes, right? Same approach. I will have now a more complex manifest with a lot of manifest Kubernetes resources. Look at this. It's 200, almost 25 lines of Kubernetes stuff, right? Because what? Because I have an HTTP route. I have an ingress, maybe. I have a service. I have a secret, a config map, a stateful set for the Postgres database, et cetera, et cetera. It's complex. As a developer, I shouldn't care about that. So here, we are generating that for me. And I could kubectl apply this manifest. And look at this. I have this because maybe locally I have access to a cluster. So I could look at the resources generated. I could list the resources dependencies generated by Score Kubernetes. And I could test my application, right? And it's at the end. So I hope you enjoy the demo. There is next step with that. You could bring more dependencies, Dapper State Store, Redis, Kafka topic. You could bring your own provisioner and implementation. And yes, you will shift down to the CI/CD pipeline. Your developer shouldn't do the kubectl command I was doing. You will put that in CI/CD, and you will target the different environment. Ephemeral environment, dev, staging, and production, all of that abstracted. They will focus on their code and the description of what they want. Thank you very much.
Thank you, Matthew. Now introducing my good friend Gervais, who's going to talk about building ML Ops pipeline with Dagger.io and GitOps.
All right. So hi, everyone. First of all, it has been a wonderful venue, and this is my second Cloud Native Rejekts, and I've really enjoyed it a lot. So thanks for the opportunity for this lightning talk. So I'll probably just dive right into this issue, right, with machine learning. So whenever we talk about any sort of a Docker image or a container image, it's particularly packaging together all of your source code and all of the system dependencies related to your software. And while it's very easy for now you to be able to deploy this to Docker Hub or any other container registry for that matter, one of the major issues when it comes to AI is the fact that there are so many different components and all of them are being stored in different locations. So if you look at the data scientist and the code that they're writing, it will be in a Jupyter notebook. Now, when you actually push this code to GitHub, your source code files will be on a GitHub pipeline. Of course, with machine learning, whenever you're training your models, there are a lot of model artifacts, weights, and biases. All of these are generated, and these are typically stored on an S3 bucket. And finally, when it comes to documentation or your data sets, they might be stored inside of a data lake or in some other place. So what basically that means is that whenever your teams are actually trying to build applications with machine learning, there are all of these different data sources, and you have to try and pull these different sources from different locations, and it just adds to the complexity. So the question is that do we have a way to be able to actually solve this problem so that we can store all of the different major components of AI, which is the data set, which is the model weights, and the actual model code itself in one single location. And that's where GitOps, which is an open source project, is used to actually help with that. And the way that it allows you to do is that it allows you to package together all of your different components of your machine learning code into one single package with the help of this new type of code, which is called as model kit. So what is model kit? It's an OCI compliant packaging format. So you can basically just define a kit file, which is like a Docker file, and have all of your components for your machine learning logic, which includes the dataset, the code, and your actual model weights, all being basically skimmed down into this model kit, and then you basically package it together into this model kit file, and you can now upload this to any OCI compliant registry. So whether it's Docker Hub or any other private compliant registry that you might want to use. So this just enables you to improve the developer tooling for your entire AI modules very easily. And now, of course, one of the another issues is that 80% of the models never actually make it to production. So how we can do that? So we can also automate the deployment of these GitOps files with the help of things like Docker Verse, where you can very easily just put it as part of your CI/CD pipeline. And the way that you'll do is that you just install GitOps, you create your model kit file that will package together all of your model resources, including the dataset and the weights, and then you initialize the Dagger module, and then you define your pipeline functions within Dagger and integrate with any CI/CD tool that you might want, and then you can very easily automate the deployment to the registry. So here, I know I'm probably out of time, but here what I did was that I simply just created that kit file, and I deployed it to Docker Hub. And this is this is my Docker Hub image, which is basically this machine learning code that has everything inside of it. So that's how you can very easily automate and improve the developer experience while building machine learning models. Thank you.
Awesome work, awesome work. All right, next up we have Ralph, who is going to be talking about a new hypervisor, I think. So Hyperlite, what the heck is that? And Prakash, you'd like for you to come over and get mic'd up. Take it away, Ralph.
All right, let's
Where did
see
you
if
get this
all
picture
works.
of me, by the way?
No, of course it doesn't. Yes, it does. Okay, great. Hyperlite process VMs. What the hell is that? Actually, what I want to do is take a quick survey through the next 5 years, because we're at a weird position where really everything in the world is going to explode. it's ironic that we're all here and we're still containering and we're still Kubernetesing and all this great stuff, but in fact what we're doing is refining everything that's already in the platform. And we're trying to get more value out of all this, do things faster, easier, and the whole thing. But we can't keep just refining the margins. We're going to have to find new things that actually change the model. And so, like, in that sense, containers are done. Like, but they're not finished. Right? We're still going to do work on them. They're still fantastic. They're not done as a workload. They're done as a stable platform. Everything else is going to be tailored around the margins or the ecosystem around them, how you deliver them, how you execute them and get them ready faster and so forth. The future is actually already here. We can see it everywhere. And so this is really about how cool it's going to be as engineers. Even though economically it may be iffy, depending on where you are, there's consolidation in the industry, things like this. As engineers, the future is so cool. Can't even believe it. We got new ways to run code. Duffy here has got a t-shirt that leads part of the way. You got ePBF. Like, kernel code is faster. Let's do that. We can add value by removing speed from the system there. You've got unikernels. Everybody, unikernels are back. Have you heard that yet? No, you probably haven't. There's unicraft.org if you haven't seen it. There's NanoVM, which is really, really great. There is the Hermit project, which is fantastic. And all of the stuff you can do with Rust VMM and those projects are great. There's also this WebAssembly thing. You probably heard some marketing buzz about WebAssembly stuff. Maybe just Duffy, you and I probably owe you a beer. Okay, but there's also things like process VMMs, which don't even boot at all. And it's like, wait, what? Wait, don't boot at all? Like, what is that? Right, so that's part of what the heck. Right, Hyperlite is a new project that we just released, not yesterday, 4 days ago, 5 days ago, something like this. We intend to file the PR, to submit it as a sandbox project as soon as we can breathe in between the days this week. So we'll work on that. But it's really a process VM, which is a really new kind of VM. It essentially treats virtual machines as the underlying virtual machine, KVM, Hyper-V, whatever you might be using, as a way to create an isolation boundary, but only for what is essentially, not in detail, but essentially a process. There is no operating system in there. There's no file system by default. There's no networking by default, any of that stuff. It's just a process. But you can be fully isolated, and we can create a new one of those from cold in 1 to 2 milliseconds. 1 to 2 milliseconds. And if you can configure the size of them, they're only the size of the process you need to run. You can actually pool those efficiently on small machines or older machines. And you can actually, when you have it warmed, the overhead call latency into a process across this boundary is on the order of 60 to 100 microseconds. So you can actually pull them and build things really, really efficiently. They are not completely distributed, full distributions of an operating system. Like I said, unless you bring file systems or networking and arrange that with your host, you can't just do that. But if you need to compute something safely in a hot path of a high load application or service, process VMM, something like the approach of Hyperlite, is what you want to do. So I want to show you a quick demo just to give you an idea. So if I can figure out where that is, I'm going to show you this. And I've just gotten a 1-minute call. This is a 50-second demo, so hopefully it works. First, we're going to run an application with a cold endpoint. And so every single one of those functions you're seeing is a brand new VM. Every single one, and gotten rid of after it's done. Now that's pretty fast, right? That's pretty fast. Let's do a warm one. That uses the 10 VMs we had in the beginning. And we've just dropped down quite a bit, right? We're averaging at 300ths of a second there. But we want to get a little faster. So we're going to run it again, and we've just dropped to 1.8 or so milliseconds there. Now we're going to actually scale it out. We're going to hit it so hard that we have to create more VMs on the fly, 1,000 over connection. And I want you to look at that. So we are now serving, in this call, on average 900 microseconds per request. Each request is in its own hypervisor partition, its own micro VM. And they're all recycled. There are 48 VMs created in this demo. The overhead was 60 megabytes of memory. That's it. 60 megabytes of memory. So if you like all these projects, open your brain, go jump on one of them. This is one you may find interesting. Thanks very much.
Awesome work. Thank you very much, Ralph. Next up, we have rethinking ephemeral environments in Kubernetes. And I'd like to see Michael Levon over here to get a mic up. So Michael, are you here? Am I saying your name wrong? Are you not here? All right, I'll figure that out. You may take it away.
Okay, thank you. Hi guys, this is Prakash, and this is probably going to be a little lower in the tempo because I'm not used to the tempo that Lori followed. So rethinking ephemeral environments in Kubernetes. So ephemeral environments have been in existence since the age of Stone Age. I think, if I may call, from the ages of Jenkins era. So, but how we implement that in today's cloud native ecosystem is what I will be discussing here today. So ephemeral environments, quickly, if I can tell you, they are short-lived environments or deployments that we generally do for cost effectiveness, and they are dynamically created for, let's say, each developer, each feature that you are building, and then dynamically destroyed as and when you merge your code to your release candidate or your staging branches, right? And why exactly do we need ephemeral environments? Because in your organization, you may have different functionalities being built upon in parallel, and you may want to want to isolate all those functionalities from each other when you're testing a particular functionality for those kind of scenarios. What we do is we use ephemeral environments to create a particular feature branch for a feature, and we deploy it across that particular environment, and then we test out that functionality and then finally merge it against other features to do integration testing. So developers can focus on their functionalities while the test integrations and all can be done in the staging branch or the release candidate branch itself. So that's why we need the ephemeral environments. The conventional approach of ephemeral environments, if we are deploying on non-containerized environment, would be just to maybe build your images, build your binaries, and then spin up an infrastructure using a Terraform script or something, and then setting up the configurations, then going ahead and deploying, and then once you do your testing and once you do not need that particular environment, you can go ahead and destroy it, nuke it. Right? But in the Kubernetes approach, what we do is you build the container images. You do not have to spin up an infrastructure, because on Kubernetes side, you can just create a namespace, or you can utilize an existing namespace which is already there and deploy your configurations over there, deploy your workloads, and then once you're done with your testing and everything, you can go ahead and just either delete the namespace itself, or you can scale down all the workloads using any of the tools that are there in the Kubernetes ecosystem, right? So this is how the Kubernetes approach works. It's not necessary to create and delete every time. That's how we did in the conventional approach, but it's not necessary to do that in the Kubernetes approach, because in Kubernetes, you do not have to have a infra cost associated with a namespace. So a namespace is a free thing you can have. You just have to scale down your workloads which are there in your namespace, and you're good to go. So you let the cluster autoscaler do all those descaling activities, and you can have your Kubernetes environments reused when you're using the ephemeral environments. That was about it. So we have implemented a lot of scenarios where we have created these scenarios where ephemeral environments can be reused by the developers. They can be engaged with a lot of other functionalities as well. We are at booth R13 at KubeCon if you want to visit and discuss any of those scenarios of yours. Thank you.
Next up, we have a kind of a change of program. Got some awesome rap coming up with my friend Lee.
What's up, people? How you doing, Rejekts? I love coming over here and then reconnecting with everybody, talking about DevTools and productivity. I think like we've been opening. How many terminal shells do you think? You know, we got an estimate. How many people we have at Rejekts this year? Is what, 200-ish? You know, maybe. So, does anyone have an estimate on how many times a terminal has been opened? Right, shout it out. What do you think? 2,000, I heard. What'd you think? 20? Cool. Yeah. It's like, it seems like every time, like there's this fundamental thing that we always coming back to when we're developers, right? We think of something, we ideate, we're on the whiteboard, we're hanging out with our teammates. We're like, yo, let's build something. It's gonna be cool, right? And it's funny because then like we start doing infrastructure stuff too, and we start configuring the machine, configuring the systems, and it gets painful. And it reminds me that a lot of hip hop, even you would say the best hip hop, it comes from pain. And it takes me back to a time where I'm just off the subway and I'm heading up to work. Got stand up, right? I'm checking in like CNN. I'm on that schedule first, doing roll call, and we all, for some reason, sitting down at stand up. Now I'm heading to my desk and I grab a banana. I do a git pull, npm build. Got 2 terminals. And the question is, will the loader controller is reaching out further, branch in a tree as it's graphed in a sea of packages, scrolling, searching and crawling. Now the logs are pouring out and it's searching, lurching and stalling. It's pretty clear. This is severe. I mean, the look on my face, a stacked trace with no place on my plan today. I was busy, now I'm stuck. And it's plain to see, I can't work, can't pull one main dependency. What's up with that, right? So, yeah, like I'm done, man. That's my piece. It's like, I love what we started out the lightning talks with. It's like we're all here together, and nothing binds us more together than pain. And Lord knows, we're all using Kubernetes, so it's a little bit painful. So, you know, let's learn each other's names, learn each other's stories, connect up. Let's build something cool together and make a difference. And maybe we can all learn who George Castro is. Yeah. Thank you. Lee Kapili.
Great job. Awesome. Thank you so much. Our next is Matthias, who's going to be talking about using your existing observability as a SIM. So let's give him a second to get set up. The next person I'd love to see is Viprek. If you're here, yeah, come on over. And take it away whenever you're ready. Welcome.
All right, I'm going to talk to you about how your SIM and observability tool are pretty much the same thing. A little bit about me. I'm a solutions engineer at Victoria Metrics. I'm obsessed with observability. I like self-hosting things, Brazilian Jiu-Jitsu, and memes. A bit about observability in a SIM. They're both tools that gather telemetry to interrogate systems. They alert you when things aren't working. What's not working is going to be different depending on the tool. They try to help you be proactive. They try to help you correlate data from multiple sources, and they use similar abstractions like dashboards, alerting, and all those good sorts of things. And it's more than just metrics, logs, and cases or traces, because that's like saying a cake is just sugar, milk, and flour. And they try to prevent the same negative business outcomes, namely regulatory fines, brand reputation damage, and the incidents just suck for both of them. I've bet on both of them. They feel about the same. And again, you have this similar negative business outcomes. And keeping those tools separate is really bad because you end up with a bajillion different agents on all your infrastructure. You have to maintain all the documentation and knowledge for the security and the infrastructure stuff. And during incidents, you end up with like 50 different tabs open and you spend a bunch of time context switching between the different tools. And you could also end up with different teams seeing different pictures of the environment. So these tools are basically trying to solve a lot of the same problems and have a lot of overlap in what they do. So why aren't they there yet? The migrations are really hard, and the tooling hasn't really existed yet, so a lot of infrastructure monitoring has been focused around checks until recently instead of using metrics and logs, and a lot of the time storing logs centrally has been super expensive, so you just end up SSHing into the box and tailing, but that doesn't really work anymore because of distributed systems, so we still have some bad habits to get rid of. When you combine these tools together, you end up with fewer admin tools, you end up with a lower security profile because you don't have multiple agents that need higher levels of privilege to get the telemetry you need out of your environment, and you have developers blaming agents less because there's fewer things to take up resources on your system. Also, if you're in a public cloud, you're not egressing and storing as much data, which are two of the most expensive things you can do in the cloud. Some downsides to this, a lot of the pre-canned SIM tools have a lot of turnkey integrations where you just generate a service count, put in the creds, and everything works. SaaS integrations are particularly hard about this because if you're self-hosting stuff, you can just pipe things to standard out and then or scrape log files. You also have to migrate all the knowledge, so along with things like GeoIP information, compliance information, direct links to CVEs, you also have to make sure the dashboards are arranged the same because that can be super helpful during an incident. Also, you have to make sure the security, infrastructure, and dev teams all get along, and one of them could want to keep some old plugin around that's making everyone else's life worse. The way I mitigate some of these downsides is I maintain a tool called Shiftmon. It's supposed to be an easy mode way to get monitoring and logging set up. And it doesn't only just deploy Victoria metrics and Grafana to make everything easy. It tries to come with a bunch of pre-canned content. So you just run the Telegraph automation, and it will instrument a lot of common applications, and it makes it really easy to add in your own content as well. Just a few solutions that I have integrated right now. Most web server metrics and logs, Suricata and CrowdSec for intrusion prevention, and then Authentic for IDM and Sysmon on Windows hosts. If you want to add your own integrations, antivirus, or anything that logs locally is going to be fairly easy. But doing cloud stuff is going to be a bit harder because you usually have to set up a multi-step pipeline. I'm not the only person that thinks like this. NVIDIA is actually using Grafana Loki for threat hunting and security use cases, and Datadog and Elastic also have products for this. And here are some Grafana dashboards. This is the Sysmon dashboard, so you can see what a Windows host is doing. You could also use that information to see what it's doing on the network. And usually one nice use case for security people is going to be, they usually don't get good metrics, so they'll get the detailed NetFlow information, but it's very hard to distill that into one bandwidth spike to see. One nice thing that you can also check out is anomaly detection. So security people can actually see if their security scans are negatively impacting production in any sort of way.
What a great set of lightning talks. We have one, this is our final lightning talk of the evening. Go on ahead. I'm looking forward to this one. This is access and share fine-grained access of your KA's cluster. So we're talking about RBAC and that sort of stuff, which is one of my favorite things. Let you get set up. After this, we're going to take a few photos, so stick around. We'll do a big crowd photo and see how things go. So,
hello.
Welcome.
All right. Hello, everyone. So in this presentation, I'm going to quickly share how you can basically share access of your Kubernetes cluster with, let's say, another team, another person, temporarily, obviously. So for example, if you have a use case where someone wants to, let's say, debug a problem on your cluster, and you don't want to share admin privileges with them, I built this project called Access recently that can be used to do exactly that. So let's say you want them or another team to be just able to look into logs of a particular pod in a particular namespace. You can generate a kubeconfig file very quickly and share that kubeconfig file with the other team, with the other person, and they would just be able to see logs of that particular pod from that particular namespace. So yeah, these are the use cases. For example, if someone wants to look into logs from Nginx pod from a particular namespace, or if someone wants to have permissions to exec into a particular pod from a namespace for, let's say, 10 minutes. That's also possible. So yeah, let's go ahead and try to look into the demo quickly. So if you see here, I have a test namespace in the first terminal here. Test namespace has 2 pods, and I obviously have other namespaces as well. So what I'm going to do is I'm going to run the command line tool to generate the kubeconfig file that would allow me to see logs of the Nginx pod. And that is the only thing that I should be able to do on that particular cluster. So I am going to run the allow command here. So if you see, I'm saying get, and the resources are pods and pods/log. I can talk about it later if you want to. Log is a sub-resource of pod resource. That's the reason we are providing both of these things. And we are actually specifying to basically fine-grain the things. We are actually specifying that even for the logs, just allow the logs of this particular pod. And we are generating a kubeconfig file, redirecting that to a config file called config. So now a config file is generated. If we quickly look into that, this is your standard kubeconfig file. Now, what I'm going to do is I'm going to export my kubeconfig to the locally currently generated config file, and if I try to, let's say, do anything, kubectl get ns, I would not be able to do this. If I try to see log of the database pod from test namespace, I would not be able to do this. And if I try to see log of the Nginx pod, I should be able to do this if you see here. There are a lot of other things. For example, yeah, I mean, let's say get pods, get services. We should not be able to do these things. In this terminal, I have not set the environment variable, so I would be able to do anything. Yeah, I think that's pretty much it. This is the QR code of the repo. Thank you so much.
Thank you to all of you who chose to put your name up on the Lightning Talks board. We do have some closing thoughts with Divya. What an awesome set. I hope you all are enjoying this evening. Thank you very much. All right.
Great. So, hi everyone. I am going to try and keep this as short as possible, but also please bear with me if I overrun, because my thoughts aren't as free-flowing as normal. I'm severely jet-lagged if you can't tell. So, I want you all to humor me for a bit, and can I have a quick show of hands here for those who have submitted to this edition of Cloud Native Rejekts or KubeCon NA or even any of the co-located events in this edition of the conference? Can I have a quick show of hands who has submitted it? Oh, that's a nice number. I am not going to ask you to raise your hands for this because I am pretty sure that if not in this edition, in some edition, you all would have gotten rejected, and that's not a great feeling to have. But did you all know that in the overall tech industry, only 25% of the submitted proposals actually get accepted? And this thing is even lower when it comes to KubeCon. So as everybody and their grandmother here knows that it's 8 to 10% of the proposals that get accepted at every KubeCon. And unfortunately, that number just goes lower every single year. But even if we look at the ecosystem, like zooming out of the entire process and just looking at the ecosystem, can anyone tell me, this is as to why we have Cloud Native Rejekts, right? Like when we talk about, rejected proposals. But again, talking about the landscape, the ecosystem, can anyone tell me how many projects are there currently in the landscape? A wild guess. Oh, no, that's... Wow, 6 is a very good number. I wish it was, but it was not the case. And unfortunately, none of y'all are close. It's 208 as of today. And that contributor strategy actually did a survey on the kind of contributions made to the landscape, right? And what they found out was that a lot of the contributions were code, but there were also very significant efforts made into the non-code side of things. And as you can clearly see, 65 plus 62 plus 55 doesn't equal 100, at least not in my math. But that means a lot of the surveyed contributors actually also wear multiple hats within the project. And whether you're a code contributor, a non-code contributor, an advocate or a content creator, all of us in this room really are a part of a wider ecosystem. And why does this matter today? Why am I closing out this conference on such a somber note? It's because it actually leads to my topic for today, which is everything is copy. Now, I know everybody here is going to stop me and say, dude, everything is copy is really not the right kind of English grammar that you should be using. But bear with me for a bit and understand when I say that everything is copy, I really do mean that everything that you bring to the table, whether it's your skill set, whether it's your perspective, whether it's your background, whatever, your experience, everything matters to the continuation of the next decade of this ecosystem. Because really, we're all in this together, to quote High School Musical, whichever version I watched while coming here. So we're all in this together. And this does not mean that there's no Cloud Native Rejekts London, because I am pretty sure if I say that, Benazir and Andy will not invite me ever to the next conference as well. So there is a Cloud Native Rejekts London. Benazir has already started planning for it. But there are no rejects when it comes to the Cloud Native ecosystem. There are just opportunities that are waiting to be explored. There are just perspectives that need to be brought to the table. And there are just viewpoints that haven't been heard yet. So as someone who has been on this show floor for quite some time, what I would like for you all to take away as the CTA for this talk would probably be that as you head into KubeCon, try having as many conversations as possible. Laurie, earlier in her first lightning talk, actually alluded to this. Have as many conversations as possible with as many people as possible. And you could find your next opportunity. You could find the next place that you want to contribute to. This is one area that I'm particularly passionate about, so I'm putting it up here. But this need not be the thing that you want to talk to. Or you are passionate about. So speak to as many people. Maybe you'll find your inspiration there. And as a part of the ecosystem, I would be remiss if I do not mention my company and where we are over the next couple of days. So if you're interested in continuing the conversation around open source and the projects that we build, you can scan the QR code here and chat with us. We're happy to help and happy to always chat about anything open source and anything cloud native. So that's it, and thank you so much for your time, and I hope you've had a wonderful conference, and I hope you have a wonderful week. Thank you.
All right. That is the end of our program, and I want to say, to Divya's point, every one of you, I'm so glad you're here. You're absolutely welcome here. If you feel bashful introducing yourself to people, go to people who don't look bashful and have them help you, right? Like this room is full of people like that, and you're going to find tons of those people at KubeCon. So what I'd like to ask next is if you could all just kind of come down into a crowd. We could do like one big selfie to do a big send-off, and it would be awesome. So come on all down into this area. Yeah. Awesome. Right down here in the, not on the stage, because that's going to be very hard for me. Yeah, down there, yeah. Gotta give this guy something to work with, you know. All right. Yes. And look at all those awesome faces. You're doing great back there. You're doing great up here. All right. Should we do like a big silly one? Should we do a big serious one? What do we think? All right. Woo, that's a huge crowd. All right, 1, 2, 3. And again, now let's do the silly one. Big arms, big craziness. Jump in the air if you want to. Let's do it. Woo! All right. Thank you all so much for being here.